presenting a paper on one of the case study which we have done as part of our support to the industry. So it is one of the typical problem associated with the vibration problem. So how we have gone to the mitigation strategies and how we have gone to the full scale investigation combined with the analytical investigations. So that gives a support for the industry to come out with a strategy for mitigating the vibration. So just before proceeding that, just for the benefit of the audience or the students, I just want to introduce this SCRC, that is a CSA Structuring Center. This is one of the 8 national laboratories under the Council of Scientific and Industrial Research. And in our laboratory, actually, we have got a lot of main thrust areas. You can see here a lot of thrust areas are there. So mainly divided into from the materials aspects to the structural aspects, and elaborated with almost like 10 laboratories. So with the different aspects for testing of the materials, advanced materials laboratory, seismic testing laboratory, where we have the large scale testing, earthquake testing facility is there, 3D differential table. So, and the panic and fracture laboratory serving the different industries, including the automobile industries, rail industries, everything. And special and multifunctional laboratory where we are doing a work from nanocomposites level to the macro level scale investigations, and the studies are being carried out for the nanocomposite based self conductive material kind of things and all we are doing it. And a steel structures laboratory and a structure health monitoring laboratory where I'm associated with having that laboratory where we have got the several facilities established in that laboratory for health monitoring of different types of structures, and a theoretical computational mechanics laboratory, and we have got one unique facility of tower testing and resuscitation. So just opposite to the airport in the Chennai. So where tower testing can be done in that laboratory, and we have got the wind engineering laboratory where the boundary layer internal has been established, where we can do all the wind scale monitoring distribution for the different wind load effects on the building, so that we can come out with the wind distribution along the structures, particularly for the different types of structures. So this is about the laboratory. So I'm not going deep into that. Just to introduce, I just want to give you a brief. Not going on.
So, check out the screen.
So these are the different facilities available with the different laboratories. As you see, from advanced testing laboratory where the wind tunnel that large scale facilities are there, and the boundary layer wind tunnel that testing laboratory, panic and fracture laboratory, all the things are there. And at SFML we have got several facilities. Mainly for the vibration testing, we have got the multi-exciter system. So actually, this is particularly for the civil infrastructure facilities where these are the aerodynamic shakers, which is different than the normal model shakers, where these shakers are the reaction type mass shakers. So these can be oriented and placed on the structure, and then it can be excited on the structure, so that the reaction the excitation will be passed on to the structure. And we have got the multi-channel data system from high speed, low frequency range to the high frequency range, where from low frequency vibration measurements to the high frequency vibration measurements can be carried out, mainly for the wave problem studies effects and all, and fiber optic integration modules combined with actuators, all the things. And recently, a couple of years back, we have established a 3D leather top vaporometer. This is again a unique thing. So first one available in India, I can say that. So where it can excite up to, it can take the measurements up to 25 megahertz range of measurements, so that it can be used for the low frequency vibration measurements. So to high frequency wave propagation studies, so that it can be measured with very high depth to the very low depth scanning can be done using this vibration measurements, where we did several studies on the composites and structures where the structure can be excited. So you can see clearly the defect identification the structures is in this with the 3D scanning parameter. So when we exhibit with the feature patches with the small damage, so it can clearly identify the damage in the structure is in the high frequency water pressures. This is just about the SHF which is available in the laboratory, and coming to the topic which I am intended to present here. So you can see the many of the structures in the infrastructures, they are very dynamic in nature, and they are subject to several dynamic loads. And due to that, the structures will be experiencing very high amounts of the dynamic loads, and which are not considered in the design stage, and that may lead to the failure. The very famous failure you can see the Tacoma bridge, where the bridge opening has gone into the failure mode, because even with the small wind gust loads. So this has changed the entire scenario of considering the dynamic loads in the structure, particularly due to the wind load effects and all. And so the dynamic testing why we do is to mainly to determine what is the peak levels of vibration, and understanding what is the frequency levels in the structure, and the different model characteristics evaluation, and of course to validate the finite element models update and look at the dynamics of those things. And coming to the dynamic testing process, generally we adopt two kinds of things. One is the ambient test, where we measure the vibration due to the ambient effects on the structure, which are coming due to the traffic, wind, or wave motion, or the seismic excitation, so ground excitation and all. And most of the structure are being studied using the ambient vibration conditions only, because we cannot excite the structure, particularly the bridges or the power plant structures or the wind turbines and all. So we have to depend on the particularly on the ambient vibration mode test, and other vibration mode test is on the post vibration test, where the component level test can be done using that. And even for the structures also, like bridges, we can do in the post vibration test, where we can use different kinds of excitation systems, starting with the impact excitation using the hammer or the droplet type of excitation, or the pre vibration test, where we can use the realization test, where we can pull and release the structure, and we can use the vibrators to even do the excite the structure. So where we can place different kinds of vibrators, starting with the mechanical vibrator, do the electrodynamic shakers, or even if you want to go with the low level of vibrational studies, you can use hydraulic shakers. But the main drawback of taking these onto the structure is the difficulty in mobilizing and then exiting the structure, because when we want to exit again, we have to stop the operation and service conditions of those structures. So we always depending on the ambient vibration studies on the structure. So from that we can measure the different signatures from the vibration, and we can extract the vibration characteristics, and we can evaluate the vibration characteristics to understand how the structure behaves under these different dynamic loads, so that we can understand how the structure is behaving dynamically, so that we can come out with the strategies for mitigating those vibrations. So coming to the particular case where we have got the one kind of a large, I will not go into the detail. So one of the large structure in the oil refinery, so they have got a very typical problem of vibration. This is one kind of a delayed coking unit in a oil refinery. So where the last product in the oil refinery, the coke, which will be crushed and then transported for the further to the cement industry and all that for the things. And this is a very tall structure, and for operating and maintaining this structure, there is a lift or elevator has been placed along the structure. So particularly actually when they design this elevator system or the elevator structure that has been designed independently away from the structure, so that the structure itself is independent of the DCU structure, that is a delayed cooking unit structure. But what happened is because of the excitation due to the ambient wind conditions and during the process of the lift elevator, so they are experiencing very high levels of vibration at the top, and then they have contacted some other consultancy. So and without further investigation, how the structure, because one is the very tall structure is very flexible in nature, and because of this, it is subject to the very high dynamic effects. So without understanding that, they considered only the static effect due to the wind load, and then just to mitigate that the high displacement, they just introduced some kind of a bracing system attached to the next staircase structure and then the cooking unit structure. Because of this, what happened is this coupled with this, because the delayed cooking unit structure is again a structure which is a very high dynamic, because whenever the coke crushing is going on, it happens to be vibrate heavily, and that vibration getting transferred to this structure, and because of this coupled structure interaction, so this getting reflected into the behavior of this star structure, and then it is again coming to the problem of high vibration levels, and then the lift getting stuck within that, and they could not able to operate this structure at all during the operating stage of that unit. So we have identified the problem, and then we try to understand why it is happening, and we try to understand the different aspects of what is the frequency levels of the structure itself at the design stage, and even at the later stage of what are the retrofitting they have carried out. So in both the levels, we have done the studies, and we try to study numerically what is the frequency and the modes of characteristics of the structure. So you can see the very closely spaced modes have been identified in the structure, and even if you measure and if you model the structure in the cooking unit, the frequencies are getting reflected, and then because they are very much matching with the cooking unit structure and the lift structure, frequencies are very closely matching, and because of that, the resonance getting transferred, and then the structure is getting resonated heavily because of this. So once we identify the problem, so we try to resolve the problem, so that what we need to do is we need to separate the structure. So we have to because the coupled vibration modes has to be separated out. So because of that, I'll just go fast, because these are the field measurements we carried out along the structure. So these are the number of field studies we did. See the 3-dimensional accelerometers. We have conducted the vibration measurements along the lift structure, and even on the DCU structure, or even on the staircase structure. So separately, we have understand what is the vibration behavior of those three structures, and then we analyze those signals, and then understand how the frequency levels are coming out of that. So if we see that the typical vibration signals, when the lift is operating or when the DC structure is operating, the modes are the heavy vibration is getting reflected on the structure when the DC structure is getting operated. So we are getting from almost like a 0.1 G level to the 0.6 G level, that kind of vibration excitation is getting transferred from the DC structure to the lift structure. So even in the frequency levels also, it is getting closely reflected from the DC structure and this one, and the levels, amplitude levels also getting highly reflected onto that. So coming to that, by understanding those aspects on the resonance levels and characteristics of the vibration studies, so we try to resolve the problem using some kind of retrofitting method. So where we want to just isolate the lift structure along from the DC structure, so that the DCU vibration from the DCU will not get transferred to that lift structure, and so that we can incorporate adequate stiffness to the lift structure so that one is to mitigate the deflection limits due to the wind load effects and all, and the structure can be stiffened enough so that the vibration levels can be minimized. So with that, we did some studies with several trial centers and some observation studies have been carried out, and we have come out with this kind of electrowinning strategies where the additional bracing systems have been provided and then connected with the original structure. And these studies we did numerically, and then we have evolved the strategies, and then we saw that the vibration amplitudes and the levels of vibration modes are getting away from that structure. So this has been provided, solution has been provided to the client, and then that has been adopted, and that problem has been resolved by them. I think they might have completed that problem by now. So these are the recommendations that have been given to the industry. So one is to isolate the lift structure from the center DC structure and bringing back the lift structure as it was designed for, so that we need not bother about the from DCU to the transport to the this elevator system, and incorporation of additional bracing system so that it can be stiffening enough for the lift structure so that the vibration problem can be resolved. And in addition to the bracing system, some because we need not provide in all the directions, so that only we provide at the two directions, so that considering the space requirements and the feasibility requirements, all the optimization studies have been carried out, and because they have provided the additional cladding and that is giving the additional load, wind load up to the structure, so that we suggested to provide the perforated sheets so that the wind load effect, wind loading will not be much onto the structures. So this is the scheme provided, and then all the design has been provided to the client. So with that, I just want to finish my talk. Thank you. So any questions?
I have a question. On the frequency you identified, is there any excitation frequency from any rotating or any pipeline enhancing these frequencies?
Yeah, that's what, as I showed you, the DCU is having the very frequencies, which is very close to, because I have not gone deep into that analysis of those things because of still time constraint. So what we observed is one is the lift structure frequencies, another is the DCU structure frequencies. Because when it is connected to the vibration from the DCU is getting reflected onto the frequency of the lift structure, and when it is operated that delayed cooking unit at very high pressure, so the structure frequency of the DCU is very much in the range of this lift structure frequency. So if you see that number of the frequencies identified, it is almost within that range. And there are the coupled vibration torsional modes are there. So that is getting excited, and that is getting very highly reflected at some certain points of time. So the lift is getting highly excited, and sometimes that is getting even stuck the lift also at some certain points of time.
Besides height and wind, there are a number of rotating wheels less than 10 Hz operating speed, and it is likely to enhance this.
Yes.
So number of focal units and other areas of steel plants structures, we have got that rotating units PSI as
Yeah.
So that is the
But here actually there is no rotating bars. Only here the high steam jets will be passed onto the delayed cooking unit, and that steam jets will crush the stone, and then that will be transported.
Okay, there is no rotating part as
There is no rotating part here.
Through the pipelines, sometimes we get less than 10 Hz rotor speed, we get agent excited sometimes.
Correct.
So that's why I was telling you that a number of pumps are operating.
Even while modeling, actually we considered that even for the lift part also we modeled as a lump mass, and then we have considered all the loadings into that.
The excellent studies we have done all this. Thank you.
Thank you, sir.
Okay.
Vibration of other main structures. So, did you study something like that?
Sorry, can you repeat, please?
because you are showing some of the torsion mode, and they will induce fluid vibration, and that needs to be studied.
The torsional modes actually whatever we have shown here, those are not due to the flow induced vibration, that is due to the wind effects and then the
Vibration
free
itself
vibration
will
modes.
induce more aerodynamic forces or fluid dynamic forces, and they lead to further vibration.
Yeah, that's what actually what we try to do is because the lift structure itself is a very flexible compared to the DC structure, because DC structure is a very massive structure. It's a very concrete massive structure. So the structural vibration due to the induced by the lift structure, it will not be getting reflected to the DC structure because of this massive in nature. What is happening is the DC structure vibration is getting reflected to the lift structure.
Okay.
So the flow induced vibration, whatever is coming out of the DCU structure, it will be reflected to the lift structure, but the lift structure vibration is not going to pass on to the DCU structure.
Okay. Right. Thank you.
Thank you.
Thank you.
Thank
Any
you.
other questions? Thank you, sir. So we'll be carrying out the papers which were left from yesterday's session. So I would like to invite Mr. Ansaf Muhammad Ashraf, Rohan P, Devsura Devan, Nitin R, Sudesh Kumar CP from Department of Mechanical Engineering, Government College of Engineering, Kannur, Kerala. They'll be presenting paper on design and fabrication of personnel noise enclosure for a stone crushing unit. I request all authors, there will be a bell which will be ringed after 10 minutes, so please pay attention on the bell.
Show them which one is yours.
Show me, sir. Yeah. Today morning was I asked.
Show sir is online. No? Just download it. Show it directly. Download.
It is also.
Mail भेजा फिर से mail भेजा.
So that.
Yes. Open.
Good morning, everyone. So we have been attending many lectures on vibration since yesterday morning. So let us have a change. So let us move on to noise control. See, all structures that vibrate radiate sound, right? So if you are able to control vibration, you'll be able to control the noise generated from the vibrating structure. So this is actually work which some of my BTech students have done under my guidance. So they have just completed their course and left, and that is the reason why I'm here to present their work. I'm Sudesh Kumar CP, working as associate professor in Kannur Polytechnic Engineering, Kannur. The noise pollution in crushing industry is, as we know, it's one of the major issues, right? And but unfortunately, in many cases, we don't have some mitigation techniques to control the noise because the workers are exposed to such high levels of noise for 8 to 10 hours, 10 to 12 hours a day, especially when they work over time and all. And we know that as the soil pressure level exceeds 80 dB, really causes psychological and physiological issues to the operators. If you see the literature, only very few papers are there related to noise control in storm crushing units and all, and we could find only 2 to 3 papers. And based on this, we just decided to take some measurements in a nearby storm crushing unit, and based on the measurements, we just decided to have some mitigation technique for controlling the noise. So we just decided to propose some noise enclosure. Whether they are interested in actually implementing it or not. And you know that if you go to industry and tell them that, okay, we want to take measurements and see how the amplitude is, and all, they will not be interested, especially the storm pressure, the owners and all, because they know that always it exceeds the norms regulated by the government agencies and all. And from the recorded noise, it's found that the noise level is usually greater than 85 dB, and it decreases the crushing and C towards outside, and it prevails up to 500 to 650 meter away from the crushing unit. We just went to the storm crushing unit and took measurements. So the objectives of the project was to measure noise, and based on that, to design and develop a personal noise enclosure unit. So a crushing unit in the district of Kannur, Kerala is selected for the study. The size of the unit is around 24 meters, 6 meters, 6 meters, which includes transmission belts and second unit. I'll just show a schematic of this, from which things will be very clear to you. And for measurement, we have used rayon sound level meter and 42. And measurements are taken at human ear level, because you can measure sound anywhere. And noise levels are measured inside the unit at 3 different points at 1 meter, 2 meter, and 3 meter away from the unit. So these are the points where we have taken measurements at 1 meter, 2 meter, and 3 meter away from the unit. And my student taking measurement, and it's a primary geocache shown over there. So at least we must have got a feel about the environment inside the unit. So it is here where the workers are exposed to this noise and dust for 10 to 12 hours. So we used this sound level meter and took measurement, and we have taken 3 levels of measurement: one fully loaded condition, second with no load, and third with partial load. And this is just to study the effect of loading on the sound generator, because we have done similar study in floor mill units, where we have found that loading doesn't have any effect on the sound generator. That means whether you are working with operating the unit with fully loaded these things or not, it was not going to have any effect in floor mill units. So we just now try to see the effect of loading on this your machine in storm pressure unit. So when it is operated at no load, the dB is 64 to 67, and 64.6 dB at frequency of 1000 hertz. And at partial load, it's found to be in the range 85 to 87, 88. And with full load, you can see the sound level meter. See sound pressure level is 90 to 91.3 dB. So the maximum noise levels is found to be at 650 hertz, and the amplitude is 91.3 dB. And you know that the dB is around 93 dB, sound pressure level is 93 dB, and the hertz is 650. And we need to design and develop a unit inside the crushing unit, because they will never allow to have some experiments inside the unit. So what we did is we tried to develop similar environment in our lab. So you can see the amplitude is 91.3 dB, and the related frequency is 650 hertz from this. So we tried to generate sound pressure level of this much amplitude at a frequency of 650 hertz, and based on this we just developed a cabin. And these are the sound pressure noise levels at different load conditions with full load, partial load, and no load condition. You can see the dB level as high as 91 dB with full load. And now to control this, we have three different strategies. You can control the noise at source. You can control in between. You can have some noise barrier in the transmission path, and you can also have control in the receiver. You can have some ear caps or something like that. So here we wanted to have some noise control so that the transmission gets reduced, and we decided to use some material having STC, high STC on a transmission class, and these are the things which we have selected for fabricating in this. Of course, we see when you make a cabin, you should have structural integrity. So for that we use plywood, simple plywood, costs around 45, and thermocol and teak wood it cost around 2,250. And see, we have to see the cost also. So our aim was to propose something which is not as costly as something which you get from outside, so commercial these things and all. So a miniature practical cabin is constructed with the dimensions inside the lab, and just with the help of a source, we just I'll just show you. Yeah, so it's a Board Stone 40W but Bluetooth speaker. This we used, and this was the sound spectrum which we got. And this is actually the cabin which we have made inside the lab using plywood. And mass loaded vinyl, it's used to cover the cabin, so as to increase this transmission loss. And you can see the property, it's having STC of 32, and at a hertz of 630, you can see the transmission loss. Transmission loss is around transmission loss is around 40 dB at a frequency of 630, and what we have obtained from measurement is also like that. At around 630 hertz, we found a dB as 93. So we just decided to use a material which is having high transmission loss at that frequency. So this mass loaded vinyl is having a transmission loss of around 40 dB at a frequency of 630 hertz. We just decided to use it to cover the cabin, which has been constructed using plywood initially. And just made this, and this is actually the distribution of sound around the source. And we did experiment with no enclosure, with plywood enclosure alone, and with enclosure coated with mass loaded vinyl. And we have taken the measurement at 630 hertz and 93.7 dB. And this is actually the frequency and sound pressure level without any barrier. So you can see that there was no barrier. So it's increasing, it's changing from 89 to 98.5 dB. With plywood alone, you can see there again. You can see it's 87 to 71 to 87 dB. So if you are able to make a simple cabin with plywood, you will be able to have this much reduction. See at 630 hertz here the dB is 75, and noise level with this mass loaded vinyl, it has come down to 66 to 75, and you can see that at a hertz, the frequency of 630 hertz, the dB is 75.2. So initially it was 93.2. So nearly 23 to 24 dB has been reduced using this cabin. If you're able to have this cabin inside the stone machine. So this is actually the overall picture. So with no enclosure at 630 hertz is 93.7. With plywood enclosure alone it's 84 dB, and with mass loaded vinyl it is 70. So it has come down from 93.7 to 74.2, and we know that most of the crusher owners and all will not be ready to implement such enclosure. So at least if you see the cost, if you are able to have simple structure with plywood, you will be able to have this much reduction, right? So from 93.7 to 84, at least 10 dB, 10 dB noise can be reduced. You are able to have a simple enclosure with plywood alone. Okay, you forget about coating with this mass loaded vinyl. And this is the graphical representation of that. Okay, this is actually just we have taken the reduction only, and again at frequency of 600. If you are having this alone, it's 10 dB, and with that it is say 15 to 20 dB, and with both you can see the final comparison of this. Okay, so you can see that there is a significant reduction in noise in the presence of plywood and torch alone, and even if you are not going for expensive or high costly this material, you can have simple constraint. It costs around 23,000 only. If you are going for this, finally the cost may be 1.25 lakhs. And most of so what I strongly believe is that being a responsible engineers, we have to do something for the benefit of the common man, for the benefit of the society. See, we have been doing some work related to vibration control of tractors, vibration control, noise control in power loom units. I don't know how many of you are aware of looms. Looms are machines which are used to make cloths, right? And in our district, Kannur district, most of people, see, many people are working in this area. And if they are exposed to such a high level of, see, power looms and all, the dB is around 100 dB, so 95 to 100 dB. So they are exposed to this 100 dB every day, 8 to 10 hours. So it causes real issues to them. So what I strongly believe is that we have to, of course, we have people from industries and have attended lectures and all. Why most of them are not interested in attending now the issues by the common people like this. So we have to have, of course, in terms of profit, in terms of money and all, it may not matter much, but I strongly believe that we have to do this because we have some, by providing technical solutions to such things, we may not be able to earn much, but that has to be done because as a social commitment we have to do that. And that's all. And one more thing I just want to tell you, because I feel a little bit disturbed here because it has been scheduled. My session was supposed to be at 3 o'clock yesterday and then postponed to 7 o'clock. 7 o'clock, then at least I could finish my presentation. Now, it's not the problem with the organizers, I'm sure. It's not a problem with the speakers also, but if we are punctual, we have to start the things on time. And punctuality doesn't mean that you have to start on time, but you have to finish on time. Okay. And when I'll just tell you one story. When I was studying in third semester, I was not permitted to enter the class by a professor because I was late by 5 minutes. So that was actually the first thing which I learned, and from then onwards I was always punctual. I am punctual, and I follow the same thing in my class also. And thank you very much.
Thank you, sir. The next paper for this session will be presented online with the title Pipe Burst Prediction System based on acoustic induced vibration by Saravana Balaji M, Praveen E, Samritha S, Shakti Raghavi S from the Department of Electronics and Instrumentation Engineering, Kamalguru College of Technology, Coimbatore.
So good evening, everyone. Am I audible?
Yes, ma'am, you are audible.
Thank you, ma'am. And I hope my screen is visible.
Not yet, ma'am. Please share the screen. And ma'am, it will be good if you switch on your video as well.
Okay, ma'am.
And the screen is not visible yet, ma'am.
We'll try it again, ma'am.
Okay.
Ma'am, the screen is visible now. You can start.
Thank you, ma'am. Okay. So good evening, everyone. So my warm greetings to one and all present here. This is Samrita presenting a paper on pipe burst prediction system based on acoustic induced vibration along with my teammates Praveen and Shakti Raghavi. And I thank the team of CVS Invest in giving this opportunity to present a paper in the International Conference on Vibration Engineering, Science and Technology. And moving to the abstract, liquid leakage is considered to be the main critical problem faced in the modern pipeline network. This affects both the production of the industry and the safety of the workers. Our approach is to make use of acoustic induced vibration in the pipeline. Basically, Ditron accelerometer 3055D2 and CDAC is used to extract the data of acoustically induced vibration of the pipeline. And LabVIEW is used to extract samples of data. By using machine learning algorithm, it is easy to forecast or ascertain whether the pipeline is leaking or not. Therefore, the main goal is to reduce the fluid leakage and the subsequence of fluid leakage. And while moving to the objective, by creating the solution, our objective is to minimize the leakage and the subsequent wastage of fluids. It also avoids the risk of leakage of hazardous substance. And to create machine learning powered pipeline leakage detection system by analyzing the acoustic induced vibration in the pipeline. And while moving to the block diagram, so this is a simple block diagram of a solution. From the pipeline system, the data moves to the Ditron accelerometer that is interfaced with CDAC on the surface of the pipeline. Acoustic induced vibration data signal is then sent to the data processing unit with machine learning in the CPU. Machine learning software is programmed by assessing the acoustically generated vibration and projecting the leak by positioning the accelerometer in certain phases on the surface of the pipeline. And further, we shall predict the leakage of the system from the output we gather. And now I hand it over to Praveen to explain about the algorithm.
Thank you, Samrita. As told in our abstract, we are using machine learning for prediction model in our project. We tested with some algorithms like nice classifier algorithm and linear regression, but we have chosen to work with SVM since it used to solve both regression and classification model. The objective of the SVM algorithm establishes the decision boundary based line that gives classes from n-dimensional space so that the fresh data points can be quickly classified in the future. The optimal decision boundary is named as hyperplane in SVM. The approach of SVM is based on support vectors, where extreme situations are represented by the utilization of these support vectors. Next slide, please. We have done our SVM model in Python in Jupyter Notebook, and we get the final prediction data like this. Next slide. To visualize the signal from the sensor, we are using LabVIEW model, and the block diagram of the LabVIEW model is shown here. As you can see in this block diagram, we can visualize both raw data from the sensor and filtered signal from the sensor since we are using two waveform graphs in our LabVIEW model. Next slide, please. In the controller module, we have programmed in a way that if the sensor data value is fallen at the negative part of the hyperplane in the SVM graph, then there is no leak or pipe burst is happening. Otherwise, if the data value is at the positive side of the hyperplane, then there is a leak. And the hardware design of a project will be explained by Shakti Raghu.
Thank you, Praveen. So coming to the hardware part, the acoustic signals from the pipeline system will be sensed by the Ditron accelerometer. So the accelerometer we have chosen according to our requirements is manufactured by Ditron Instruments. It is generally used for measuring the level of noise, vibration and harshness of a system. And owing to its small size and less weight, that is only 10 grams, it can be easily installed in the pipeline system, and it can measure the acceleration of up to 50 G range and has a good sensitivity of 100 millivolt per change in the acceleration. Next slide, please. And the next one is the DAC module. The analog signal from the accelerometer will be passed on to the DAC module, where the signal will be processed and converted into the required digital format that can be processed by the CPU for machine learning prediction. So this model of DAC, that is NI9234, is generally used for noise and vibration input. It has an inbuilt module for pre-filtering the analog signal, so we need not install any signal processing module. and the analog signal is converted to the digital signal by the sigma delta type ADC. It has 4 analog input channels and it can process both AC and DC signals and has a maximum accuracy of plus or minus 50 ppm. Next slide, please. So this is the complete setup of our hardware design along with the pictures of the modules that we have used, such as the DAC module and the power cords. Next slide, please. So though there are various methods of water leakage detection, acoustic induced vibration method proves to be very effective and accurate in detecting the water leakage, as the sensors used for detecting the vibration are very sensitive and can detect even small vibrations. So SVM algorithm is also proves to be very effective in classifying the data from the accelerometer as fine and leakage based on the given threshold value. Next slide, please. So these are some of the journals and references that we have referred to develop our prototype, and thank you everyone for patiently listening to our presentation.
Thank you, ma'am. Anyone having any questions? So our next paper will be a pre-recorded video. So I just want to make one small announcement. There won't be an official tea break, but anyone who wants to have tea can go, have tea and come back. We'll be playing the next pre-recorded video of the paper titled Seismic Vibration Control of a Building Structure Using a Deep Liquid Containing Tank with Submerged Cylindrical Pendulum Appendage by Tanmoy Konar, Aparna Ghosh from Department of Civil Engineering, Indian Institute of Engineering Science and Technology, Shivpur, Howrah.
Good afternoon, I am Tanmoy Konar, Research Scholar, IEST Shivpur, and Senior Member, Council of Vibration Specialists. The title of my paper is Seismic Vibration Control of a Building Structure Using a Deep Liquid Containing Tank with Submerged Cylindrical Pendulum Appendage. This paper is co-authored by Professor Aparna Ghosh. Good afternoon, I am Tanmoy Konar, Research Scholar, IEST Shivpur, and Senior Member, Council of Vibration Specialists. The title of my paper is Seismic Vibration Control of a Building Structure Using a Deep Liquid Containing Tank with Submerged Cylindrical Pendulum Appendage. This paper is co-authored by Professor Aparna Deghos. This is the overview of my presentation. The term tuned liquid damper stands for a class of dynamic vibration absorbers in which liquid partly or fully constitutes the inertial mass of the damper and also contributes to the damping mechanism. TLD is a low-cost device. This is easy to implement, easy to modify, and requires minimal maintenance. TLD does not require any external damping element. The damper liquid normally consists of water, and TLD can be incorporated into new or existing structures very easily. Depending upon the depth of liquid to the length of the damper container ratio, TLDs are divided into three groups: shallow TLDs, intermediate depth TLDs, and deep TLDs. The present work is dealing with deep tank damper or deep TLDs. For deep TLDs, the ratio of liquid depth to the length of the damper container remains greater than 0.5. There are very limited research available on deep TLD. There is no real-life implementation of deep TLD till date. This is because deep TLD has two major drawbacks. Firstly, low inherent damping, as the standing sloshing wave produced in deep tank has very little energy dissipation capacity as compared to the traveling sloshing wave produced in shallow tanks. Secondly, the high proportion of impulsive liquid mass and limited sloshing mass. For example, a tank having D by B ratio equal to 1 has about 80% of the total liquid mass as impulsive liquid. The focus of this paper is to present a practically feasible design that would involve the impulsive liquid in the damping mechanism and thereby utilize a deep tank as an effective vibration control device. This figure is showing the geometry of the proposed damper system. This consists of a conventional rectangular water tank. Here, a solid metal cylinder of uniform mass and cross section is vertically suspended within the impulsive liquid zone of the tank from a hanging arrangement rigidly attached to the tank walls. The pendulum appendage is placed in such a way that the length of the cylinder remains perpendicular to the direction of expected excitation. In the proposed damper system, the oscillating frequency of the CPA and not the sloshing frequency of liquid is tuned to the structural frequency. When the host structure is excited, a part of the excitation energy is transferred to the CPA due to tuning. As a result, the CPA is set into oscillating motion, which is opposed by the adjacent liquid in the form of drag, and this results in energy dissipation. A certain percent of the impulsive liquid effectively acts as an added mass to the CPA. Thus, in the proposed damper system, the impulsive liquid mass of the deep tank participates in the energy dissipation mechanism. The natural period of oscillation of the CPA is determined from the free vibration analysis, and the equations of motion of the structured damper system presented here is derived from the consideration of the dynamic equilibrium of the mass of the STF structure and the mass of the cylindrical pendulum appendage. For numerical study, an example building structure is considered. The structure is a 7-story dormitory building. The typical floor plan of the example building structure is shown in the figure. The building is modeled as a three-dimensional moment resisting frame in StatPro VHI software. The fundamental period of the building and the corresponding modal mass are determined. The damping ratio of the structure is taken as 2%. For the numerical study, an equivalent STF structural system is considered, which has mass and period equal to the mass and period of the fundamental mode of vibration of the building structure. The design of the proposed damper system, practically feasible value of mass ratio equal to 0.6% is taken. The damper system is assumed to consist of 6 number of identical units. The value of tuning ratio is considered as unity for simplicity. The cylinder is considered to be made of copper and damper liquid is water. The different parameters of the cylindrical pendulum appendage are calculated and these values are presented in the table. The effectiveness of the desired damper system is assessed by subjecting the equivalent STF structural system to 3 recorded earthquake ground motions as given in the table. The equation of motion of the structure damper system is solved numerically using the ODE45 solver of MATLAB. The response reduction achieved by the proposed damper system is presented in this table. It can be observed that the damper system is able to reduce the RMS and peak displacement of the structure significantly. The RMS displacement response reduction remains in the range of 21.8% to 36.2%, whereas the peak displacement response reduction remains in the range of 11.3% to 14%. These reductions are significant for a passive damper. The peak rotational displacement of the cylindrical pendulum's appendage is also determined, and this can be observed from the table that there is significant rotation of the cylindrical pendulum. A representative set of time history for the Loma Prieta earthquake is presented in this slide. The figure in the top left corner is showing the displacement time history of the controlled and uncontrolled structure, whereas the time history for rotational displacement of the submerged pendulum appendage is shown in the figure in the bottom right corner. The conclusions. Deep liquid containing tanks, which are generally considered unsuitable for use as TLDs, can be effectively used for seismic protection of building by installing a CPA within the tank and tuning the frequency of oscillation of the appendage to the dominant frequency of the primary structure. The performance of the proposed system is independent of fluctuation of in liquid level within the tank for the functional purpose, so long as the pendulum appendage remain within the impulsive zone of liquid. This provides the option of using functional deep tanks such as overhead water tanks for simple passive vibration control system. The reductions achieved by the proposed system in RMS and peak displacement response of the equivalent STF structural system are significant for a passive supplemental damping device. Thank you.
So Tanome sir is also present online. So anyone wants to ask any question, you can ask directly. No, sir, no questions. So we'll move on to last paper of this session. The paper is titled as Seismic Analysis of Base Isolated Liquid Storage Tanks Using Supplemented Clutching Inerter by Ketan N. Bajala, Nakib UI Uslama, R.S. Jangir from Department of Civil Engineering, Indian Institute of Technology, Bombay, Powai, Mumbai.
Hello everyone, good morning. My name is Ketan Bajar and I am research scholar at Structural Engineering Department, IIT Bombay, under guidance of Professor R.S. Jangir. I am doing my PhD work. So this is my first conference paper of my PhD work. So the title is Seismic Analysis of Base Isolated Liquid Storage Tanks Using the Supplemental Clutching Inerter. So this is general outline of my paper. So first of all, structure response control. As we know, vibrations get induced due to earthquake and wind excitation in structures, which can cause a considerable damage to structure. These are controlled effectively by using various control strategies such as passive, active, semi-active, and hybrid control strategies. Passive control strategies actually do not require external work to, uh, to carry out the control of vibrations, whereas active semi-active require actuators and sensors, whereas hybrid control strategy combination of or semi-active devices with passive devices also. However, the passive vibration strategies are more widely used because as they dissipate the energy by adding a flexible layer between superstructure and the foundation, as you will see in the base isolation technology, whereas another is by regulating the structure frequency, which can be shown by the two mass damper, and another one is the by altering the excitation response, that is the viscous damper, where we use some silicon fluid or compressible liquid to dissipate the earthquake or wind excitations. So basically the review on the inerter based hybrid control strategy. Although passive control strategy widely used, it has some fundamental limitations. As we know, the Taipei building in Taiwan, it has the TMD at top of its structure to dissipate the structure vibrations, but its weight about 800 tons, which adds to the extra construction cost and extra liquid at the top of the structure. So to overcome this limitation, there, Smith in 2022 proposed a two-terminal element which is known as inerter, which generates a force proportional to the relative acceleration between its two terminals. However, the inerter over last 2 decades has especially have grown in prominence in the and it is finding its application in various civil engineering structures also. Numerous inertial mass dampers have been developed and studied recently. Some of them are gyromass damper, rotational inertial viscous damper, viscous inertial mass damper, tuned viscous mass dampers, adaptive tuned viscous damper, electromagnetic inertial mass damper, clutching inerter dampers, spring dashboard inerter system. These are the representations of all these inerter dampers. So I will be focusing on the clutching inerter dampers. So basically, clutching inerter damper is a combination of inertial mass damper and clutch, which is first proposed by Marquis and Compass. Under attached condition, the resisting force is proportional to the relative acceleration between its two terminals. When this damper gets detached, the resisting force of the CID becomes zero. The unique characteristics of this CID has promoted its use in various base isolated structures such as tall building bridges and which are two of papers of my Professor R.S. Jangid. He has used CID building and base isolated bridge. So basically the objective of the study, if you use base isolation technology in liquid storage tank, there is an increased flushing height response of the water, which causes instability in depth, which can result in the failure of tank. So the objective of the study is to establish the effectiveness of the CID over traditional IMD and base isolated technique, and to evaluate the various response quantities such as flushing and bearing displacement response, and to evaluate the total shear force of the base isolated tank with and without CID, so that we can know about the lateral force acting on the tank. So this is the mathematical modeling base of a base isolated tank. We can show the equation of motion where the M, C, K, N are the mass, damping and stiffness metrics. The U double dot U dot U are the displacement, velocity, and acceleration vectors, and U double dot G is the relative ground acceleration. Where the restoring force given by the LRB is shown in the equation. Now here comes when we attach CID with the liquid storage tank. Actually, liquid storage tank is modeled as three masses. One is the rigid mass, where the whole mass of the tank is taken into consideration, impulsive mass and convective mass. The convective mass is known as sloshing also. Impulsive mass is the portion of the liquid which stays with the tank. As tank moves, it also moves like it is a fixed liquid mass, whereas the slushing mass is the independent mass of the structure. So the equation of motion is as follows, whereas the restoring force of the CID is when it is attached, then it gives the B into U double dot B, and when it is detached, in the resisting force becomes zero. This is the important characteristics of this isolator. Where the B is the constant of proportionality of CID, which is known as the inertance of the CID. So the problem statement and numerical study. I have validated my paper with Shrimali and Jangid sir's 2003 published paper of base isolated liquid storage tank. So the properties are considered from his paper, Shrimali sir's paper. So the type of tank is broad, the material is steel, whereas the aspect ratio is 0.6, height of the tank is 10 meter. The frequency, sloshing and impulsive frequency is 0.148 and 5.757 hertz. Whereas the sloshing and impulsive damping are 0.5 and 2%. The Young's model is taken at 200 MPa and density of steel is 7900 kg per meter. I have considered these properties for LRP and CID combination. So the type of isolator is laminated rubber bearing. Type of inerter is clutching inerter. The isolation period is 2 seconds, whereas the damping ratio is 0.10 and the beta is 0.30. Actually, beta is the ratio of the inertance mass and total mass of the isolated tanks, which is known as the inertance mass ratio. So these are the ground motion characteristics which are considered for analysis. Kobe, Loma Prieta, and Imperial Valley earthquake, tail ground motion recorded. The response of the tank. As you see in Kobe, the isolated tank has given 26.55 centimeter of bearing displacement, which we can say that base displacement. But when we add CID there, the response gets reduced to 78%. Similarly, you can see in the sloshing displacement in Kobe earthquake, the response gets reduced to 34%. So it is a very more than 50% of response is getting reduced in bearing displacement. And considering our total base shear, 45% response is getting reduced due to application of the inerter elements. So these are the representation of the slope time history representation of response considered in Kobe earthquake, similarly for Loma Prieta and for Imperial Valley. And so the conclusion are the bearing displacement and big shear force can be considerably decreased when we apply CID to the base isolated structure. However, in sloshing displacement response, there is a minimal reduction, but the issue of water spilling or root tank damage may still be addressed. Optimal design of hybrid system can be done to address a little increase in sloshing acceleration response. However, the CID is a combination of IMD and clutch, which is a better option than conventional inerter based system. So these are my references. Thank you.
I have a question.
Yes, sir.
Actually, you are talking about because of base isolation, whatever problems are being created, you wanted to stop that.
No, actually,
Minimize, right?
We use base isolation to minimize the reduction, but
That's true, because base isolation is a specific purpose.
yeah,
And then because of base isolation, maybe that another negative impact in terms of lossing effect, isn't it?
yeah,
That you wanted to minimize.
yeah.
But what is the basic purpose of base isolation?
So basic purpose of base isolation to lengthen our time period of any structure, so that we can
Particularly
reduce.
in earthquake resistance, you are building earthquake resistant structure, isn't it?
Yeah.
So what is the impact of your provision? Because base isolation is normally provided to sustain under earthquake.
Actually, in TMD, in tune mass damper, if you see a Taipei in Taiwan, there is Taipei building.
Are you understanding my question? I'm just asking.
I am telling you the reason of using inerter.
I understood that, but I wanted to understand because your results are not reflecting that. In what extent base isolation effect is minimized with reference to earthquake impact?
Yeah. No, I have shown that. You can see in the bearing displacement response.
I understood this isolated tank bearing displacement from 26.55 to reduced to 14.89.
Yeah.
So when it is reducing, is it the basic purpose is fulfilled of going for base isolation or not? It is concerned in some extent, no? No.
No, sir.
It is nowhere related to your earthquake movement.
No.
This bearing displacement is nowhere related to earthquake excitation, no?
No, bearing displacement, if you not use the base isolation, then the displacement can go up to 100.
We wanted to make sustainable tanks under earthquake.
Yeah.
But for that reason, you are providing base isolation, right or not? Now, if you arrest that base isolation in some extent, so the negative impact may come also, no, for tank sustainability.
That's what I tell in. Yes. Due to instability, the storage tank may fail. So to reduce that, we are using inerter, and inerter is giving virtual mass.
I understood in the other way. Because of earthquake problems, you are using isolation, and isolation is creating another problem. You are actually focusing on the problem created by base isolation.
No.
If I understood rightly.
I want to explain. Actually, what inerters do, they increase the inertial mass. So basically, the seismic weight due to the isolator or the damper which get added to the structure, that is minimized. The construction cost is minimized very effectively, and also you get the less reduction. At this, in only water tank, there is instability added by base isolator. If you consider tall buildings now, when you consider tall buildings more than 20 floor, base isolation is not effective. There you have to use damper.
I understood. That I understood.
Yes. Only this case there is instability, and this is groundwater tank. If you use elevated water tank, now, at that case also base isolation is not a good option. You have to go with dampers.
My question was something different. I'm just trying to ask you that question. Because for earthquake resistance of that particular your water tank or any tank, the base isolation is provided. Our intention is not constraining the motion of a tank, otherwise it may damage. Right or not? Now, if you can arrest that base isolation, because maybe base isolation creating instability, I understood that, and because of that, maybe you wanted to minimize that instability, but simultaneously, what is the impact in terms of what flexibility given for the tank under earthquake movement? I was asking that question. Is there any impact of your system on the flexibility given to the
No,
diagram?
that I have not considered because this is my only first semester of PhD.
See, it was a very dynamic question.
That can I
So
consider.
you're expecting a dynamic answer, but you're giving much static answer. That's a very good response. No, thank you.
After 2-3 years when we are publishing, we can.
Very good. Very good answer and a very good question too. It's very dynamic, the whole process now in vibration presentations. Good. Achha, I have one suggestion.
Yeah.
You have written the names of those places from where you've written the names of the places in your presentation. Hubei and all that.
Yeah.
No, I am an ignorant guy. I don't know where these places are. So in the bracket you write they are in Japan or in some place, Spain or whatever it is. Just a little suggestion because a lot of people may not know, may not want to ask also because it's an ignorant question. So sometimes it's important to trace your, and there are lots of places in this world which have the same name in different countries, like Portland. There is a Portland even in UK and there is a Portland even in the USA. So it will be good if you could do that. Thank you. Thank you.
Thank you.
Thank you, sir. Now I would request Dr. Gambhir to award a token of appreciation for our paper presenters. So first I would like to invite Dr. Srinivas Hogu, Senior Principal Research Scientist in CSIR. I will request Dr. Pine to present a token of appreciation to Mr. Ansaf Muhammad Ashraf. Is not present? Okay, fine.
No, Dr. Sudesh Kumar.
Dr. Sudesh Kumar. We'll present him later. I request Dr. Pine to present a memento to Mr. Ketan Bazda. Thank you everyone for being a part of this 4-track session. We request a session chair to summarize the session and address the paper presenters. So I welcome Dr. Chinmay Kar.
Thank you very much. Good morning. This is a very nice, interesting session. We could see the application of vibration in different areas. For example, we could see a robotics application of vibration monitoring and control by Sasaki-san from Japan. Then we saw the application for a lift, industrial lift case structure by our founding fellow of CVS, Dr. Srinivas. Then we saw application on pipes, application on the building structure, and then liquid storage tank. So you can see the variety of vibration monitoring and control in different parts of the application areas. We also see some interesting observation. For example, we have seen a lot of measurements on vibration using accelerometer, velocimeter, or our proximity probes. And Mr. Sasaki-san, he has shown a very good application of strain gauge. So high frequency strain gauge application for measuring vibration. Even I have done a similar project for monitoring the vibration of idlers in conveyor belts using some IoT device with the case of strain gauge, high frequency strain gauge, and I have compared with the accelerometer signal. And it was really very good application. We can see different such application in future for us. And then we have seen application, actually Dr. Srinivas has explained the laser Doppler meter for measuring vibration, that also a non-contact type. So such type of application we have to see that different type of sensor measurement in vibration monitoring and control. We have seen a lot of different control scenario and also an interesting case of noise isolation for stone trussing device. So these are different new areas. For example, one thing is that the inverter based damper. This is a new case for me, at least I learned from that. So there are some interesting observation, and really thankful to all the keynote addressers as well as the speaker of the presenters. And it is really very nice applications areas, and we can see different such type of variety in our future presentations. Thank you.
Thank you, sir, for an excellent summary. So all delegates, drop your today's lucky draw coupon in the box. So during valedictory session, we will be announcing yesterday's as well as today's winner. So now I request for our, so there'll be a presentation by our corporate associate Baker Hughes. So I request them to please carry the presentation.
Okay, so by the time he loads the presentation, just want to thank CVS for and Mr. Pine sir for giving us opportunity to be in this session and also present um, in this forum. Okay. So just a short introduction. Myself, Mahek Jadhav. I am senior application and solution architect for Bentley Nevada. Bentley Nevada is in field of vibration from last more than 60 plus years, almost 64 years now this year. So I will briefly touch upon this topic called as integrated asset performance management, because what we are doing in the field of vibration in turn for industry, it is impacting or the way they manage the asset, it is impacting that only and ultimately their business. Baker Hughes as a company is mostly in oil and gas sector. It has two sections. One is an upstream where they are mostly in oil exploration, drilling, related services and equipments, and there is another vertical where we have equipment business where we manufacture compressors, pumps, turbines, as well as a lot of digital devices. Like Bentley Nevada is one vertical where we primarily in vibration monitoring system hardware and software, as well as we have other pressure calibrators, ultrasonic testing devices, X-ray machines, and everything. Okay, so asset management, as you know, that it is a new field, evolving field, though it is present from quite few years. But adoption of that is accelerated in recent years after the IIoT, and everybody is trying to adapt it in their own way. And if you look at some of the data from some of the consultants, 70% of all the organizations are already all completed or on the verge of completing implementation of some strategy which will help them in their digital transformation. So why do they want to have a digital transformation? Is basically they want to manage their assets so that they can produce more at the less cost, right? So ultimately that is how the business advantage they will get. So but if the reality is only 16% of them are really successful. Successful in the sense they are successful in achieving their business transformation as well as sustaining it, because a lot of time one-time achievement is very easy, but sustaining it is become more and more difficult. And some of the reasons behind is like there are functional silos, right? You have very good condition monitoring program. You are doing all the good work, creating the results, finding out the problems. But are you really connected to your reliability team so that they are getting that input and so that they are doing the relevant root cause analysis, changing the asset strategy so that they can maintain the machine in a proper way, or then if there are repetitive issues, you are eliminating those issues from the system by doing the root cause analysis and everything. And all that, like whenever there are multiple machines having some kind of issues, how to prioritize and everything. So in industry currently, everything is siloed. Like reliability team is working in silo, their asset management teams are working in silo. There is no connection with the work management system, that is SAP and CMMS. And ultimately what happens is industries are not able to basically leverage the insights in a better way to manage their assets. Other major issue that their industry is seeing is the skilled manpower. A lot of them are retiring, I think. And with them, all the knowledge related to process machines is also leaving, right? So there is no standardized way of storing that knowledge within the organization. Plus, if you have multiple sites, then ultimately you can have pockets of knowledge, right? You can, one side has a very good knowledge, knowledgeable people, but other side not. So how you can leverage that kind of situation, like using the knowledge from the other sides so that you improve the asset availability in the others. And the other thing that is happening is a lot of people just see that the fancy things about the technology and they just go for it rather than first really understand what really is the problem they want to solve, what exactly will help them to improve their process and also successful in their digitalization journey. So it is more becoming a technology oriented selection. That is the reason a lot of the customers fail to realize the value. And some customer who basically succeeded in that, they were right. Their approach was like, okay, I have current situation, my current situation is this, and I want to go here, and these are the gaps. I want to solve these problems, and what is the technology available to address those issues, right? So that is what process should be, and in that the technology selection, one should have partners who know about the domain knowledge and everything else. So unless you have content and domain expertise, all this implementation becomes another piece of technology in your company, and it will not be successful. And why asset management is done in the industry in the first place is there are a lot of benefits in doing that, because in today's competitive environment, it is more of producing more with the similar kind of asset and infrastructure that you have, and at the same time you need to control your cost, right, so that you can improve your margins and everything. So that is what some of these benefits are. These are from one of the Frost and Sullivan paper. So there are really good benefits of managing assets well, integrating it together and all. So what we are trying to do in our solutions is we are trying to integrate all these different silos together so that we can leverage and learn from one function to another, right? So if you see the asset management cycle as such, one is first you want to understand the condition of the assets, right? So what exactly is happening? And then if you have some kind of notification and everything, you want to prioritize. Like if I have 10 kind of notifications, how should I prioritize that? So there should be a system which tells me or give enough information that yes, these particular alerts are more you can say important to address first rather than moving to next, and then notify the relevant people and then take action and then understand what exactly you learned and associate it back to what the notification was. And if there was some learning, whether it drives some more root cause analysis, because as Fine sir was telling yesterday, vibration is just an effect, right? Or any condition. Root cause might be anything. So you want to dig down further and understand what is the root cause and then learn from it. So if you learn something, okay, whether I should just this particular learning is only for that particular asset, or I can scale it up, because that is where the benefit of APM comes in. If I have one pump where I learn something and I have hundreds of pumps and that particular learning is applicable for all 100 pumps, then I can have the ability to implement that learning with single click, right? Otherwise, I will be doing the same kind of repetitive work again and again. I will not be able to achieve my digitalization goal. So that is where we are doing. So all our solutions are integrated in such a way that learnings can be immediately scaled up, and then you can slowly bring down the stability from the chaos that you see in a day-to-day life of a plant people. So what we are doing is we are automizing the detection process through AI/ML techniques, and also some part of diagnostic. Also, basically, it is a combination of both AI/ML plus our domain expertise together. And then we are seamlessly integrating everything, means from our condition monitoring to asset strategy management, means how that machine should be managed, maintained, what activities you regularly do it, what is the cost associated with it, what is the maintenance budget from right now 2 years from down the line. Everything can be managed in asset strategy, and also doing root cause and integrating with the SAP, so that work orders also can be seamlessly generated and followed. So that is what we are doing with our integrated APM solution. And one thing that we understood in all this is in condition monitoring, particularly if you don't want to do something in a continuous or online basis, not all the machines are monitored continuously, right? A lot of these machines are monitored using portable handheld devices. And these days, wireless sensors have become very prominent, increasing the coverage of your assets in the plant, because you might have few hundreds of critical assets, but there are thousands of non-critical assets in the plant. Also, those needs to be monitored. So we have this Augury solution, which is again wireless sensors, which is again seamlessly integrates with our APM solutions as well, and which increases our coverage for balance of plant assets, and it has a very good track record. So in terms of detection accuracy for their AI/ML algorithms, the way they provide the prescriptive analytics for the problems associated with the condition monitoring, and they have average ROI of 3 times the investment that you make on these sensors. So together, what we are trying to do is we kind of create a digital thread between these different functional silos, like asset condition monitoring, that is typically we call as a vibration or any other condition monitoring related program. And then asset strategy management means how you do certain inspection, do maintenance, what is the labor cost associated with it, maintenance budgeting. If I want to increase the shutdown timing, time between 2 shutdowns, everything, that all is managed under the asset strategy. So, and that we have programs to optimize the asset strategy so that it is win-win, like I don't increase the risk as well as I spend less and have maximum availability of machine. And with defect elimination, like root cause analysis, again seamlessly integrated with the EM programs like CMMS, SAP, etc. So that whenever there are alerts and everything, you can clearly see on this some of these dashboards where we provide all the data all the alarms that are seen from the monitoring systems and everything. You can even associate it, the cost associated, means what is the probable risk associated with that particular alarm. So if I'm seeing 10, 15 alarms, I'm very easily can prioritize what is my high priority alarm, what is my low priority alarm, and accordingly I can schedule my work tasks and everything. And we can give all the scoring related to machine reliability, availability. Even we can show the maintenance related spending and everything in the dashboard. So that was just a brief introduction to our integrated APM solution. So basically it is formed with our domain knowledge of Bentley Nevada plus domain knowledge of ARMS reliability, that is acquired business, which is mostly in reliability space, as well as any other data available to integrate from DCS and all the system. So thank you. Any questions?
I have one question.
Yeah.
I have done at least 17 projects in India. Everybody had such shop. They put the licenses of SAP into their cupboard and then they found a guy like me who said, okay, this guy seems to be wanting to do something in the game. Whenever I go to an Indian company, maintenance is given the least priority in placing it with SAP. I'm with you on the same digital page that you are. I'm down enough?
Yeah, I'm ready.
So the question I have is, how much of this service, this combined service of performance monitoring and performance enhanced services, that SAP gives you support to be able to align with their system?
Yeah, we don't really ask any support from SAP in this. Generally, what we do in our integration with SAP, like we have direct connectors with SAP, we can integrate or import their hierarchy and everything. And one, as you rightly said, currently data quality is a big issue. Even what you logging into the SAP and everything. So yes, we do have that awareness and consultancy initially when because this is again, as I said, it is not a one-time project, right? It is a journey. So we take it as step-by-step approach, so that initially we can help the customers so that they can improve the data quality into their system, so that the other periphery will give more, you can say, relevant information about everything. And again, whatever the work order generation and everything is anyway seamlessly integrated. So any work order closed or still open, everything we can see in our dashboards, everything as through our standard connectors, etc. So yeah, that is how the current integration is.
So have you done anything like that in our Indian countries to be able to help any particular organization, some case study you might like to?
Yeah, we have worked with global customers currently. We have not yet done it with India, but that integrated APM is we have recently basically from December last year we have started that, and globally we are working with like customers like BP and all, British Petroleum and all, where we are integrating. So wherever we have all these different verticals available, it is much easier for us to integrate. And all this is a cloud-based solution with the services attached.
Actually, data management itself is not the responsibility of Bentley Nevada or any other company. It is the responsibility of the corporate how we manage data so that we can extract data for the identification of for the reliability analysis, for the different type of different elements and all this code, everything has to be done. And it is this priority in a large corporate. When you see, when you go for consulting and see the data, just you cannot do it. If at all you do, we can give a figure to management that is not relating the reflection of reality as such. So data quality is the main problem. quality data, but Bentley or any other software doesn't have any problem to take it off for the analysis for decision making purpose. So that's the problem of the corporate users. It is not the supplier of the system or hardware or software analytical tools, whatever the integration they have made it the best use of it. It's fantastic. Problem lies at the plant that I have seen. Okay, sir.
Yeah, actually, I totally agree with you, and so that is how the culture change and other thing happens slowly. It doesn't change overnight, right? If you just execute it as a project, it will take quite a lot of time. But one should basically agree to embark on that particular journey first. Okay. Thank you.
Just a moment. I would like to just add to what is being discussed. Data, yes, it's the responsibility of the end user. But if you see the whole benefit realization, the value proposition of balancing cost, risk, and performance, all this data essentially comes from CMMS or EAM systems. So the success of any such program also lies in the success, or say the prerequisite is there is a reasonable data quality and also data capture, so that we are able to show to the customer that what is the value we will be able to deliver. When we say we will improve the performance of the assets over time, so it needs to be in a measurable way, and that measurements essentially depend on various structuring and the discipline of capturing the right data at the right time.
Yeah, I totally agree. So, John, that is what I said. You first should know where you are and where you want to go. And that gap, if you want to address, it is a journey and you should start somewhere. Right?
One more question is,
running short time. Okay, fine. I can address.
Yeah, we will discuss offline.
Thank you. Thank you very much.
See this video, sir. Huh? All the sir, we can give it to the
Thank you. Thank you. So what we will do is we'll immediately begin with technical session 5. I welcome everyone for the technical session 5 of Invest 22 conference. And I just wanted to make an announcement for everyone that lunch will be sharp at 1:30 to 2 p.m. If we have any papers that are still left in session 5, the events will be automatically transferred to session 6, and we'll be informing you. I request everyone to be on time after the lunch, because we have a delegate from Sweden who will be joining us online. So I hope that everyone comes back here sharp at 2 o'clock, and 1:30 we will end the session of session number 5. So thank you, everyone. Now I'll introduce the session keynote speaker, Dr. Edwin Vijay Kumar, HOD Asset Management, PHM, GVP Engineering College, Visakhapatnam, Andhra Pradesh. And I'll just give a brief introduction about sir before we begin. He has worked for 35 years in the steel industry with Vizag Steel. His area of specialization includes reliability engineering, condition monitoring, information fusion, and maintenance engineering. He has 6 research papers from various national and international conferences. He has also guided 8 MTech students and 4 PhD students from IIT Kharagpur and other universities. Sir, you can please come and address the guys.
Good afternoon, everybody. Firstly, on one side, I thank everybody here to present to listen this a brief talk on health monitoring and predictive maintenance of turbo machinery. I thank the organizers to give me the opportunity for presenting my views and ideas and experience on this matter. Health monitoring and predictive maintenance of turbo machinery area and what has been just discussed as asset management by Venture Nevada and users. Yes. So what is a turbo machine? A turbo machine is a mechanical assembly of components exchanging energy between a rotor and fluid. Energy is transferred from fluid to rotor in turbines, and energy is transferred from rotor to fluid in pump, blower, fan, and compressors. This is what is a category of machine which is largely used in most of the process industries, and they are the workhorses, mostly control most of the processes, and in the process plant and power plants, they are the major units. Why turbo machine reliability is important? Process plant operations are solely dependent on availability and performance of turbo machines needed at capacities with high efficiency. Turbo machines handles large volumes of power, DG sets, large high-speed compressors, and high-volume fans and blowers. Outage of turbo machinery leads to production loss and high maintenance expenditure. Turbo machinery damages are not only costly but also technically complex because those components are made tailor-made, they are not available off the shelf. You have to inform the OEM and make a suitable part or somebody else to make that part and be readily available. It takes time and also a lot of technical expertise is required. Turbo machines health monitoring is not, in general, it is not completely coincides with the normal industrial asset management because the complexity of the machine is so that data collection, as we were discussing just now, the raw data and corrected data and good data, the data collection and analytical part of the data collection varies greatly in turbo machines. That is where this area of specialization gained importance in asset management too. Turbo machine health monitoring is aimed on life cycle optimization. That is, operational cost, maintenance cost, and salvage costs are vital in design of turbo machine health monitoring policy. As we have just seen that Benjamin Nevada, mostly OEMs develop turbo machine condition monitoring system, but not health monitoring system. Here I want to say one thing that condition monitoring and health monitoring different. Condition monitoring is that the present condition is monitored and the correction is made. Health monitoring is a large life cycle concept. It takes from the day of the installation of the machine to the removal of the machine for the salvage or conditioning the machine for as new as condition. That is where the health monitoring plays a major role. It incorporates some of the process parameters and also data collection techniques. Condition monitoring, health monitoring, just I mentioned, condition monitoring provides us diagnostics and helps determine health of the machine based on various measured conditions. Health monitoring incorporates equipment degradation and overall asset performance. Condition monitoring is a prerequisite to health monitoring. Without condition monitoring, health monitoring cannot stand, but it is a prerequisite. Now, coming to degradation of a component. See, this is the performance. The performance level starts from 100%, and over a period of time, as time usage goes, that it drops down. The dropping down of the degradation of the performance level to unacceptable level, like alarm level or alert level, depends on the pattern of degradation. The pattern of degradation may be varying from one condition to other condition, and the pattern of degradation mainly depends on the operating context of the turbo machine. The operating context means the ambient temperature, process conditions, number of operating hours, and the operational abuses. All these things comes under operating context. Operating context is a vital role, plays a vital role to deciding which pattern the machine takes. It may shift from point to point, from time to time, from pattern 1 to pattern 2, and once it goes from pattern 1 to pattern 2, it cannot come down to pattern 1 because the degradation is a non-reversible process. It is an ever-increasing process. So this is where we can see that in one life cycle, the performance is reduced to an acceptable level then because of degradation pattern like this, and degradation is because of the stressor, could be a temperature or a vibration or an operating context variation, whatever it is. So based on the variation of the stressor, the degradation changes over a period of time, and the performance level drops to a maximum purpose level. Then the minimal repair is done. When the minimal repair is done, the performance is not improved to 100%, but it is improved to a great acceptable level. Then once it goes like the different number of cycles, then it goes to a major overhaul where it will be again taken to a as new as condition. Maybe little lesser than what as a new condition, but it is almost matching with the new machine. So this is how the cycle continues for a machine or a number of times, and that is where the health monitoring comes in importance for a life cycle concept. This is the performance and failure characteristic. So when we are talking about condition monitoring, we will know an interval to measure the machine condition today, and after some time, then the change in machine condition is indicated by the parameter which is measured. That is a condition indicator. So that is what we call as a PF interval. That is potential failure interval, where there is an indication of the failure, and the F is the time when it fails. So that depends on this pattern, this time, and this pattern, this time. So depending on the degradation pattern from 1 to 2, 2 to 3, when it changes, then the PF interval also will be changing. In case of turbo machines, when the operating context changes from time to time because of the loading condition, suppose if you take a power plant, there is a peak load time and off load time and summer time and winter time. So when base station is there, it will always run at the base level. But when it is a peak load station, peak load will be there and for some time of the day, and then it will be reduced to a normal load at some other time. So like that, the changes in the load condition takes the operating condition context also varies greatly. Then the degradation of the component, it could be a journal bearing, it could be a impeller blade, or it could be a seal or a gland, anything which will be subjected to high loading stresses. Those things will change the component life, degrades the component much faster than the turbine which is operating on a continuous peak load condition. So that is where this PF interval makes it difficult to arrive at a point that for this machine this is a PF interval, and if it is not deterministic, if it is varying for a period of time or time or a load, then it is very difficult to assess on which condition or which time the machine fails. This is the complexity of turbo machines. That is where this asset management, the Bentley systems are very good in capturing data, and they are really give a good data from time to time. It is a user to analyze those data and take a corrective action. That is where the user interface with the asset management system is much important. As we are, question is raised by somebody in the audience. As we know, this the classification of the three component failures, there are different 6 classifications are made as per the statistics. This number one is a typical characteristic of electrical motors. This is the typical characteristic of rotating machines, and this is the roller element bearings and bulbs and electronics, and typical of turbines. One good thing with turbo machinery is that they are mostly time-dependent failures. They are not purely random failures. They will follow a particular pattern, and that pattern decides on a degradation pattern. The degradation pattern depends on the operating context. So this is the interrelation of these things. So the 59% or 5% of the failures typically comes to this pattern. This is an asset management cycle, like health management. So the failure purpose is maintenance decision making, and of this gas engine. So that is where the cycle continues like this, and then the deviation of the measured parameters is a condition monitoring, and this is the decision making part, and this is the relation which it goes on again and again from time to time, so that the equipment health is maintained at a particular level and the reliability is ensured. This is just a concept slide. So hierarchical layers of turbo machinery and health monitoring. So as I was telling that condition monitoring is a prerequisite of health monitoring. These are the steps involved in the condition monitoring. First is that know your mission. Identify key process indicators. List all possible failure modes. Identify failure mode indicators. Map failure mode indicators to components and identify component deterioration indicators or parameters. Develop indicator monitoring program system. Set alarm or alert levels for each indicator. This is a part of condition monitoring. This is cycle. These are the steps involved. And when it comes to health monitoring, establish trend monitoring, develop database for feature extraction, review component integration with process indicators, develop rule-based to generate maintenance action, restore component life and process level, monitor machine and refine database and rule base. This is the health monitoring as per asset management standard. So this is a part of this, and these two go together for the total health monitoring of the turbo machine. Now, health monitoring and asset management, as just we have seen in the last slide. Now, the thing is that what it makes health management is more robust is that the first is connectivity of the equipment monitoring our system with machine. So, how the machine is connected with the component interface, indicators, indicator monitors, performance indicators, and the mapping of component to process. This is all inbuilt process of the connectivity of equipment monitoring system with machine. The second layer is that analytical abilities and data management for decision support. This is where analysis of condition indicators means feature extraction, trending, domain knowledge, and decision logic. This is a key part of the health monitoring. The next thing is that man-machine interface. Presentation of man-machine integration with visual effects, plus online indication of process changes, plus response visuals on human intervention or maintenance action. These are the three layers of the health management systems. These are three modules which will talk to each other and finally gives a decision which will make the system more reliable. What is predictive maintenance? Predictive maintenance uses condition monitoring data and techniques to monitor the performance of a component of a machine during useful operation to predict the impending failure and before the machine fails or degrades to such a level that machine performance is reduced. The advantage of predictive maintenance is that they minimize the time required for maintenance, minimize cost of lost production, minimize cost of maintenance and maximize equipment life of the machine. This is a generic one. Now that I take an example of one process steel plant where an impeller is balanced every time repetitively because balancing is known to everybody in the plant, that section of the plant, and they think that impeller is getting every time unbalanced and it is balanced again in the operation and again it is getting unbalanced. The cycle is going on, but the frequency between two balancings was very less. Then we have gone for proactive management, the predictive maintenance. Why it is going? Why it is getting unbalanced very frequently? Can we not reduce the number of times the balancing requirement? There we have gone out of the machine. Here we see that we have taken the air sample which is collected by the filters and then we have analyzed with the variables analysis. So that shows normal rubbing wheel particles are observed in large quantities. So these normal rubbing wheel particles are coming from where? They are coming from the air suction. So what we have done is that we have changed the filter maintenance device. So when we have changed the filter maintenance for every 3 months filters were changed. Now we have changed it every 20 days. Like that. Then the frequency of filter changing is changed. The total accumulation of dust or variant of impeller is reduced and the compressor was running smoothly for the last 5 months. So it was earlier 4 to 5 months. Between two balancing periods, the time is increased to 9 months. So this is the result of analyzing what is the root cause. The company was talking about root cause failure. So this was the reason for the root cause analysis. When we do root cause analysis, a lot of machinery problems will be eliminated. The thing is that we had this is the turbine cross-sectional view. The problem is that high turbine ratio of vibration on load, 300 microns more than that, and turbine front shaft is less than 600, more than 160 megatons at a speed of 4000 RPM. Data collected vibrant suggestion shaft orbits and tender for 2014, and these are some values. So what happened is that the vibration was more on the rail pedestal, but the problem correction was made in front pedestal. During the period of March 14 to December 14, bond half its component, that oil will component is found to be unstable and shaft vibration level at the turbine layer and were fluctuating. So this is where we have got an indication from the analysis and then further analyzed it, and it was stable. 80% of the component is always stable. What we did is that we have changed the two number of tilting pads are changed at the turbine front, showing drastic reduction in shaft vibration. The increasing trend is observed since June 2014. The problem observed was on turbine rear, but the correction was made on turbine front. Normally, what people will do that when half of this component, oil wheel component is found, they think that the journal bearing has lost its profile. So that's why oil weight is coming on journal bearing. So they will change the bearing. But we have not changed the bearing on the journal generator turbine rear, but we have corrected the problem by changing two number of tilting pads in the turbine front. That is how we have to deeply analyze the machine. To analyze that, we have to have the anatomy of the machine fully known to us. That is where the importance of understanding the machine lies. Thermography of the monitor, how we have used thermography monitor also to increase the turbine installation time, life, to assess the condition of the turbine installation, to identify invisible steam leaks at high temperature, to ensure steam gland condition for steam leaks and temperature, to ensure safe working of maintenance staff during operation. This is a turbine normal view, and this is a thermograph. So in thermograph, you can see the hot spots. See here, the steam is leaking, and which cannot be seen by naked eye. If somebody goes near to that, he will have a thermal injury. And this is where the gland is leaking. So we have corrected this also. So the gland is cut. When the gland is leaking continuously, the gland life will reduce. Like that, you can analyze the machine with the thermography, and which will reduce the failure of the insulation at a particular spot. So these are some of the standards which are related to turbine machine health monitoring and asset management, and this is available on the internet. You can take this. So please be interested to ask questions. Of course, time is not there much. Anyone one or two questions I can take up.
One question.
Yeah, please.
Not related to this. Okay. So you retired from
Vizag Steel.
Vizag Steel.
Yeah.
How many blast furnaces are working there now? After you retired?
6.
That's all I want.
You related with the blast furnace?
Yes, I went for the first blast
Okay.
in 1988.
I was there.
Yes.
I was there. When the first metal was tapped from the machine, yeah. I was there in the cast house.
I went all the way from Bombay to see that.
Yeah. Now I have a piece of metal which has come out first time out of the blast furnace.
I'm a metallurgist, that is why I want to.
Very good, very good.
Thank you.
Yes, please.
Thank you. It was a. Can you hear me?
Yeah.
Yeah.
Thank you. It was a very nice presentation. Congratulations for that.
Thank you.
I have only one question.
Please.
You have shown one, characteristic.
Yeah.
Performance characteristics and when you do the small repair.
Yes.
And when it goes for major, overall.
Yeah.
So for that, you have to have a performance indicator of the machine.
Yes.
Which may be combination of various, parameters.
Yes. Definitely.
So there may be vibration, there may be thermal mapping, or high temperature is rising, there may be lubricant issue, there may be hydraulic system issue.
Yes.
Contamination in the hydraulic oil.
Yes.
So how do you think you can capture all these things in one single indicator?
No, it is not possible.
It is not possible.
It is not possible.
Then how do you say machine performance is good or bad?
We have to categorize all these performance indicators into 3 levels: major, minor, and critical. We have to monitor critical parameters. What level the critical parameters are changing. So how much we can improve these critical parameters from one level to other level. Then the major, like ABC analysis. We have to categorize this and then attempt to review the machine.
Exactly. So if there are 3 parameters,
Yeah.
which has to be monitored.
Yes.
And if you can put a weighted average for each of them.
Yes.
Then you can make a single indicator.
That is what my PhD is. You can refer in that online also. Health indicators, indication, health index of a machine for reliability. That is where I spent about 4.5 years to arrive at an indicator which will be indicating the true degradation of the machine or a level drop in the machine, and by maintaining that how the reliability is ensured. That's very Thank you.
Thanks.
Next, we move on to our technical session for the track of vibration, noise control, and isolation. And the technical session chair for this track is Dr. Amolesh Barai, and the two judges are Dr. Nitesh Relve and Dr. Sanjay Rukhande, who will be judging for the two awards, Best Paper and Best Young Researcher Award. Before we begin, I request all our presenters to keep their presentations to strictly 10 minutes duration, which will then be followed by an interaction with our judges. I also request once again our audience to please switch off their cell phones or keep it on silent mode, and if required, please take their call outside the hall to avoid disturbing the session. So with this, I begin the first paper. The first paper will be application of finite element method for analyzing the influence of geometrical patterns of spur gear pair on dynamic behavior by Mr. A.S. Raut from the Department of Mechanical Engineering, Rajendra Mane College of Engineering and Technology, Amba, Ratnagiri, Maharashtra, and Dr. S.M. Koth from the Department of Mechanical Engineering, FCRIT, Washington. Mr. Raut, you can begin.
Say your file. File 50.
Good morning, everyone. Today I am going to present my paper titled on application of finite element method for analyzing the influence of geometrical parameters of spur gear pair on dynamic movement. This topic is based on my PhD work under the guidance of Dr. Fcrit, and the overview of this paper contains the introduction, in this case, why the vibrations are induced. It is the basic mechanism, then brief literature view, and the design of spur gear pairs. Then the dynamic response of spur gear pair by using the finite element method, and the dynamic response is to be predicted by using the experimental study, and last topic is the conclusion. So basically, the gears are the most important as well as the critical component, and which is used in many applications. A pair of gears would transmit uniform angular rotation if only if the gears are having the perfect profile, infinite stiffness, and if the teeth of the gears are equally spaced, then and then only it is possible to transmit uniform angular motion. However, in real gears, we observe that basically the gear profiles or the gear surface are designed somewhat or deviate somewhat from the ideal profile in order to have the smooth operation or in order to avoid the interference and undercutting phenomena. Also, they contain the manufacturing errors, because manufacturing errors are the inherent in the manufacturing process due to the wears, due to the deflection of the teeth or the deflection of the shaft, due to the flexibility of the bearing housing. So these are the various parameters which definitely affects on the dynamic wear of the any type of gears. Also, the operating conditions of the gears, that is the speed of the gears, then the torque applied on the gears. Also, the speed as well as the torque is not remains constant. Even though in some application we require the constant torque, however, the torque output torque on the gears is not remains constant. So there is a fluctuation of the speed and the fluctuation of the torque is to be takes place. So basically during engagement or during the engagement and disengagement, if the point of contact lies along the line which is tangent to the base circle, then and then only it is possible to obtain the uniform angular velocity. And in practice, we already observed that due to many reasons or due to many causes, it is not possible to have a relatively constant angular velocity due to the non-aerodynamic accident. So there are the various researchers, they studied the effect of various geometrical parameters, effect of bearing stiffness, as well as effect of the shaft stiffness and the operating characteristics of the movement. Now in 1992, Kerman developed a finite element model in order to investigate the dynamic wear of the gear pairs. And their results show that the bearing compliances can greatly affect the dynamic of gear system. And this kind of study helps in understanding the influence of gear errors, shape modifications, and mounting errors on gear dynamics. In 1994, Lin have investigated the several profile modifications and resulting from the dynamics. Basically, here are the various modifications is to be adopted by the researchers: linear profile modification as well as the parabolic profile modification. In some cases, we have the modification along the lead. So profile modification basically used to avoid the corner contact or in order to reduce the static transmission error. Static transmission error is the deviation of the position of the output gear from the idle position. So many researchers measure or static transmission error is one of the most indicator which specifies or which indicates the noise and vibration in the gear system. So next one is the Velix and method have studied the influence of shape deviations and mounting errors on gear dynamics. In the same year, Leo presented a computer simulation how the tooth addendum affects on the gear dynamics. Tooth addendum is one of the most important parameter as this affects on the contact ratio. Then the review made by the Osborne and Hauser and Wong give a comprehensive summary on models and approaches used in solution. So these are the various many researchers have proposed the different models and try to investigate the basic phenomena of the gear noise and vibration. So these are the various researchers. From this literature review, it is observed that even though the various or the many researchers have studied or developed the different models in order to predict the dynamic behavior of the gear pair by considering the different geometrical parameters. The current study or the current phenomena is not completely understood, and so that the present study or there is an opportunity to predict the dynamic behavior by varying the different geometrical parameters of the gear pair. So in this case, I have made the three gear pairs. One gear pair is the variation in the addendum. Normally, the addendum for 20-degree involute system, the addendum is 1 times of module. However, in this case, increasing the addendum and it becomes 1.1 times module. And in second gear pair, normally the backlash depending upon the speed as well as the module value and the center distance. So for 3 mm module gear and 150 center distance, the backlash is normally lies in between 100.1 to 0.125 mm. However, in this case, I have taken the backlash 0.15 to 0.175 mm, increasing the backlash in order to predict the effect of increasing of the backlash on the dynamic behavior. And test number spur gear pair number 3 consists. So normally from the base circle up to the tip of the tooth, we observe this curve is the involute profile. However, the profile linear profile modification, that is the long relief profile modification, is to be adopted and investigate the effect of profile modification on the dynamic behavior. So this is the table. You observe that the operating condition, that is the speed and the torque applied on the gear, all the three gear pairs are remains constant. The other parameters such as the module number of teeth, pressure angle, phase width, center distance, all these parameters remains constant. Only there is a variation for first year. There is a only variation in addendum. If we increase the addendum, ultimately that affects on the contact ratio and the point.
Sir, please conclude, sir.
Sir. So this is the finite element study I have done, and the results is to be obtained by using the finite element method. This is the experimental method is to be developed. Motor having 5 HP motor. Then this is the single stage gearbox, and the load is applied by using the wire rope dynamometer. Now this is the results obtained, experimental results obtained from the experimental test. Three tests are conducted, and the results are obtained. Now this is the table. Table number 4 shows the comparison of the experimental responses and the finite element response. The nature and the amplitude of the responses obtained from the experimental study and the finite element analysis study is similar. So in this case, the conclusion is that this one is the best method in order to select the level of the geometrical parameters in order to have or in order to generate the minimum vibration of the gear pair. So that is the conclusion, because we can, if we select the various parameters that mainly affects on the gear dynamics, so it is possible. So before designing the gears or before manufacturing the gears, it is possible to predict the dynamic response of the gear pair by varying the level of that particular parameter, geometrical parameters. So this is the.
Sir, any questions from the audience or from the judges? No. So thank you. Thank you. Next, we will have an online presentation by the paper titled Dynamic Vibration Absorbers Using Pendulum Structures by Mahadev B. Kumbhar, R.J. Desalve, V.J. Salonke from the Department of Technology, Shivaji University, Kolhapur, Department of Mechanical Engineering, Rajaram Bapu Institute of Technology, Rajaram Nagar, Islampur, Sangli, Department of Mechanical Engineering, FCRIT, Vashi. Kumbhar. Kumar sir, if you can hear me, you can begin your presentation. We have made you the presenter.
Yes, sir. Yes, sir. Good afternoon, respected faculty. I am Mahadev Kumbar from Department of Mechanical Engineering, Shivaji University, Kolhapur. My topic is dynamic vibration absorber using pendulum structure.
Hello, sir. Hello.
Hi,
Sorry
yes,
to, sir. Your PPT is not showing on the screen.
PPT. My screen is visible, sir?
No. Sir, 1 minute. So you're visible now.
Okay. My screen is visible, sir?
Yes, sir. Yes, sir.
Okay. Thank you, sir.
So if your camera is on, you can turn that on as well.
Okay, sir. Okay. So good afternoon, respected faculty. My topic is dynamic vibration absorber using pendulum structure. So the abstract is today the reduction of an uncontrolled vibration is gaining importance due to safety, environmental and economic reasons of regular lifestyle of human being. So these unwanted vibrations may be originated by heavy machines, shock loads, external causes like wind, traffic load, or earthquake and railway lines in an urban area. These are the major areas. So one of the best solution is to use a pendulum type dynamic vibration absorber. It is also a reliable design by adjusting any accolade parameter. Acceptable level of vibration control can be achieved. So the next slide is the classification of dynamic vibration absorber. So there are three major types: passive dynamic vibration absorber, active vibration absorber, and semi-active vibration absorber. So passive dynamic vibration absorber, where we can use conventional spring mass damper systems, where we cannot adjust any parameter. So that's why this is a conventional. And next one is active vibration absorber, where we can use actuating mechanism like servo mechanism, electromagnetic, electrohydraulic actuators we can use to control the vibrations in real-time control systems. So this is the integration of mechatronic system. So that's why this is costly. And the third one is semi-active vibration absorber. So there are four types. First one is variable steepness type dynamic vibration absorber, where we can adjust the steepness of our spring or material like our shape memory alloys, tunable beam filled with EMR fluid. These are the types of variable steepness type dynamic vibration absorber. Next one is variable damping type dynamic vibration absorber, where we can dissipate the structure energy like ER damper, EMR damper, electromagnetic damper. These are the examples of variable damping type dynamic vibration absorber. Third one is variable steepness and variable damping type dynamic vibration absorber, where we can adjust the steepness as well as damping properties like our air spring air damper systems. And fourth one is variable inertia type dynamic vibration absorber, where we can control the vibrations with the help of mass pendulum. So there are three types: oscillating motions using angular acceleration control, rectilinear motion using linear acceleration control, and oscillations motion using impact acceleration control. So these are the major types where we can control the vibrations with the help of pendulum. So this is my review article focused on these topics. Mostly we can control the vibration with the help of vibration isolations, vibration damping, and vibration absorber. Vibration isolations, where we can to prevent the transmission of vibration. Vibration damping, where dissipates the structure energy. And vibration absorber, where we can single degree of freedom systems control with the help of secondary system. This is called as the dynamic vibration absorber. So the next slide is oscillating motions using angular acceleration control, where we can angular acceleration control with the help of this pendulum. Here I have shown a single degree of freedom system, spring mass damper systems, and on that I have attached one secondary systems which can control the vibrations of our primary systems with the help of pendulum. So this is the figure shows design of high performance pendulum like adaptive tuned vibration absorber, supposed to be an effective device that can enhance the vibration absorption capacity and further increase resistance to fatigue damage. So detailed design and dynamic property of the pendulum like Adaptive tuned vibration absorber is reported. A multi-mode experimental platform is also discussed to investigate the practical vibration absorption performance. So I will show you one video. So this is a single degree of freedom system. So this is a single degree of freedom system. Swing mass damper. So when it goes on natural frequency, it will produce a large amplitude. So this is the unwanted vibrations produced at that natural frequency, and these vibrations I have absorbed with the help of secondary systems like our pendulum type tuned dynamic vibration absorber. I will show you. So this is the pendulum type tuned dynamic vibration absorber. I have attached on that, and I can control the vibrations of our primary systems. Thank you. So in this way, we can control the vibrations. This is my master project. So next slide. Next one is oscillating motion using angular accelerations control. Same example where we can control the vibrations with the help of pendulum tuned mass damper can replace the translation spring and damper system by a pendulum, which consists of a mass supported by a cable and is pivoted about a point as illustrated in figure. Such a system commonly modeled as a simple pendulum or small angular acceleration oscillations, it behaves similarly as a translation to the mass damper and can be modeled identically with an equivalent steepness and equivalent damping ratio. Hence, the design methodology for both the translation to the mass damper system and pendulum to the mass damper system are identical. The next example is overall dynamic and sphere of influence of magnetism for diverse periodic solutions of an autoparametric spring mass pendulum system. So example of nonlinear model coupling like pitch and roll motion in sheaves, surface waves in fluid containing cavities, where we can control the vibrations with the help of this pendulum. Next one is rectilinear motion using linear acceleration control, where I have shown two figures. The first type DVA moving in a perimeter way in right and left, and the second type, that is the DVA moving in the circular path like up and down. So these are the two examples I have shown here. So dynamics and control of the overall stick pendulum are pre-mediated. In pendulum structure, the gravitational force does not yield a moment about the vertical axis, thus varying the vertical component of the angular momentum by any controller action using interior forces, either through active or passive means, is intolerable. The next one is dynamic vibration absorber using pendulum. So this is same semi-active or smart tuned mass dampers by means of semi-active variable stiffness systems are more superior than tuned mass damper in plummeting the response of the prime structure. Likewise, the concept of smart tuned mass damper is additional, established and practical. So smart tuned mass dampers and adaptive pendulum tuned mass dampers executions in USA, Japan and China is presented. So systems with semi-active variable stiffness devices and STMD or APTMD are linear time varying systems. Henceforth, algorithms are desired for their credential and regulated. So the next example is oscillating motion using impact acceleration control. So where we have used pendulum impact to control the vibrations of our structures. So impact vibration absorber consists of an impact masses which is placed on the basic vibrating mass so that periodically collides with it. So pendulum vibration absorber are used in practice for decreasing of vibration level of different engineering structure such as flue pipes, television towers, bridges, high-rise buildings, aerial masts for shaft auto balancing and others. So these are the three major types with the help of inertia type control dynamic vibration absorber with the help of pendulum. So the conclusion is the various design concepts regarding pendulum type dynamic vibration have been reviewed based on their concept and practical applications. It is seen that due to the simplicity, easy of modification, and simple mathematical modeling, pendulum type dynamic vibration absorber has become a traditional track to customize and reduce vibration in recent innovation application in an engineering sector. Pendulum type dynamic vibration absorber is a fail-safe design and expected vibration control can be achieved by adjusting any complement parameter, and more novel design are being developed to meet modern demands. So these are the reference I have referred for this research article. Thank you, sir.
Thank you, sir. Any questions from the audience?
I have one suggestion.
So you can come here, sir, please. Mike, I see.
I think it's an excellent practical way of getting things done with the least effort, and it's a very good model. My suggestion is that you've done a very good job of the presentation, except the last spelling mistake on complement. It should be LEMENT, because complement, as you have written, is like telling yourself you've done a good job, but you actually have to put it as an engineering word, PLEMENT. Thank you. Excellent.
Okay, sir. Thank you.
Thank you very much, sir, for joining online. We'll now go to the next.
Okay, sir. Thank you.
All right. So because of time constraints, we are going to be concluding our session 5 over here. All the remaining papers and the sessions or whatever is according to the schedule will be now shifted to session number 6. And you can, those who are going to be presenting, you can come and meet me. I'll let you know about the detailed schedule. Now, I request Dr. Gambhir to give a token of appreciation to our keynote speaker, Dr. Edwin. Gambhir sir, one more. Gambhir sir, one more. So for our second paper presenter, Mr. Raut. Thank you, sir. With this, I request our session chair, Dr. Barai, to please conclude this session and just address the papers present.
Good afternoon, all. this session we had two very interesting papers. I think from yesterday we were listening to several papers on the basis of external techniques and condition monitoring. But this afternoon we had two interesting papers from academics on basics. I think that's the thing we should also look into, not always do experiment and try to analyze experimental data. So it was interesting, and I think Professor Raut couldn't speak fully, and he had a lot of information to provide. And then next gentleman, Professor Kumbar, he also talked about several experiments, but only one of the experiments he has demonstrated. But I feel it's a very good practice that for vibration separation we use some of the passive techniques, and they are more reliable and much easier to implement. Thank you all.
Thank you, sir. Now I've finished this session by requesting Mr. Kannan Rajan, for the Executive Life Planner from Tata AIG Life Insurance, to address the audience for the next 5 minutes.
I don't want to keep you waiting for lunch. No 5 minutes, please. Just, I want to thank the team of CDS. I think they have taken out of our static mode from COVID to a vibration mode now. That's very important. So it's indeed been a pleasure for me. I missed yesterday's morning sessions, and I really feel guilty about it. And I thank you all for having come all the way from all over India to make a presentation in Navi Mumbai, where I belong to. And it's been a pleasure sitting with you all and going back to my old school and college days, trying to understand fundamentals of our own existence. You know, I'm a retired guy, mentally retired. Okay, so when I sleep under a fan every day, the only one thing I wonder is, why is the fan making noise? These days I don't do any work except this. So I find that, there is a layer of dust that keeps sticking around the edges of the fan. And my only job is to keep cleaning it every week. I get up on the bed and I put my little fingers and clean it. And then I find that the vibration of the fan, as well as the noise, everything comes down. So this is what I wanted to share with you all, because I think vibration is now the need of the hour. Understanding vibration is the need of the hour. Enjoy your lunch, and I thank Dr. Pine and his team, and also the young Agnel team of technical staff who have made this entire presentation very interesting, very innovating, and something to think about. Thank you so much.
Thank you, everyone. So this concludes our session 5. Now I request everyone to go proceed for the canteen lunch. So
yes, canteen lunch at 2 o'clock. Please
yeah, please be back sharp at 2 o'clock.
Professor of Condition Monitoring in the Division of Operation and Maintenance Engineering at LTU, Loyola University of Technology, where he is coordinating several H2020 projects related to different aspects of cyber physical systems, Industry 4.0, IoT, or industrial big data. He was also involved in the SKF UTC Center located in Loyola, focused on smart bearings and also actively involved in national projects with the Swedish industry or funded by Swedish national agencies like Vinnova. He also principal researcher in Spain, heading the Maintenance and Reliability Research Group within the Division of Industry and Transport. He has authored more than 500 journals and conference papers, books and technical reports in the field of maintenance, working also as member of editorial board, scientific committees, and chairing in international journals and conferences, and actively participating in national and international committees for standardization and R&D in the topics of reliability and maintenance. In the international arena, he has been visiting professor in the Polytechnic of Bragança, Portugal, University of Valencia and NIU, USA, and the Pontificia de Chile. Currently, he is visiting professor in University of Sunderland, UK, University of Maryland, USA, and University in China. So I now invite speaker Diego Galar to address the audience on the topic of vibration analysis powered by industrial AI, APHM approach. So he's not present online right now, but he has sent his video. So we'll be playing his video.
With you in this vibration congress, and I'm really glad to deliver this keynote in your congress, and especially glad to be able to talk about my research topic, that is the vibration analysis powered by the industrial AI. My name is Professor Diego Galar from Luleå University of Technology, and again, thank you very much for the invitation to Invest 2022. Actually, the most important thing that I want to transmit in these 20-25 minutes that I'm going to be with you is that the vibration has been dramatically changed during Industry 4.0, because we have deployed so many accelerometers everywhere during these 10 years of industrial revolution that I would say that our industry has become data-driven industry. But the models that we are working in predictive maintenance with these technologies, with vibration analysis, are not new. We have been working for long with these models. Generating models based on our knowledge is not new. What is new is that we have deployed so many sensors that it's important to notice that we have been able to scale it up in such a way that hopefully in 10 years more, we will see a number of industries, most of them monitor with services like diagnosis and prognosis, even though now we cannot say that we have been successful deploying these techniques, because we had maybe more expectations in 2011 when we started the fourth industrial revolution. Remember that with the fourth industrial revolution, we have changed the customers. Now is the industry. But the pipelines, the data pipelines is the same. We are having same services, forecasting, nowcasting, early warnings, analytics-based maintenance. At the end of the day, we are getting the benefits of the consumers' good like Amazon, Google, etc., that they have provided so many benefits for us. And it's important to notice that with our vibration analysis, we expect to enlarge the lifespan of our machines and not to shut down our machines due to a breakdown or if it's not needed, in such a way that we gain some MTTF with the diagnosis and prognosis of our machines. Basically, we are gaining time, we are gaining availability. And this is crucial for us because if we are able to perform diagnosis, that is no casting, what is happening right now, and prognosis, when it's going to happen, then we will be able to deliver good quality services for the maintainers in order to know what to do and when to perform the maintenance in their actions. And for that, we have moved from different stages of maturity, from the traditional corrective maintenance that break it and then fix it, to preventive maintenance that, okay, let's prevent, let's spend time, let's spend money, but let's do something to prevent the failures, to the RCM, let's do where is necessary. The condition-based maintenance that maybe is the more rudimentary predictive maintenance that we can talk is based on the no casting, based on the current condition of the asset. And finally, the PHM, the prognostic health management that is based not on the current condition of the asset, however, it's based on the future condition of the asset and all the logistics to put the machine up and running again after the repair. Then the last ones are the most relevant ones. We are acting not in function of the condition of the machine right now, but in function of the condition of the machine in the future. And this is extremely important because we are moving towards some kind of paradigm where we are perceiving the symptoms like a vibration, but we are not acting in function of the current condition of the machine, but we try to predict the future condition of the machine in order to know what is the remaining useful life of that machine, delivering the function in a safe way. If we are doing that, we will be able actually to shift from the traditional maintenance, preventive and corrective, to the maintenance based on the condition and the PHM. But for that, we need to trust on the methods and we need to transfer confidence to the maintainers. That's why we have to see the evolution of the different techniques and how we have evolved with the different analytics in the Industry 4.0 with vibration analysis. I will mention several times the concept of digital twin. Digital twin is not a science fiction, it's not far away from the reality. But when we have some engine that is co-creating domain knowledge together with analytics, we can say that to some extent, we are twinning some properties of the machine. And this is actually what we want. What we want is a twin as a service provider that with our knowledge and with the data that we are getting from the field, both vibrations and also contextual data in terms of speed, rotation speed, etc., then we can issue one report with diagnosis and prognosis and therefore save quite much time and money for the companies. That's why it's important for us to agree that the digital twin is not something that is a 3D representation of our asset, however, is representing some properties of our asset and is connected to the physical product, for example, a centrifugal pump or a gearbox or something like this. In this case, when you are doing vibration analysis in the 4.0 era, what you have is actually one connected product with the accelerometer. You have a platform when you do the analytics, and you have the services that you develop with such platform. Therefore, you have the three ingredients to say that you are twinning, or you are at least having done some digital shadow of your asset in order to deliver diagnosis and prognosis. And remember that the digital twin is some kind of digital replica of some properties of the asset. And with the vibration, you are replicating one of the most important health parameters that the asset can issue in order to identify what is going on and identify when it's going to collapse. But what kind of analysis we can do? First of all, we can have stochastic digital twins. That is okay. Is the concept of all-in-one. Means that I'm taking a lot of vibration analysis. I'm taking data of this vibration analysis. I do statistics of the most popular failures, and I can infer that my fleet has this failure, and this failure. I'm talking about probability density functions for the different failures in large fleet. But if I want to do one-to-one, I mean one vibration analysis for one physical element, then I have real-time models, and it's a one-to-one collaboration. And in this case, where I'm issuing not probability density functions, but also one-to-one diagnostics and prognostics for the different digital twins. But remember that all the digital twins that we create with vibration and other sensors acquiring data from the field, the main purpose of that is provide what we call the ILS, the integrated logistics support, to perform the proper maintenance when needed and where is needed in order to have this kind of actions that minimize the shutdown of the machine. And if we take our vibration data, the raw data, the signal that are getting from the accelerometer, and you introduce this vibration in one machine learning just to detect any anomaly, any deviation from normality of that, is what we can call the digital twin 1.0. If you introduce the vibration data into some normality model, and you, for example, support vector machines or neural networks, and you just issue a warning if you have some kind of deviation from normality, this is the most basic digital twin with basic features, just raw data into the digital twin, and this is what we call descriptive analytics. The descriptive analytics is just say, this is normal and this is not normal. Doesn't mean that it's a failure, but looks like could be a failure. That's why this is the concept of descriptive analytics. And in many cases, we do it, and for example, if you use time synchronous average and you use some anomaly detection, you can issue a warning, good quality warning, when the anomaly is there, saying that, okay, the vibration that I'm getting now is not as used to be 30 days ago, 30 hours ago. Doesn't mean that I have a failure, but definitely the vibration has changed. This kind of anomaly detection is descriptive analytics, and is the most basic stuff that you can have when you are doing analytics. If you go one step forward to the diagnostic analytics, you identify that the failure is there because first you detected something is going wrong, and then you identify. And means that when you are able to create these normal and abnormal clusters that you can see there, what you are having is also the levels to say that this is the failure number 1, number 2, or whatever. This is diagnostic analytics, not only detection, but also identification of the failures and also localization of the failures. For that, you can see that we can cluster or classify our data according different features, and in function of the color and the cluster where the data is falling down, then we can say that, okay, if my data falls in the yellow zone or in the purple zone, the failure is number 2 or number 4. And then in function of the features, I can have this kind of clustering. But if you merge the vibration data with the actually the CMMS, the work orders, you bring the IT systems, then you are doing something else. You are creating what is a fusion between the operational technology data, that is the vibration data, together with the work orders. Work orders, that is the events that happen when you issue a warning. And this is important because the work orders is all the maintenance flow that you perform in a company in order to fix something. And when you consider all the maintenance flow in terms of preventive maintenance, corrective maintenance, reactive maintenance, then you are providing some meaning to some vibrations. Because actually, remember that if you have in the work orders some information regarding the actions performed in the machine, maybe this is relevant to identify what is going on with the machine. And this is very important to the work orders. You find explanation there, because maybe some change in the operational context force the vibration to increase, and some maintenance action dramatically decrease the vibration. If you trace that, you can have what we call the metadata as the OT and IT convergence data. And this is what we call the fingerprint of the data. When you are able to fuse the operational technology data together with the IT data, then we can say that you have the fingerprint of the data in order to identify what happened and when it happened, but with the contextual variables and the events of the maintenance actions. For example, if you take this kind of centrifugal pumps, where you have obviously some data coming from the sensor, like temperature, pressure, vibration, etc., but also some data coming from the IT systems, definitely doing this IT and OT convergence, what you do is the creation of a more sophisticated digital twin. Is the digital twin that I like to call 2.0, because this digital twin 2.0 is a digital twin through the convergence of the data of condition monitoring together with the data from the CMMS. And this data creates a metadata that is really valuable in order to exploit and do artificial intelligence based on that. And is much richer in information and much smaller in amount. Then it's a reduction of data in dimensionality, but much richer in information. In this case, remember that when we are doing vibration analysis, usually we do feature extraction, we do Fourier analysis, and in function of that, with the contextual scenarios that we can have, we have to filter out the false positives. But it's important to have the failure signature in order to issue the diagnosis. And in this case, it's important also to notice that the thresholds that we are using for that are extremely relevant. Extremely relevant. You know that many of these thresholds, they can come from the standards, but the standards, they don't consider many times this kind of contextual scenarios. That's why different operational scenarios, different situations may lead to different maintenance thresholds. That's why the health fingerprint is extremely important, because the health fingerprint, out of this health fingerprint of the failure before it happened, I can extract number of features. And if I record all these features that belong to the health fingerprint before the failure happened, then I can have a real fingerprint of the failure in order to recognize this when happen again. But features are very, very tough. And many times we cannot have so many features because doing the interpretation of so many features is difficult. That's why I recommend you to do some dimension reduction of the map of features with principal component analysis, for example, in order to keep the most relevant features. For example, here 70 features converted into 6, but keeping 92% of the information. Then I do a dimension reduction, but I keep 92% of the information, and it's much more to plot different cluster maps, etc. And once you have this, then it's easy. What is the failure? Then I create one ensemble. And why ensemble? Because I don't want to rely on one artificial intelligence technique. I use several like a bank of filters using KNN, using super vector machines, etc. And I use some voting technique in order to define what is going on. Then using 10, 12 classifiers together, you are able to decide that, okay, the failure is happening, is number 3, because 8 out of 10 classifiers are saying that. But if you want to move forward and you want to do not only diagnosis, but also prognosis, you want to do forecasting, it's important that you see that from anomaly detection up to prognosis, all the way up, there's a long way to go. And if we want to do remaining useful life estimation, we have to be aware that the features extraction, classification, and identification is not enough. We need to calculate the remaining useful life until the function is lost or the machine is broken. Then, how shall I go for that? I need also to merge with the artificial intelligence the domain knowledge. I need a co-creation between data science and knowledge. And for that, what I need, co-creating artificial intelligence and knowledge, what I need is to move from the comfort zone, the blue area that you can see here, to the red zone that you can see here. In few words, my friends, how you can see that a machine is going to degrade to advanced stages of degradation if you have never been there. It's important that we are able to detect the swan song. Remember that the swan is a funny animal that before dying makes a special sound. And this song, the one of the canary also, is something very specific. That's why we need to create hybrid models with data-driven and model-based together. These hybrid models are a merging process of the data-driven together with the physical ones, incorporating the physical knowledge to the data-driven, incorporating the physics of the failure, modeling data that maybe we don't have. And if we're able to do that, we will be able to have what we call virtual prototyping. Virtual prototyping is exactly that. It's modeling data of events that never happened before. And it's important that you use the traditional simulation techniques, but with one purpose. What we are doing is creating data, synthetic data of the failure modes that never happened before, in order to have data that is going to help us to detect these failure modes. Then I'm moving from this area to this area, incorporating data that not only the field data, but also data that comes from our background, our health knowledge. And if we incorporate that, incorporating data that I'm able to create from our failure mode effect analysis, data of failure modes that I don't have, but I can create with physical models synthetic data. And this synthetic data, for example, the simple case of a bearing, is able to increase my capability to perform diagnosis and prognosis, then definitely I will have been successful in the sense that I'm improving from my visibility of failures and predictability to something that is close to the overall universe of potential events. In few words, if you have data of 2 failure modes out of 10, and out of 10, I have 8 failure modes that I don't know how they look like, then let's articulate physics in order to have these failure modes at least identifiable by our methods. And this is important because we have now a multiphysics software like Modelica, DMOLA, MATLAB Simulink, Siemens, etc., that are able to create with, for example, multibody and other physical models to create synthetic data of different elements in different circumstances, and creating data with different level of damage, with different failures, different failure degradation stages. Then what we will be able to do is, to the data that we collect from the field, we will be able to incorporate also the synthetic data that we are creating with the multiphysics, and then we can use the traditional data-driven models in order to perform clustering, classification, and also forecasting of the data. And in this case, we can produce data that, if you see the difference between experimental and theoretical, is pretty good. Then there's no problem. We have the tools to produce data that really looks model and theoretical fairly good. Then what is the problem? There's no problem at all, because the data is not exactly the same data if the failure is happening in our machine. But if you extract 70 features out of this data, what you are getting is the DNA of this failure in such a way that when the failure happens in the real world, this DNA is already in your data sets, even though the data is synthetic. And then you will be able to detect and identify this failure, even though the failure never happened. And this is important because you can do this in many ways. For example, if you are doing with a centrifugal fan, you can do it with multiphysics, or you can do it directly, taking your spectrum and generating data, adding the peaks in the signals, as you know that the peaks should look like. And for example, for some kind of soft food, and if you take this kind of fingerprint and you create synthetic spectrum, the spectrum should look like this, enlarging the peaks of your spectrum and doing the inverse Fourier transform of that, you get a time domain signal modified by you in frequency, but with the characteristics of the failure that you expect to get. And in this regard, what you get is when you do the feature extraction, you get a number of features, synthetic and real, but they are pretty similar. And actually, the important thing is that the DNA of your signal is there. Then, even though, for example, the failure yellow or the advanced stage degradation red never happened before, I have created signals with such severity that when the real signal pop up and fall in this cloud of points, I will be able to say that, okay, most likely this is advanced stage of degradation of the failure number 2. This kind of incorporating knowledge in rudimentary way, like just adding additional peaks and doing the inverse Fourier transform, or with multiphysics software, is increasing the accuracy of our systems and the diagnosis and prognosis performance lot. But even though we may identify failure modes that are not visible in our FMECA, and the artificial intelligence should be able also to identify those failure modes and have the way to incorporate this knowledge and report it in the way of fracas, failure reporting, and other techniques, because maybe some failure modes have been neglected when doing the RAMS analysis. In summary, the data that we need is the data that we collect, the vibration, the knowledge that you all have about the equipment, that is a strong core knowledge, a strong domain knowledge, but also don't neglect the surprises. The surprises is something that is there. Surprises is when you neglect the first stages of the asset. That's why when we do digital twins and we do vibration analysis in these digital twins, we need a PLM approach. We need to have a life cycle perspective. A life cycle perspective that together with the data knowledge, to the data of the physical knowledge, to the data of the field, and the surprises, is going to give us the digital twin 4.0. The digital twin 4.0 is that one that the black swans, these unexpected events that we didn't know about them, is able to identify these black swans and incorporate the knowledge to the database of knowledge that we have and turn the swan into white. Then remember, digital twin 1.0, just machine learning, raw signal. 2.0, metadata when you have IT-OT convergence. 3.0, when you incorporate physics of the failure and you create synthetic data. And 4.0, when the digital twin is also able to recognize events via clustering that never happened before, and they are out of the scope of the failure mode effect analysis. If you consider all of the landscape of data, then you will have the digital twin 4.0 based on our favorite technique, that is vibration. Then, as concluding remarks, let me say that vibration powered by industrial AI, I could say that is the king, the technique most popular and most versatile in order to get these digital twins in the Industry 4.0 and deliver operational maintenance services. And also, if you don't have much data of failures, remember that data-driven solutions, when you lack data, can lead to catastrophic failures. Thank you very much. Thank you to the people in the conference. It has been a pleasure for me to be with you or with all you all today. And again, congratulations for your wonderful conference, Invest 2022. And of course, you have there my mail addresses and you can mail me for any problem. Thank you again and congratulations.
So anyone if having any questions, you can mail him directly on the mail IDs provided by him. So next, we'll be moving on to our next keynotes address speaker of session 4. So I've already introduced him to you, Dr. Naveen Garg. He's Senior Scientist and Head, Acoustics and Vibration, National Physical Laboratory, New Delhi. So he'll be presenting a paper on vibration standards and traceability chain in India, methodology, implications, and challenges ahead. So he's present online with us. Naveen, sir. You're mute, sir. Naveen, sir, please unmute yourself.
Good afternoon. Am I audible? Hello. Good afternoon. Am I audible?
Yes, sir. You are audible.
Yeah. Okay. Just let me share the screen. Is my screen visible?
Not yet.
Yeah, it's still not available.
Yeah, is it visible now?
Yeah. Yeah.
Yes, sir. Your presentation is visible.
Yeah. Yeah. Okay.
So just
good afternoon.
So just start a slideshow.
Yeah. Yeah, I think now it's okay.
No, not yet.
Screen is not visible.
Screen is visible, but the slideshow is not visible. So please press F5.
Yeah, I've already pressed it, but I don't know why it is coming so.
So you must have been shared this specific window.
Please unshare and share the whole screen again.
Okay. Now is it okay?
Still it is not on presentation mode. Slideshow has not started for us.
I don't know why it's coming so.
So share your whole screen.
Okay.
So when you get the share option, don't select presentation, share the option screen.
Just a minute.
Yes.
Now is it okay?
Yes.
Yes, sir. You can start.
Yeah. Okay. So very good afternoon to everybody, and I am very thankful to the organizers for giving me an opportunity to present my work in this conference related to vibration called as Invest 2022. So basically, I am from National Physical Laboratory, which is a CSIR organization. So I think most of you must be knowing about it. So National Physical Laboratory is actually the National Meteorology Institute of India. So by the act of the Parliament, the Parliament has given us the responsibility to maintain the national standards of all the fundamental units as well as the derived units. So in this regard, the acoustics and vibration standard, where I am working and presently heading the standard, we are responsible for realizing the national standards of sound pressure level and vibration amplitude. And we are giving the traceability to the entire country in this regard for the vibration measurements in the entire measurement frequency range ranging from low frequency to mid frequency and to high frequency. And apart from that, not only about disseminating the measurement standards, we are also providing various type of testing and calibration as well as R&D services to various clients. Maybe it may be government or private sectors, etc. And training services also. So today I'll be discussing basically about vibration standards, the traceability chain in India, how the measurement traceability chain is going on in this parameter throughout the country, the methodology realized, what are the implications and challenges that we are facing. So the contents of my presentation will be a brief introduction about this vibration methodology. What are the national primary and secondary standards that are being used for disseminating the traceability in the parameter of vibration, how the measurement methodology is done, what is the measurement uncertainty that is realized, and the status of calibration and measurement capabilities of India in this parameter as when compared to the international scenario, and what are the future challenges ahead and work in progress that is being done at CSR NPL. So vibration, I think most of you must be knowing it is a phenomenon of oscillating, reciprocating and other periodic motion of the rigid or elastic body from the state of equilibrium. And it is one of the essential field in the mechanical engineering problems. In fact, in past decade, many of the institutes are now having a special branch, or in design engineering, they are introducing noise, vibration and harshness in their curriculum. So this particular presentation aims to measure the sensitivity of the vibration sensors with the lowest levels of uncertainty of the measurement. That means we need to have highest levels of accuracy and precision in doing our measurements so that we can provide the accurate and precise measurements to various stakeholders, including the automotive sector, the heavy engineering industry, space and defense research. So the physical quantities that describe vibration are rectilinear displacement or velocity or acceleration. And there are two standards, vibration standards that we are realizing. One is the primary standard and other is the secondary standard. So primary standard is basically the standard that is having the highest levels of accuracy and precision, and which is based on some definite technology, that is proven technology, and it has to be in concurrence with all the international standards which are there for that particular parameter. The secondary standards are basically deriving their traceability through the primary standards, and these are being used by the industry for their routine testing, calibration and other activities. So this is actually, if you on this screen, you must be seeing two pictures. So this is actually the national primary vibration standard that we are realizing at CSR National Physical Laboratory India. So on the left hand side, you are seeing the system that is going from 0.1 hertz to 20 kilohertz. This is actually a system, a commercial system from Model Shop USA, and we call it as TMS 9155D system, having two shakers. One is the medium frequency shaker and another is the low frequency shaker. And we are able to realize from the complete 0.1 hertz to 20 kilohertz. That means we are able to calibrate whatever sensor, vibration sensor is there, velocity pickup is there, in there, whether it is charge or ICP type, in the frequency range from 0.1 hertz to 20 kilohertz. And on right hand side, you are seeing a picture of the medium frequency primary vibration standard that we had procured from HBK Denmark. Earlier it was BNK Denmark, and this system is ranging from 5 hertz to 5 kilohertz. So the basic methodology behind the system is actually the measurement of vibration using a laser interferometer. As so far, the laser interferometer is the proven technology to measure the vibration with the highest levels of accuracy and precision or we can say with the lowest levels of uncertainty. So this is actually the secondary calibration methodology, because when in the industry, particularly the automotive sector, the avionics sector, the heavy engineering industry, they are basically relying on the use of sensors, vibration sensors in day-to-day routine measurements. And every time they cannot have the laser calibrations, which is very costly also and time consuming also. So in that case, they have to follow a secondary calibration methodology, which is basically a fast method, and it is actually sometimes called as a back-to-back comparison method also. Where if you can see, this is actually the block diagram on the left hand side. There is a vibrator which we are used to excite, which we are exciting the vibrator in the entire measurement frequency range, say of interest from say 5 Hz to 20 kHz or 5 Hz to 10 kHz. And over that, there is a standard sensor which can be calibrated by a laser interferometer. And whatever sensor you want to calibrate, which you want to use in your day-to-day measurements, or if you want to integrate that sensor with a vibration analyzer or vibration meter, so all those things can be calibrated over the standard. And you have to just both of them. One is the reference and another is the device under calibration. They are basically mounted by the stud. On one is mounted on the face of on the head of the other, and this is called actually the back-to-back calibration. And both are being excited by the exciter at specified frequency range from say from 5 Hz to 10 kHz. And since these are the piezoelectric crystals, so basically the ratio of the voltage output will give you the ratio of the sensitivity. That is actually the principle behind that this type of calibration. And you can see on the right hand side, this is just a back-to-back mounted sensor, where the upper one is basically this device that is to be tested or calibrated, and the lower one is the reference standard, which is basically calibrated by the laser interferometer. So this is how the traceability is being realized, that this particular sensor, the lower one sensor, is being calibrated by the laser interferometer, and the upper sensor is being this is being calibrated using this master sensor. So once these two sensors are excited by the exciter, so the ratio of the sensitivity of these two sensors will be calculated by the ratio of the voltage output of the two sensors that we can measure in a voltmeter using a charge amplifier. And from that, since we are knowing the sensitivity of the reference transducer because it has been calibrated by the laser interferometer, so we can measure the sensitivity of the device under calibration. So this is how the traceability chain of vibration measurement is there. So at the apex is the primary vibration calibration standard, which is using the laser interferometer methodology. And from that, reference standards can reference accelerometer, we call them master accelerometer, or reference accelerometers can be calibrated. And from these reference accelerometers, we can calibrate our vibration meters, analyzers, accelerometers, velocity pickups, calibrators, and even the seismic sensors. So far, the primary vibration calibration standard is basically realized using a method called the sign approximation method. There is a separate ISO standard called as the ISO 16063 Part 11, which defines the protocol of these measurements, the methodology of these measurements, how we have to measure the uncertainties, etc. And secondary vibration standard, there is another protocol that is called the ISO 16063 Part 21. So whatever all the countries in fact, across the globe, they have to follow these two standards for realizing their vibration calibrations, because all these things have to follow these two standards. Otherwise, it cannot be they cannot claim their calibration and measurement capabilities at par with the other countries. So as I was telling you, we are using two shakers. So one is called the medium frequency shaker, or the high frequency shaker, which is actually, if you can see on the left hand side of the screen. So this is actually a low frequency, medium frequency and high frequency shaker, which can range from 5 Hz to 20 kHz. And on the right hand side is a low frequency shaker, which is actually specifically designed in such a way that it can go beyond up to 0.1 Hz, and maximum it can move up to 80 or 100 Hz. So while basically basically choosing these two shakers, the most important concept is the transfer sensitivity, because transfer sensitivity means that when we are exciting the shaker in one direction, so the voltage output should not be there in the other two. Say if you are exciting in Y or Z direction, so the voltage output should not be there in X or Y directions. So we have to reduce that transverse motion in the other directions. And while designing these two or deciding about which shaker has to be chosen, so we have to govern these. The transfer sensitivity of the shaker and transducer assembly is an important criteria. So you can see the exploded view of the low frequency shaker. This is a low frequency shaker actually, which is basically used for calibrating even the seismic sensors also. So as I was telling you that at present technology is that the helium neon laser. There are two types of helium neon laser. One can be homodyne or another can be an heterodyne laser, which is basically used at present almost in I think in almost all the countries for vibration measurements. And this figure shows the block diagram of this in Michelson interferometer with two retro reflectors. So the methodology is that there is a laser beam which is basically transformed into two laser beams by using a beam splitter then these two beams which are basically transmitted by the beam splitter. So one is being focused on the accelerometer, which is to be calibrated, and another is just passed into a retro reflector. So once that reflected beam from the surface of the accelerometer is then these two reflected beams are then passed on to a photo detector, where the two beams are basically combining to generate the fringes. From these fringes, we can calculate the displacement and the amplitude of the vibration. Now, this ISO standard actually says that there are three methods, but generally we are using the sign approximation method, where we are approximating the wave to be a sine wave, because from the sine wave it is possible to calculate not only the amplitude but also the phase. So we can get by simple mathematics, we can get the sensitivity of the transducer and what is the phase lag or phase shift. So this is actually the principle of using the heterodyne or a homodyne laser interferometer. At my laboratory, we are having both the laser interferometers. Only the difference lies in the fact that there is in the heterodyne there is a Bragg cell, while in a homodyne this type of optical part is not there. But essentially the principle behind both of the laser interferometers are almost same. And these two, once the signal is the two quadrature outputs are there. As I was telling you that the reflected beam from the accelerometer and another beam from the retro reflector, these are being combined, the fringes are being generated. And from these fringes generated in the photo detector, these are passed through a low pass and high pass filters, and which are being decoded by a PCI card. These are NI cards which are available for doing the signal processing. And from these cards, you can get after doing the digital filtering, we can get the amplitude and phase. So there is a particular algorithm called the phase unwrapping, where we are actually trying to adjust the phase so that we can minimize the error in the approximated sine wave. And we can get the clean signal with the highest levels of accuracy and precision, and we can find out the amplitude and the phase of the transducer. So basically we are just a minute. I think there is some issue in the internet. Yeah, so why laser interferometer? Basically, the question rises why we are using laser interferometer, because I think in most of the industry and automotive avionics sector is basically using the accelerometers only for measurement of their vibration. But the laser interferometer is having very lowest levels of repeatability, even less than 0.3%. It can be effectively used to control to measure the entire frequency range from 0.1 Hertz to 20 kilohertz. And this technology is used by all the national metrology institutes of the world. The uncertainty is very less as compared to the other methods, and also this using the reference transducers, the stability is very high because the drift of in the sensitivity is less than 0.5% in a span of say since I've done these measurements since past 8 years, so the drift is less than even 0.45%. And we are doing a lot of studies for improving further improving the accuracy and precision in this measurements, so that we can achieve the as far as we can achieve the highest levels of accuracy. We are using we are calibrating the voltage gains of the NI cards, which are being used for particularly for the low frequency region, because we have to calibrate the seismic transducers also. We are using some new methodologies for laser positioning, particularly the multi-point laser positioning approach. Where we are, if you can see the upper one figure, where you can see that we are focusing the laser beam on these different positions on the surface of on the armature of the accelerometer. Oh, sorry, the shaker. And these laser beams can then the average of all these positions will give you a very precise sensitivity of the transducers. Then there are some studies that we are undertaking for the different stiffness, contact stiffness of different armatures, particularly the beryllium and ceramic armatures that are being used by the manufacturers. And the ultra low frequency range, going up to 0.1 hertz, is really a very big challenge, because at 0.1 hertz the displacement is very low, and we have to have a very high signal processing. The accuracy in the signal processing should be very high, so that we can get very good accuracy. And this is very important, particularly for the seismic transducers. And we are using finite element methodology also for doing the transverse motion, the distortion, the eigen modes analysis of the shaker when it is excited at different frequencies. So this is just an example where on some studies that we are doing, like the online quadrature corrections, because these two, when the laser beam is passed from a beam splitter, and the two laser beams are allowed to they are generating a fringes, so we have to get a perfect circle between the quadrature should be perfect, so that our signal is very clean. So we do have to ensure that this particular perfect circle approach is there, and we are analyzing it using a software which is actually provided by the laser manufacturer. So if once this circle is complete, a perfect circle, then only we assume that our measurements are really very high accurate. And as I was telling you, that we are using also the finite element methodology, where we are trying to understand how the shaker is behaving at different frequencies and different amplitudes when it is being vibrated. Apart from that, we are also trying to develop some low frequency novel methods which are less time consuming as compared to the laser interferometer, because as I told you, the main drawback with the laser interferometer is that it's not very cost effective, and secondly it is very time consuming, particularly for the lower frequencies. So we have, with the help of manufacturer, we have tried to design a new approach which is called the optical encoder approach, which is actually used particularly for the tachometers, etc. And this technique we have used for calibration of the seismic transducer, and we found that it is having a same measurement uncertainty as compared to the laser interferometer, and it is also cost effective also. And we are doing some more further studies also in this regard, because currently we are able to only from realize on up to from range 0.1 hertz to 20 hertz. But we are hopeful that we'll be able to realize at least up to 80 or 100 hertz in due course of time. So this is how, as I was telling you, that the uncertainty plays a very important role in this part, because when we are comparing ourselves with the other countries, so the uncertainty is a very important issue. What type of accuracy and precision are we achieving on our system as compared to the other countries? That is a very important issue that we are always discussing when we are at the international platforms with discussing about our methodology and our traceability chain with the other countries. So this is how the primary standard is. You can see that the measurement uncertainty is somewhere from 0.3% to somewhere around 1.8%. And this is, we are always trying to reduce this as much as we can, and this is under the system is now under the upgradation process, and we are quite hopeful that we will be able to further reduce the measurement uncertainty to up to 1%. So the status of that is a very important issue. How far we are lying as compared to the other countries in vibration parameter. And I am happy to share with you that we have our vibration calibration and measurement capabilities. This calibration and measurement capabilities are a very important aspect when it comes to the metrology or the measurement traceability chain in a particular parameter. Actually, this is basically a measurement that is with a defined measurement uncertainty and with a which is following an international standard and which is being peer reviewed by an international expert. So these CMCs are very a sense of pride to any country because these are not easily achieved. There is a very rigorous process of getting the CMCs enlisted in this particular website of BIPM, which is the Bureau of International Weights and Measures at Paris. And I am happy to share that we have our CMCs in vibration, or 11 CMCs since January 2012, and we have 23 CMCs in sound in this part in BIPM website. So we are quite comparable with the other countries in the field of sound and vibration. And recently we participated in October 2018 for low frequency calibrations also, and we have successfully participated with NIM China. As a result, 2 or 3 CMCs in particularly for the low frequency. That means the seismic calibration is also will be soon enlisted in this particular website. So as I was telling you that we are always under the process of upgrading our measurement systems, reducing our measurement uncertainty, doing R&D on various aspects so that we can reduce we can enhance the signal to noise ratio, and we can take care of the challenges that are associated with our system. So there are various challenges like distortion, noise, and hum, particularly in the low frequency calibration, because as I was telling you, the displacement is very less. So in that frequency domain, so we generally encounter some issues associated with distortion, noise, and hum. Then at high frequencies also sometimes above 10 kilohertz, we have some issues due to shaker vibrations, etc., and material of the exciter. Then the low frequency calibrations validation, particularly because the analyzers that are measuring the low frequencies down to 0.1 hertz. So there is a traceability issue for those particular measurement range. So that is also a big challenge. Then we are doing some FEM studies so that we can take care of the contact resistance of the armature when different transducers are there mounted on either a beryllium armature or a ceramic armature, and we can find out the deviations when using these two armatures in this particular range. And the optical encoder technology that we have developed with in collaboration with the manufacturer, so that we can use this technology in the entire measurement frequency range, that can be very cost effective to the industry, and it will be less time consuming also. So I think I'm now going to conclude my presentation that this is just an example of how far we are our measurement uncertainties are there, in particularly in the low frequency range, and as it is ranging from 0.8 to 1.3%, and once from 5 hertz to 20 kilohertz, it is ranging up to 1.8%. And the future efforts, we are trying to reduce the measurement uncertainty to as much as we can by reducing the total harmonic distortion and improving the signal processing part. And we are also, the efforts are always in progress to participate with the other countries in international comparisons so that we can validate our measurements. And recently we are in progress with in January, we have to focus on a comparison with National Meteorology Institute of South Africa, and then in June, we have to participate in an international comparison with NMI Japan. So by this way, we are trying to validate our measurements, and we are trying to strengthen the measurement traceability chain in the entire country, so that all the stakeholders, they can take the benefit of having this strong measurement traceability chain in vibration parameter established in the country. Thank you very much. And I again thank all the organizers for giving me an opportunity to present my work in this workshop. Thank you very much.
Thank you, Naveen. Sir, anyone having any doubts? Sir, so now I would like to announce the technical session chair for this track, Engineer Rajashree Uchil, and two judges are Dr. Nitesh Yalve and Dr. Sanjay Rukande. So for this session, we have two invited authors and 4 papers and 2 corporate associates presentations. The next paper, I would like to invite Mr. Rao Manipalli from Chief Scientist, Colorado Springs, Leidos, USA. He will be presenting online a paper entitled Experiences in Developing Digital Twins of Legacy Mission Critical Aerospace Systems. Please present. We'll start the video. He will be available for answering the questions, but just presentation, he has sent a pre-recorded video that will be playing.
Good afternoon. My name is Rao Manepalli and I'm coming from the USA, Colorado Springs, Colorado. Today's topic is my experiences in developing the digital twins of mission critical aerospace systems. Weapon systems critical to the national security are increasingly becoming more complex and expensive. Most of the time, these are system of systems. A study estimated that the cost overruns alone makes it the second largest defense budget in the world. So DoD came up with a digital engineering initiative to revolutionize the way DoD weapon systems are designed, built, tested, maintained, and sustained. The crux of the digital engineering is the creation of computer-readable models to represent all aspects of the system and to support all the activities for the design, development, manufacture, and operation of the system throughout its life cycle. Digital twins are an important part of digital engineering. Even though the term is new, the concept is not new. For example, in 1963, when all the countries banned the nuclear tests in atmosphere, underwater, and space, the national labs like Lawrence Livermore Laboratories, they developed systems to see whether we can simulate and check whether these weapons really work when required. Highly complex system of systems are analyzed using distributed simulation of independently developed models using federations like high-level architecture and distributed interactive simulations. A digital twin is a virtual representation of a complex system. It can be used to predict the future performance. It spans the entire life cycle. It is updated from the real-time data from the physical twin. It uses simulation, machine learning, and reasoning to help decision making. The term is first used by NASA in 2010 to improve the model of simulation of a spacecraft. And the digital twin concept has been employed in healthcare sector, energy, and a lot of other areas. This is the NASA's concept of digital twin. It has a close relation between the real system and the virtual system, that is digital twin, and it integrates the high fidelity simulation, onboard data, and maintenance history, and all available historical data. And it is constantly updated. The digital twin is constantly updated using this data. Some of the examples of digital twin: an aircraft carrier, and a destroyer, and AFRL missile, and a city. Aegis ballistic missile defense system. These are some of the questions answered by the digital twin of the Aegis ballistic missile defense system. Some of them are: can it shoot down a satellite, though it was designed to shoot down an incoming missile? If one ship can handle N threats, how many threats two ships can handle? Is it 2 times N, or less than that, or greater than that? How the total number of threats handled changes if we use CEC, cooperative engagement capability. How these numbers change for launch on remote and engage on remote. How these numbers change for shoot, shoot, look, shoot, 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 look, shoot, and shoot, shoot, look, shoot, shoot. And how the probability of single shot kill changes if one radar is replaced by another radar, and how the probability of raid annihilation changes with one ship, two ships, and N ship. This is the video of Aegis ballistic missile defense system shooting down an ICBM. The digital twin was used to see whether it can do it or not. This is the digital twin Solstice for Solar System Test and Engineering site. We got 3 patents out of it. So we predicted how much is going to be the temperature of the oil on a particular day to less than 0.25%, that is within 1 degree centigrade. This is the digital twin we developed for concentrating solar power plant. We called it Restorm. And these are the things, okay? It looks like this, and these are the models we have integrated into that. And we actually used standard models developed by NREL, SAM, Solar Advisory Model, Thermoflow, and all of them. And we answered, okay, how we can optimize the design. This is the video replay of Restorm, the digital twin of the solar power plant. The digital twin we have built for the solar power plant has answered the following questions. How much it will cost to build a 295 megawatt power plant with government subsidies and without? And what would be the levelized cost of energy? Can we improve the ROI of any power plant by 8%? Can a new dispatch algorithm that takes into account the PPA, power purchase agreement, and time of the day pricing? Do we really need NREL's recommended 6 hours of storage? It uses molten salt that costs about $80 million per hour. Can we reduce the total cost of power plant by some 200 to 300 million from its original $1.8 billion? City of Barcelona in Spain, they are developing a digital twin for their city. So they will use that model which runs on a HPC, high performance computer, and it will see what will happen if I lay a new road, or if I have a new pathway or new walkway. This is one of the examples. This model is developed by RAND Corporation, and it analyzes the guerrilla engagements when there is weapons supported by another state actor and when they are not supported by them. There is a lot of confusion between digital engineering, model-based systems engineering, and digital twins. INCOSE, in their systems engineering book of knowledge, tried to clarify them. So it defined digital engineering as, and its relationship with MBSC, and digital engineering as a transformation and digital twins. The digital engineering strategy by DoD has 5 goals. Use models. Use them to provide the single source of enduring truth. incorporate technological innovations like machine learning, AI, establish the IT systems to support them, and transform the culture of the industry, which is the most difficult one. The digital engineering lists several models. You can see them, okay? There is a model for everything and anything. After the publication of DoD's Digital Engineering Initiative and its requirements that all the new acquisition programs should include the language of digital engineering, the Army, Navy, and all, they came up with their own vision of digital engineering. Some of their requirements are so broad, deep, and ambitious that trying to develop these digital system models will take a lot of money, and it will not only make Norm Augustine's 16th law, discussed in the next slide, a reality, but probably will move the target date from 2054 to 2044. So moving to the whole-scale digital engineering doesn't justify the ROI, but DoD requirements mandate digital engineering. Norm Augustine's laws. The Law 16 is the most cited one. It tells that by 2054, entire defense budget will only get one plane. I am fortunate to have him as my mentor. He was a former CEO of Lockheed Martin. We have developed a digital twin using Python, about 5,000 lines of code in 3 months for one person, and it answered some of the questions listed here. I'm not going to read all of them, but you can see, okay? So we actually have finalized the configuration based on the results from the digital twin. We have used it for the bandwidth analysis instead of data-driven, where you get everything that is available from the provider at the maximum rate and try to see what you are going to do with that. We actually used a concept called demand-driven versus data-driven. By that, we could drastically cut the size of the hardware requirements, bandwidth requirements. Using the digital twin, we studied several information fusion algorithms for our use, and some of them are listed here. One is UUIAC, that is an ONR term, Office of the Naval Research. Unstructured, uncertain, imprecise, incorrect, and even contradictory data. How do you fuse them? And Dempster-Schaeffer, Desert Summer-Deck, Kalman filter, extended Kalman filter, unscented Kalman filter, multi-hypothesis tracking, interacting multiple model, hidden Markov model, particle filter, deep neural network, recurrent neural network, convolutional neural network, and most accurate processing, all threatening, and special processing. You will see some of the pictures in the next slides. Kalman filter I developed while I was at ISRO for the star calibration of the PCMC radar, Precision Coherent Monopole C-band radar. These are for extended Kalman filter and unscented Kalman filter. We studied the efficacy of them and applicability for our job. This is multi-hypothesis tracking, interacting multiple model. Please note that the Python has modules, as they call the library, for each of them. So Python, as they say, it comes with the batteries. So most of the thing what you are going to do is already developed and available to you. Some more algorithms: hidden Markov model, particle filter. We used actually the particle filter in GPS OCX. These are different types of neural networks: deep neural network, recurrent, and convolutional neural network. Do we really need a digital twin? If we can really play with the real system and modify it and study how it behaves, then we don't need a digital twin. But most of the time, the answer is no. Because the real systems may not be built already, and it may be available for you. It may be expensive. You cannot just punch, let there be a digital twin without writing the code underlying the interface functions. This I took it from IEEE Computer. There are several ways to develop the digital twins. The most important lesson I have learned is that we need to do it incrementally, and we need to develop optimum fidelity and targeted to the question we need to answer. And don't get hung up on the tools. And these are pushed by the vendors, and there is no silver bullet. Follow the Unix culture. It is on the next slide. And remember, the end product has to answer your questions. Okay, not having some pretty pictures like model-based systems engineering. That is not the end product. And always think about round-trip engineering. That is, you start with the model, then generate the code and update the model using the code. Always validate with the real system whenever possible. Unix is the operating system developed at Bell Labs by Ken Thompson and Dennis Ritchie. And there is a Unix culture. First, let the machines do the work. And second, let other people do the work. Third, do the job in stages. And fourth, build the tools. And lastly, the most efficient way of doing any job is showing that it need not be done. Bell Labs has taught me some important things. One of them is don't be humble. You are not that great. Digital twins can quickly become evil twins. That is, they will produce the results and you believe in them and you make wrong decisions. Some of the reasons are not understanding the problem completely. And you have some initial successes and you think that that is going to give correct results for all. And overselling their usefulness by the developers. The man I see in the mirror is not an exception. And treating the digital twin as holier than thou. Okay, these are the things. How to prevent it? As they say in instrumentation, good measurement always needs someone who is skeptical about it. And it applies to digital twins also. Don't blindly believe the results. And this is where the feedback from the real system comes into the picture. If you remember NASA's concept of digital twin, there is always a constant feedback from the real system to refine that. And you have to monitor the system, okay? And this is where the vibration and sound come into the picture. They are the most useful, okay, and important parameters in monitoring the system. Use artificial intelligence and machine learning to analyze the logs, to analyze the byte data, that is built-in test equipment data, and training. Okay, you allow the system to learn both supervised and unsupervised. Finally, you have to constantly refine the model based on the feedback. I mean, it is not one way, though in some cases, the real system is not there and digital twin is the only way to do that. Thank you for attending. Now I will answer your questions.
Any delegates? Any delegates having any questions? Sir is available online to answer your questions. No questions, Rao sir. Thank you really very much.
Fascinating presentation.
Yes. Now I request our next invited author, Engineer Madhusudan Nagarajan, Diagnostics Engineering, Bengaluru. He'll be presenting paper on vibration analysis of rotary machines, cases of turbine diagnostics and solutions.
Just move this because I have to move between my laptop. So I have to come out of the presentation and show some videos so that you are directly working. Yeah, yeah.
Good afternoon. Today I'll be presenting a few industrial case studies. Most of the case studies are related to resonance. Now, I will just explain you the kind of resonance that we come across in case of the rotating machinery equipments, and how do we approach the problem, scientifically see the problem, understand the problem, and go for the rectification. So I have some 6 case studies. I will try to present up to 5 case studies, and if time permits, we will go for the 6th case study also. Okay. So I have few videos in between which I will be playing, where you can see the physical vibration of the rotating equipment, and accordingly how we go for the measurements and different kinds of measurement techniques also. Now my first case study is from an automotive plant. So the vibration study and the diagnosis of a phosphating pump 2, the speed is around 3000 RPM. So there were 2 pumps actually, out of which the pump number 2 was vibrating very heavily. And we just went through we did an inspection, and the first thing what we observed is pump was sitting on a loose mounting. That means you must have heard of the soft foot. So what I did is I just passed a A4 size sheet paper below the foundation. So it was just moving very freely. So that is a clear indication that there is a soft foot problem in the pump. Okay. So what we did is we just used a very good nylon material. Okay. And we just went for the grouting of this particular pump. So the resonance problem, whatever we have seen earlier, that has automatically brought down. We were able to bring down the resonance issue, and almost about 60 to 70% of the vibration problem came down. So the next thing what we did is, whatever the remaining amount of vibration, we observed that there was an unbalance in the pump, and we added about 7.5 grams of the weight on the motor cooling fan, and totally the vibrations came down. So there are 2 different techniques we adopted here. One is reduce the resonance issue and then go for the balancing of that particular cooling fan of the pump, and we were able to bring down the vibration level. So I'll just explain you what exactly we did here. Yeah, this is the vibration levels. So this is the vibration levels you can see here. Before the corrections, you can see the motor outboard vertical vibration was almost reaching up to 16 to 17 mm per second. So that was the vibration levels. And after the corrections, we were able to bring down the vibrations levels to around 2.73. Apart from that, you can see other vibrations also coming down. So if you carefully watch here, you can see here there is a lot of difference between the horizontal and the vertical vibrations. That means it is a directional energy. The high energy was seen only, maximum was seen along the vertical and the axial direction. So after the required modifications carried out, we were able to bring down the vibration level to the acceptable limits. Now, in the next, before that, I will just show you. See, this is the pump test results, the resonance test or the natural frequency measurements, what we did. You can see here, the natural frequency was around 54 Hertz. The speed of the motor is around 3000. So we are just 4 Hertz away from the operating frequency, right? It is something like a wideband frequency. Now, once I inserted that particular nylon material and went for the grouting, you can see in the bottom plot, the 54 Hertz totally went off. Okay, that means I have cleared off the resonance band. Now I have only the unbalanced value, which I have corrected by adding a 7.5 grams of weight on the motor. Okay, so a combination of the resonance issue, the soft foot issue, and the balancing issue, totally 3 faults, we were able to clear it out and bring down the vibration levels. So it is very unfortunate to see that there is absolutely no proper this one for the maintenance team or the production team, because most of the time they are only interested in the production part and nobody takes care of the rotating equipments. Okay, I'll just show you one small video how the machine was when this machine was just sitting adjacent to this particular pump, and I'll show you how neglected this machine is. See here, you can see there is absolutely no grouting at all, and the entire pump is moving to and fro. So this is how the people are maintaining their equipments, and it is very unfortunate to see the rotating equipment in this condition. Okay. Just go back to my. Yeah. So this is the plot, the before balancing and the after balancing. You can see the 1x plot. Before balancing is the red one, and the blue is the plot which is the balance after balancing. We are providing the corrections. Okay. So my next study will be on the in a cement plant, vibration study and diagnosis of a classifier. This is a 3050 diameter classifier used in a cement plant. Basically, it is known as centrifuge also. It is a separator basically, right? Now, there are two cases, two things here. One is we did the balancing at shop conditions. Okay, you please see the difference in speed. At shop conditions, the balancing speed was only 140 RPM. Then I asked the customer, what is the speed that you are going to run at site? So he told 300 RPM. Then I told them we have to run the motor at 300 RPM. That means we have to run the classifier at 300 RPM. Then he told, no, my motor is not having that much capacity. So you please carry out the balancing at 140 RPM. Even at site also it will be fine, okay. Then I said, okay, because we don't have options. So we did the balancing at shop. This is the shop. So this is the temporary arrangement, mounting arrangement, what they do. So we did the balancing. So my vibrations was not much. So before balancing and after balancing, some about 850 to 900 grams weight was added, and we could able to bring down the vibration levels. Now the same machine went to site, and it is a big structure, right? So the entire machine was mounted on the big structure. And when they rolled the machine at 300 RPM, just see what happened to vibrations. Okay, so the vibrations went up very high, almost reaching about 28 ml per second. So again, we were called to investigate what exactly went wrong between the shop conditions and the site conditions. Okay, so I'll just show you. So at site conditions, we did all the measurements. We generated the cascade plots, or what we call it as the waterfall plots. You can see here, they went up to 300 RPM, and then we took the cascade plot, and as soon as the RPM drops below 250 to 200 RPM, suddenly the vibrations also drop. Okay, so that was an indication that there is a possibility of maybe a local resonance or a structural resonance. So we went for the further investigation. Yeah, so this is the machine, what I have carried out the balancing at shop. So it is sitting on maybe at somewhere about first floor or second floor, that is a height. So what the customer did is he used all the angles, L brackets, everything, and he did the welding wherever he wanted. So his intention is if I provide welding or if I provide the angles, automatically the vibrations are going to come down. But totally that is a wrong approach, because without this way of scientific approach, we are never supposed to give any kind of these kind of brackets or the L angles. Okay, so we just watched the movement of the machine, in which direction it is moving. Okay, I'll just present it that video for you. Just this. So this is the video where you can see the actual machine, how it is moving. That is a motor, and that is a driven pulley which is driving the centrifuge. And you can see here the whole structure is moving to and fro. It is a low frequency oscillation. 300 RPM means around 10 hertz. Okay, you can see I'm just standing on that particular structure only, and you can see how the whole structure is moving. Okay. Now what we did is, we observed the directional energy, in which direction the movement is more. So I just went through the entire structure, went around, and I observed that these two particular angles look somewhat very odd for me. So I just asked the customer, and he told, yes, these are all the two structure angles we just welded. So I just told them just to disconnect it. Okay. So we went for the disconnect, And apart from that, we just after disconnecting, we added about 850 grams of the correction weight to bring down the vibration levels further. Okay, next slide. Yeah, you can see here, before disconnecting the cross channel, we could able to go only up to 255 RPM, and you just see the vibration levels reaching almost up to 34 mm per second. So after disconnecting the channel, you can see automatically the vibration levels came down and we could able to go up to 310 RPM. So it is a direct indication of a local structural resonance coming into picture and disturbing our whole settings. Okay, so then this is what I want. I told them, yes, somewhere about here we have a small resonance, but no need to worry because our final speed was about 300 RPM. So at 300 RPM, we could able to balance it and bring down the vibration levels further down. Next slide. Yeah, you can see here before and after balancing, you can see this is what my final achievement of the vibration levels. Okay. So different measurement technique, different troubleshooting techniques needs to be adopted. And then when we go for a scientific approach, definitely we could able to achieve the results. Let it be any kind of rotating machine. Speed is not a matter at all for us. Okay. But step by step, we need to go step by step. We are not supposed to go for any additional welding or additional adding of any this one, something like that. Okay. So scientific approach will tell us that yes, this is the way of approaching the problem, and this is how we can able to bring down the vibration levels. Next. Yeah, so just a graphical representation plots before balancing and after balancing. You can see here nothing is there. Okay. Next. So this is my next very important case study. This is for MDF boards unit. This is an ID fan. Okay, the speed is 994 RPM. I will tell you a very good story on this. Now this is the fan on the both sides. So the photograph showing the either side of the fan, the direct coupled motor coupling, and then we have two bearings. It is an overhanging fan, and next we have the ID fan. Okay, next. So the first visit I made in 26/11/2020, and you can see the vibration levels, sir. 100, almost reaching 100 mm per second. Okay. So then I just did all the measurements. Bode plots were generated, and I brought down the vibration level to 6.4 mm per second. So there itself, I got the first down. I told the customer, because customer told this is a very critical equipment for my plant, so I need to take care. I told, please take care of this machine. So this problem will again occur. Never allow, because it is a very sensitive machine. So never allow the vibration levels to exceed beyond certain point, certain limits. Okay, so what happens? Just one day before, about 26/1/2022, full night vibration levels were running at 180 mm per second. Nobody noticed. Okay, so some problem has occurred. So the whole one shift night, the vibration levels were almost running up to 180 mm per second. Next day morning, I got a call. So we have switched off the machine. Please come down. Okay, the whole plant is off. Okay, so I went up. I went to the plant. Next. You can see here, sir. 180 and the result of 180 mm per second. So the total plumber blocks, the front fan, non-drive and bearing plumber blocks were cracked. So how can you expect the precision, the accuracy, the very low vibration levels for this plant? Okay, just I want to play this video. Just split double. So I was standing on that particular concrete block and I took the, you can see here. So luckily my accelerometer did not fall down. Okay, so 180 mm per second value, energy, so much high energy, we cannot just imagine. And that is the reason why the cracks have developed. So what the customer told, no, our production is there. So we want to run this machine. I told it is not possible. So then what he did is he filled the cracks with welding. Okay, so he temporary arrangement. He has to do some temporary arrangement. Next slide, please. Yeah, so this is the theory what we are seeing. So when the stiffness is changing, accordingly, the response will also change. Okay, next slide. Yeah, you can see here, sir. So this is the with cracks. the vibration levels went up to almost, you can see here, 230 mm per second. Okay, so then the cracks were filled. You can see here, this fellow got shifted near rated RPM itself. Okay, so after filling the cracks, what we were not supposed to get, we were able to, he got with this one and the cracks got filled, the resonance got shifted and it was near rated RPM. I told it is not possible, what you are doing is not correct. Then he told somehow manage. Then with great difficulty, we took Bode plots and we were able to add some weights and bring down the vibration levels to some for a limited value, but we were not happy. Okay, so 650 grams of the correction weight was added. So the before the balancing, and this is what we could able to achieve after balancing, only up to 30 to 32 mm per second. That is the last. Beyond that, I could not able to achieve. So I told customer, maybe another few days or few weeks you can run, because this fellow will again create problems. So for them there is no choice. Next. So these are the results before they went for a new fan with a new shaft. Okay, and you see the result. Plant invested 28 lakhs to bring down the new fan along with the shaft and the bearings. This is the result, and this is how they are. This one about the production. So they want only production, not bothered about the rotating machinery health aspect or other aspects. Okay, so this is finally we end up like this. We know there is a problem, but we could not able to take up the corrective action well in time. Neglected, the machine was neglected, and it was running at a very high vibrations. Finally, we end up problems like this. Okay, too much of cost involved. Next. So this is one study for a 6.8 megawatt generator for a paper industry. So there was a change in the some turbine kilowatt rating. So the new turbine was brought, but unfortunately the generator level, the foundation level was not sufficient. So they lifted the generator to a certain height by providing this kind of structure. Okay, so shaft vibrations were absolutely fine. Now the worry is only about the casing vibrations, that too near the generator drive end and generator non-drive end, and that too only along the horizontal direction. Okay, so we were called, we just went there, but before that we just made some theoretical calculations and trying to understand what exactly is happening on the generator non-drive end and generator drive end only along the horizontal direction. Okay, next. So these are all the measurement results. You can see the 1x component showing up only along the horizontal, while vertical and axial is absolutely fine. Next. Yeah, so bump tests were done. So I could not see any frequency closer to the this one on the structure. Okay, so the first doubt, because the structure is the new fellow coming in. Generator is basically designed as per the earlier this one. The structure is a new modification done, and yeah, wait, it's coming. Oh, go back. Automatically going. Yeah. So the structure is, we could not able to see any 25 hertz frequency because generator operating speed is 1500 RPM. That means 25 hertz is the operating frequency. Now 119 hertz is quite far away from this one, so structure is absolutely not an issue. So it is the combination of the structure plus the generator body which might be creating this kind of issue. That is the first suspect what we got. Next. So when we did a bump test on the generator non-drive end along horizontal direction, one particular frequency was appearing at 25 hertz. Okay, so there are totally 3 frequencies: 17 hertz, 26 hertz, and 40 hertz. These are all the 3 natural frequencies that appear on the generator non-drive end casing. Okay, so this is the reason. So we call this as the local resonance. Okay, that means it will not affect your shaft vibrations, but it will affect only your field vibrations. Okay, so one more important point I would like to highlight, because in most of the power plants, people only see the shaft vibrations. They are not at all bothered about the housing vibrations. They say housing vibrations, they are not worried. They only want shaft vibrations. If it is within 25 or 30 microns, they say, well, fine. Okay, so but for us, for vibration people, both shaft as well as housing vibrations are equally important. Okay, now you can see here, this is the first suspect, 26.66 hertz, very close to 25 hertz. So this is the main reason why the excitation levels were very high whenever the speed approaches 1500 RPM. Next. So this is the cascade plot. You can see it is just exactly following what I have tested during the bump test. That means at 1350 RPM, there is a sudden drop. Again, near 17 Hertz, that means about 1020 RPM. Again, there is a hike and again, there is a drop. So both my cascade plot measurements and my bump test results are matching. Okay, so it is just following as per the measurements. So then we were trying to analyze what exactly is happening. So the theoretical calculations were made. Okay, next. The theoretical calculations were made and we found that through finite element analysis, we are seeing at 26.6 Hertz as the resonant frequency on the generator non-driver. Okay, I'll just present it for you. So this is a Bode plot. You can again see here the 1x plot going high and then dropping. And as it approaches the 1500 RPM, again it is going high. Now we need to find out what is the corrective action to be taken for this kind of problem. Next. So customer insisted we will give a stiffening. I told no, this is not the right way. If you try to stiffen from the same body to body, it will not have any influence at all. You have to give an external stiffness, right? So you cannot support the same bearing with respect to the same generator body. So it didn't work out for us. So the next observation is, you can see here, lot of shims, the loose shims were there and they were giving around 6 to 7 shims or something like that. So a lot of problems related to the mounting conditions also. Okay, next. Yeah, you can see here, this is the frequency spectrum. So the 1x component was visible along with the 12x component. So there were 12 mounting bolts, the plates that were supporting the generator body, and that 12x component is also getting added and it is giving a further excitation to the whole system. Okay, next. Yeah, this is the time waveform. You can see here, it is going around 12 events. Okay, in one cycle, there are 12 events. Okay, if you can count, there are 12 events coming in the time waveform. So the frequency measurements and the time waveform will also tell us where is the source of vibration for us. Okay, next. So this, we just did the model analysis. Okay, and through ODS measurements were also done to identify how the movement looks like, the behavior looks like. And you can see here, these are all the shims what I was indicating. Lot of shims were provided, which is creating something like a looseness. Okay, so I just want to play these two videos. So the first video will give you the ODS measurements of the generator ND movement at 25 Hertz. You can see here, sir. So this is how the structure is moving, and this is how this one is moving. Okay, so yeah, play again. Yeah, you can see here the front one is the generator drive and the back one is the generator non-drive. So to just cross check, we did the video based ODS also. Okay, escape. Yeah, this is the video based ODS. You can see here. Just make it big. Yeah, you can see here. Just can you just play again? Yeah, you can see here the whole generator non-drive end is moving something like this. Okay, so the movement is something like this. So the video based ODS and the model ODS, theoretical ODS were taken into consideration and observed the movement of the generator non-drive end. Okay, so then the calculations were made through finite element analysis. Okay, so the structure was modified. Next slide, please. So the structure was modified. Yeah, these are all my observations, what I have written. So both ODS and data and model analysis were done. So anyway, whatever I have explained, the same this one. Next slide, please. Yeah, so this was the theoretical calculation through finite element analysis. And we can see here the frequency, the theoretical frequency exactly match with the practical orientation approach what we did at site. So there we are also getting theoretically 27.2 Hertz. We got about 26.66 Hertz. Okay, so this is the main reason why vibration levels were high at rated RPM. Okay, next. So the modifications were done, and these are all the specifications what has been achieved, and the packer plates were given. All the loose shims were removed. Okay, so we could able to move the frequency from 26.12 Hertz to 30.457 Hertz. That means about 3 to 3.5 Hertz away from the operating speed we moved. So 25 Hertz is now safe. because it is not a wideband frequency, it is a narrowband frequency. If you see the bump test results, it is a narrowband frequency. So almost we moved by 5 to 5.5 hertz away from the operating frequency. Next slide. So we could able to clearly got the results from 5 to 4 mm per second. We got about 1.2 to 1.3 mm per second. Okay, so the through bump test results, through theoretical FEA calculations, video-based ODS and theoretical ODS, finally we could able to achieve the results. Okay, so that's next slide, please. So this will be my last case study. So the vibration study and diagnosis of ACC fans. This is for a Ultratech cements. So where they have these cooling fans. Okay, so for these boiler pipelines for cooling. Now there are totally 12 fans, out of which 10 fans came from one manufacturer and 2 fans came from the different manufacturer. Okay, so these 2 fans started giving vibration problems at site. Okay, so we were just called. Yes, next slide. So this is just the history. Fan number 7 and 8 of the TG1 and TG2 are having aluminum plates. Okay, this is the difference. And shim type coupling were used, and along with the blades and pin type of coupling has been used. Okay, next. So this is the diagram how the fan looks like. So the fan, there is a bridge. So if you go and stand on the bridge, so you can see the fan rotating below. Okay. Now you can see here, this is the motor, this is the gearbox, and this is the fan. So the complaint was high vibrations were observed on the motor non-drive end. Okay. So in the normal practice, we think that motor non-drive end is in the overhanging position and it is bound to vibrate. But if you look into the vibration, we don't assume that it is because of overhanging. Okay. I'll show you the vibrations next. So initially when we measured the vibrations, the motor non-driven vertical was almost close to 27 to 28 mm per second. Heavy vibration. Okay. So we just took an example of ACC fan number 8 and horizontal, vertical and axial measurements were done. So absolutely gearbox looks to be okay. Okay. Next. Yeah, this is where our first measurement will come into picture, the bridge. So where this fan is located, it is mounted, the whole gearbox is bolted to the bridge, and the bridge was very heavily vibrating. So almost about 100 to 120 mm per second. That was the bridge vibration. Okay. So we did the pump test on the bridge. So this is in the center of the bridge, we have the highest vibrations. Okay. So we did the pump test on the bridge, and the frequency, natural frequency observed was 10.5 hertz. See, normally as a vibration people, what normally we think the natural frequency, we will search for 1x component. That means this natural frequency may be somewhere closer to any of the operating speed of the machine, right? Or the multiples of the operating speed of the machine, 2x or 3x. But this was very, very tricky for us. So the first indication was we came to know that there is a 10.5 hertz natural frequency on the bridge. Okay, next. Yeah, you can see here. So during summer, they want full speed, but whereas during winter, I think they could able to manage with this speed. But the problem is whenever they go for 1500 RPM, just see the difference. For 100 RPM difference, the vibration levels went up by 4 times. So the first indication was at 1500 RPM, something is exciting the bridge. Am I right, sir? At 1500 RPM, something is exciting the bridge, and you can clearly see the plot here. So there is an exponential increase of the vibration levels at 1500 RPM. So the next question is, what is making the bridge to vibrate? Because motor RPM is 1500, that means 25 hertz. Okay, but we searched everything, we look into the gearbox. It is a simple gearbox, right? A pinion and a bull gear. So nothing was found there. Next. Yeah, you can see here. This is the bridge vibration, sir. 111. If you go and stand on the bridge, you feel like shaking. Okay, so much was the vibration levels at 10.5 hertz. Next. Now this is the cascade plot we generated. You see here, suddenly from 1400 to 1500 RPM, 10.5 hertz jumped up. Okay, so we need to now track it. What exactly is 10.5 hertz? Next. Yeah. So what I did is, I just inserted 2 wooden blocks. Okay. So I just on one side of the motor and on the other side of the motor, maximum stiffness I gave near the motor non-drive end. Okay. So one side it is supporting the bridge, another side it is supporting the motor non-drive end. Okay. So when I did it, automatically you can see here the vibration levels drop down from 56 to 11 mm per second. Okay. So that indicates that something is happening between the motor and the bridge. So whether motor is the culprit or bridge is the culprit. That is the next question. Okay. But we could able to get something. We could, at least we are moving towards the result. Okay. So almost 5 times the vibration levels came down. Next. Yeah. You can see here we did a measurement again with stiffness and without stiffness. Okay. You can see all the vibrations were reducing. Okay. So 12 became 8, 27 became 11. So now next we started tracking what exactly is happening. Next. Yeah. So this is the plot. So without with wood stiffness, so this particular 10.5 hertz disappeared from the spectrum. Okay. Next. Now this is interesting. Now you see here, this is the ratio 1:13.87. That means when the motor runs at 1500 RPM, your fan runs at somewhere about 104 to 105 RPM. Now you can see here, sorry, 107. That means 1.783 hertz is the operating speed of the fan. Right? At full speed, when the motor runs at 1500 RPM, my fan runs at 107 RPM or 1.783. And we counted the number of blades on the fan. So there were totally 6 blades on the fan. You please watch here, sir. 1.783 multiplied by 6 gives rise to 10.7. That means the flow induced pattern or the flow induced vibrations of the fan was exciting the bridge. You're getting my point. So the bridge natural frequency was 10.7 hertz. Whenever the uneven airflow of the 6 blades, the flow coming in my direction, in the direction of the motor, so it is coming in my direction. So whenever it comes in that direction, 10.7 hertz is the frequency, that is because of the vane pass frequency or the flow fan blade frequency, correct? So 10.7 hertz is the bridge natural frequency. So the vane pass frequency or the VPF is exciting the bridge natural frequency. So how, when I gave the wooden stiffness, what exactly happened? When I gave the wooden stiffness, what is the physical change that I could able to make out? Yes, that means I changed the bridge natural frequency. When I gave the wooden stiffness, the bridge natural frequency changed, but the fan continued to give the same flow, but bridge natural frequency is maybe 11 hertz or 12 hertz, so the vibration levels dropped. Yeah, we are giving a stiffener. That means this is what we do here is we give some temporary arrangement at site just to cross check whether it will work or not. Because I cannot directly bring some metal and go for welding. I cannot do that. Whatever the temporary arrangement available at site, I will just try to introduce that and see what happens to my results. That is what I have done. Okay, next. So we went for the final theoretical calculations. So this is the bridge model, what we did. And we recommended some modifications. Next. Yeah, so these are all the new design that we recommended. So go for the different kinds of supports and stiffening parameters, and we could able to shift the bridge natural frequency. Next. Yeah, you can see here, this was the old design and these are all the modes. And you can see here 10.3 hertz. So for the new design, the first frequency started from 13.5. So that means the bridge is never seeing the 10 hertz or the 11 hertz in this case, because the first frequency itself is 13.5 hertz. So even there is a VPF, it will never excite the bridge at all. Okay, next. So this is one more diagram for the modifications data. Next. Yeah. So you can see here, this is the this one results. You can see the old design. Okay, so the new design, the frequencies starts after 13 to 14. And these are all my readings after modification. That means at full speed, I could able to achieve fan motor non-drive and 2.6, 2.8, and 1.9. Okay. So any kind of problem, we need to go through theoretical or the practical approach. So that is a lesson. Okay. So I have seen customers doing taking angles and doing welding, all kinds of sorts, but finally we end up nowhere, like what we saw in that ID fan case. Okay. Yeah, next. So just so I think I'll be concluding this. So this is what my company deals with. So we deal with all these kinds of different services. And for the modal analysis or the ODS, whatever I have shown here. So my colleague, Mr. Ramkrishna is here. He is having around 30 years of experience in modal analysis and ODS based. He is ex-engineer. So he supports me in all these kind of different techniques where through measurements, through different kinds of analysis techniques, we could able to achieve results and give the good machine to the customer with vibration levels coming in the permissible limits. Okay. So I thank all the organizers and Dr. Gambhir, Dr. Fine and Dr. Code for providing me an opportunity to come on stage and presenting these case studies for the whole group. Thank you very much. Thank you, sir.
It is very nice, all very simple way, nicely tabulated. The process you have to one after another, it has come to everybody's heart with exhibit by this.
Yeah.
So that's fantastic.
Thank you, sir.
All the case studies are good. It is not that stiffness and mass. Think it over, but taken the scientific stuff.
Thank you, sir. Thank you.
That's fine.
Thank you, sir. Thank you.
And I'm telling you, 80% industrial problem is and it is happening.
Yeah.
People that don't work come, balancing, come, alignment. Come.
Yeah. Correct.
So that is the thing that done sustained, I think, is a very nice.
Yeah.
First of all, let me extend my sincere thanks to you for providing a lot of enriching examples. So we could relate it very much actually.
Yeah.
So my question is actually you have taken for all the vibration measurement the velocity data, right? Millimeter per second.
Yes.
So instead of that one, we could also even take this displacement or acceleration also. So why only velocity data?
No, see, most of the Indian standards, we are more comfortable with velocity vibrations, and most of our ISO standards are also with velocity. We see, normally displacement is the one, if you ask any vibration person, normally displacement is the one where we take in terms of the turbine or the power plant applications, where we give this online proximity non-contact displacement probes. Because we can take, but normally since we are using an accelerometer and taking the displacement, it may not be a right approach. That is my point number one. Second point is acceleration is the unit. Normally we consider whenever we go for the gearbox and the anti-friction bearings measurements, because in these two elements, most of the fault frequencies will occur at the high frequency range. I think you know that mid frequency, high frequency and the low frequency. So for the mid frequency, we go for a normal velocity vibration. For a low frequency, in case of this power plant applications, where the proximity probes will be used, we go for a displacement. And when we go for a gearbox anti-friction bearings, we go for a high frequency measure.
Thank you. Thank you.
No, right, sir? No, sir. Yeah.
Okay, time.
Yeah. Thank you very much, sir. Thank you.
There's 1 minute.
Yes, good.
अभी प्लेसमेंट अच्छा है, लेकिन वो प्लेसमेंट में सारे वाइब्रेशन रीडिंग ही दिखाया था, लेकिन कोई फेज नहीं है.
No, phase angle we take for certain applications. See, phase angle is the one where we use it to understand how one element is vibrating with respect to another element. For example, in case of a cross phase analysis, we do for misalignment problems. And in all the balancing cases, we need phase measurements also. That will be the one which indicates the high spot location. But here I am not showing that because we have a very limited time. Yes, all the balancing study, whatever we have done, it is through phase angle measurements only. Because in the balancing program, RPM, amplitude and the phase. These are all the three important parameters we use for balance. And also for identifying the soft foot conditions also, we use phase angle measurement. Thank you. Thank you very much. Yeah, that's right.
Thank you, sir. I would request Dr. Gambhir to present a memento to Engineer Madhusudan Nagarajan.
Okay, yeah. Okay.
Thank you, sir. So before going for HITI and R4 leftover papers, we'll be taking a short presentation by Corporate Associate AIIML. Sir, please. Pen to connect and close.
From my name is Yusuf Khan. I am a research scholar working in the field of piezo batch placement strategies and active vibration control for smart structures or flexible structures. I am pursuing a PhD from this college under this field. And currently I am working as assistant professor in Jim Aslam Cultural College as assistant professor. For active vibration control, we need some extra force or counter force to suppress or control the vibration. For that, we use the piezoelectric patches to control the vibration. So for that, we need some exact location of the piezo patch to suppress the vibration. So the optimum placement of piezoelectric patch is a very much important area for research. And for that, I'm working for identifying the piezo patch location for different type of structure like beam type structure or plate type structure for the active vibration control. For that, I'm using genetic algorithm to identify the location. The piezo patch you can use for the actuator also. By applying some voltage, we can use as actuator for control the vibration for the flexible structure having very less thickness. So I'm using the genetic algorithm to identify the exact location to suppress the vibration. And then I've used some controllers, 3 types of controller I have designed, the LQG controller, LQR controller, and H infinity controller to suppress the vibration. The most effective place where you have to place the actuator is where the strain energy is maximum in the structure. So for this study, I'm using the cantilever beam as a structure and identify the place where the strain location is maximum. If you consider multi-mode vibration system, the location of the strain position is different for different modes of vibration. So my aim is to identify the best possible location to suppress all the vibration modes and to place the user patch as actuator to suppress all modes of the vibration. For that, I have used the initial 6 modes of frequencies to suppress the vibration of the cantilever type structure. And for that, I'm using the strain equation and apply the genetic algorithm to identify the location. And then I've used the 3 types of algorithm, the controllers, the LQG, H infinity, and LQR controller with using state feedback and output feedback. And compare the effectiveness of these types of controllers by combining the simulation results of this type of controllers. And a few literature based on this objectives is written over here. So first literature is Usama. He had worked on the identifying the piezo patch size, piezo patch location, and number of piezo patches. And he had used single piezo patch and 2 piezo patch on the cantilever type beam and all different other boundary condition of the beam. He considered only the beam type of structures and identify the location by taking the independent control independent methodologies in which he has used controllability and observability methodology to identify the location of user patch and use single pair and 2 pair to control the multi-mode vibration controls. And he have identified 2 locations. And then second author is Kumar. He has also worked on the identifying of the location on the beam type structure only. In it, he has used the LQR type of controller methodology. It is used as a LQR as objective function to identify the location. And for the modeling of the cantilever type of beam, he used inverse beam theory. And after modeling in ANSYS software, he has considered both the mass and stiffness of piezo patch also, including the base structure, and used as a LQR performance index and identify the optimum location by using genetic algorithm. And third author is also used genetic algorithm as well as the neural network algorithm as the objective function, and then they have identified the locations. And in third author, Joshi and Samkot, they have worked for the plate type structure with varying areas and identify the best position where the strain value is maximum. They use the 9 pairs of piezo patch configuration for the multi-mode vibration controls. And then next author, he has worked for the control system and used LQG as a controller to suppress the vibration. He worked for the active vibration control, not for the piezo patch vibration. And he has modeled the 4 initial modes of the frequency and suppress the 4 initial frequency and use the Kalman filter as objective function to minimize the vibration. And then my aim of objectives is to identify the location by considering the strain equation. In it, first I started with the deflection equation of the beam by considering Hilbert's-Bernoulli's equation. In it, I written this deflection equation by considering the boundary condition as one end is fixed and another is free. That is cantilever beam. For that, this is the equation. And then the value of the constant is calculated by using cos and cos S equation. That equation I solved by using MATLAB calculation, and that is f0 function is there in MATLAB. By using this function, I have calculated the 6 different values of constant, and which is used to calculate the mode shape, the natural frequencies of the beam. This value is different for different boundary condition, and the equation is also different for different boundary conditions. So I consider only cantilever beam, and then I plot the mode shapes of the initial 6 modes of the frequencies. And this graph is showing the mode shapes of the cantilever beam of initial 6 frequencies. And then I have calculated the strain equation by differentiating it twice. So I get the strain equation in it, which is considered as the objective function for genetic algorithm. So this equation is objective.
It would have been better if you would have told me कि video भी चलता है, so आप would have actually video. अच्छा क्या हो गया था इसको?
पता नहीं सर, अभी कनेक्ट किया तो वापस चालू हो गया। डिस्कनेक्ट।
Hello.
Hello. Sorry.
So we evolved with the stage where we just have a scale, just keep it on the coupling and just understand that talent is done. But the matter of the fact is, this is not the shaft treatment that you should do. You just keep a scale on the coupling, but it is the coupling that you're checking, but not the shaft. You never know what the shaft really is. You might assume that the shaft element is done, but end of the day, you are just checking the coupling, not the shaft element. This is what used to happen in the state gauge or the feeler gauge, what they used to follow. Later on came in the dial gauges. Dial gauges still people follow it, but still there's a certain amount of limitation with the dial gauge. The reason being too much of mechanical elements involved in this. You need to ensure that this is straight enough and your mounting is proper. So any small mistake that happens in a dial gauge, you end up with a result that cannot be repeatable, and you don't have a documentation for the dial gauge. But in the laser limit is you have a record of everything and it guides you every step. That's the advantage what you have with the laser alignment. And how it works, I'll just explain you this. So as I said, what is the shaft element all about? The shaft element is all about ensuring that you have a shaft on the left hand side and the right hand side. Maybe just assume a motor and a pump. You have one shaft axis on the left, the right. On the right hand side, you have one more shaft axis. The idea is to ensure that both shaft axes are linear to each other. That's what the idea of a shaft element is all about. And by making an accurate shaft element, naturally you want to save a lot of money on your mechanical elements. Plus, the power consumption is going to improve. And we have just proven that with a lot of case studies that we did. And it has really helped industries where they have implemented laser shaft element. To basically understand shaft element, you just need to understand 4 parameters. When you see a simple machine, a motor pump, from the front side, you have a vertical angularity and vertical offset. On the same machine you see on the top view, you get a horizontal offset and horizontal angularity. So we just put 4 parameters for you to understand what a shaft element is all about. As I said, you have a stationary machine, which is supposed to be a motor and a pump. As I said, again, pump is like a stationary machine. Where on the right hand side, you have a motor, which is actually a movable machine where you make the corrections to ensure that this shaft axis is linear to this. So this again thermal image taken where when the machine was aligned within the tolerance. You can see here the amount of the load or the heat transfer that used to happen because of improper alignment was enormous. I mean, you did the same alignment within the tolerances. So there's actually no load on the mechanical element. So the transfer of energy from the left machine to the right machine is happening smoother. So this is what you can prove with this case study, that a proper better alignment will help you in increasing the mechanical elements life as well as power consumption. We also have case studies to understand, like to say suppose the better and closer are to your tolerances, the better is in the bearing life cycle. This is also again proven with the case studies. Power consumption, as already said, so the closer you are to your tolerances, the power consumption is lesser. So you already heard about the vibration IIoT. So today we want to speak about what is IIoT in laser alignment. I have a small video on that. Just So that's how simple it is. The measurement setup, everything is quite easier than I should do every step, like what is the next procedure, next step. So you can automatically just get the results, do the corrections on the go, and save it, and it just one click of a button.
Cloud.
So the same way we also have this IT inbuilt with our online the portable vibration monitoring system, wherein all the data with permanent sensors mounted. You speak about any process parameter. We have the sensors connected. It just goes to the. We have the hard disk provided. Data goes into the cloud. It gets analyzed and comes back. We have the hard disk provided to monitor this data in real time, where the sensors are permanently mounted and the data goes on onto your feed. You just in a click of a button, you get to know like the overall asset condition, how it is performing, what it is today. So you can be any part of the world. Just click on your machine, which location plan. Just click on that, and you get to the overall condition. What are the parameters which you want to monitor? Whether it's in good condition, any warning, pre-warning. And if you know about the initial machine, like which machine, which direction has got an issue, just click on that specific parameter. You want to know in detail. Just you can just go on like overall view plus detail analysis. This is always there. As I said, the same thing. IoT inbuilt in all our vibration and alignment systems. That's it. Thank you for listening. Any questions? You can first.
Thank you, sir. Now I would request our authors of next paper, Dr. Neelash Deshmukh, Afzal Ansari, and Axin Samuel, Department of Mechanical Engineering, Father C. Roderick Institute of Technology, Vashi, will be presenting paper on investigation of effect of porous material on performance of Helmholtz resonant.
I'm not sure this one. My name is Axin Samuel, and I'll be presenting on the topic investigation of effect of porous material on performance of Helmholtz resonator. This is my dissertation topic under the guidance of Dr. Neelash Deshmukh and with the help of Professor Ansari. So next. So what are thermoacoustic instabilities? So thermoacoustic instabilities are also known as combustion instabilities. They are encountered in development of gas turbines, boilers, aero engines, and rocket engines. So they manifest themselves as large amplitude oscillations, which can cause demarital consequences. So in the instabilities, they are generated due to a feedback loop between unsteady combustion and the acoustic mode of the chamber, combustion chamber. So moving ahead. So this type of perturbations, they grow and alter the flow of the in the features of the flow, and they are of acoustic nature. And there is a coupling between these two processes, and the strength of the coupling increases with time. So in the next slide, you can see that this unsteady heat release and acoustic oscillations. The driving is due to Rayleigh criterion. It states that the phase between heat addition and pressure oscillations is less than 90 degree. Then there is then there will be thermoacoustic instabilities. What exactly is Rayleigh criteria? It states that whenever heat is added at the greatest compression, or it is abstracted at the greatest rarefaction, then there will be thermoacoustic instabilities. Then we have damping. Damping is due to viscous losses, heat transfer, and sound radiation. So for thermoacoustic instabilities to continue, the driving of the oscillation should be greater than the damping of the oscillations. So in this image over here, we have a rocket engine which was tested by NASA, and we can see that it is partially damaged due to thermoacoustic instabilities or combustion instabilities. The image on the right shows a stable flow in the burner, and on the right side we have an unstable flow which is seen in the form of mushroom vortices. So now we know what thermoacoustic instabilities are. Now we need to know how to characterize them. So a Riquet tube is used for characterization of thermoacoustic instabilities. In a Riquet tube, the heating element is placed at a length of L by 4 from one end of the tube, and the fundamental frequency is found by multiplying the mode number into the velocity of sound in air upon the length 2L, so twice the length of the tube. There are various methods of controlling thermoacoustic instabilities, passive and active. In active, we have open loop and closed loop methods. So in passive methods, we have quarter wave tubes, perforated liners, baffles, Helmholtz resonator, and we can change the geometry of the combustion chamber to tackle the instabilities. In active method, open loop, we have use of heaters and swirlers. And in closed loop, we have fuel modulation and air modulation, that is flow modulation. So we will be focusing on Helmholtz resonator. The resonant frequency of the Helmholtz resonator is given by a speed of sound in air upon 2 pi into root of S, which is the area of neck, upon B into effective length of the neck. So from the formula, we found the frequency which we got for the tube was 496 Hertz, and we designed the Helmholtz resonator keeping this in mind. So we got a Helmholtz resonator, and we kept the cavity diameter as 40 mm and the neck diameter as 3 mm. The length of the neck was kept as 24 mm. Sorry, this should be mm. And the height for the cavity was calculated. For our design, the height for this frequency, the height was supposed to be 11 mm. So as we need to check the effectiveness of the porous material, the Helmholtz resonator was designed as a cap and cup type shape with threading in between. We can see over here, and the threading was of 2 mm pitch. So one rotation of the cap would increase the wall height of the cavity by 2 mm. The porous material was stuck to the cap, so it doesn't block the cavity. And the porous material was a polyurethane foam with a density of 1.45 PCF, which is pounds per cubic feet. The thickness of the foam was 0.5 mm. This is the schematic of the experimental setup used. Over here we have the LPG cylinder, and here we have the air compressor, which supply to the pre-mixer, and the pre-mixed fuel is then sent to the burner. So the burner is placed inside a leakage tube, which is connected to the plenum chamber. Blower is then connected to the other end of the plenum chamber, and a continuous flow of air is maintained through the setup. So this is the photo of the actual setup that we have used. This is the leakage tube. You can see the Helmholtz resonator over here. This is the plenum chamber, and this is the transverse mechanism to move the burner inside the leakage tube. This is with the reactive setup. This is the data acquisition system, and we have the microphone over here. In this, we can see the blower which is there, and a VFD is used to control the speed of the blower. This is the data acquisition system. So at first, the burner was kept at different location inside the leakage tube, and we got the FFT of that. So we can see that it is around 469 Hertz. The location of 160 mm was selected as the placement of the burner, as it was the most suitable. So this is the placement of Helmholtz resonator inside the leakage tube. The fundamental frequency was around 219 Hertz. And if we divide that by 469, we get something around 2.1. So it indicates that the instabilities of the second mode. So for second mode, the Helmholtz resonator was placed over here, L/4. So this is the Helmholtz resonator placed in the tube. So now coming to the results, the height of the cavity of the Helmholtz resonator was varied from 8 to 12 mm, and its effect on the instability was checked. So for 8 mm cavity height, there was no effect on the instability. For 9 mm, we can see that there are some changes. The most drastic effect was seen for 10 mm cavity height. Over here, we can see that control with HR, we can see that there is a slight reduction in the SPL. But with using porous material, there is a drastic reduction in the instability. 11 mm was found to be the optimal height of the Helmholtz resonator. So both of them show no instability, and instability was subdued. And again in 12 mm, we can see that the instability is trying to come back with only the HR, whereas the Helmholtz resonator with porous materials show no indication of the instability. So again, this is comparing the SPL with the cavity height. So we can see over here for 10 mm, there is a reduction in SPL. So this was the conclusion. So The volume of the cavity was reduced by 9% by use of porous material. These are the references. Thank you. If you have any questions, please ask. Thank you.
Thank you, sir. Now we'll move on to our next paper by Mr. Santosh Kumar Murugdas. So before proceeding to the paper, I would like to inform everyone that feedback forms are being circulated. Please make sure you fill both the sides of the page, and after this paper, we'll be collecting those feedback forms. So I request Santosh Kumar Murugdas, Principal Engineer, ANSYS India, Bangalore. He'll be presenting a paper on random vibration fatigue prediction. One more thing about lucky draws. So kindly fill your coupons in the box before our valedictory session. So we'll be taking out lucky draws for today's and yesterday's session. So you need this mic or the other mic? The other mic.
Thank you. Good evening, all. These 2 days, we have been gaining very insightful information about vibration monitoring, diagnostic, and prognostic, even the advanced technique like IIoT and etc. My topic is slightly different in terms of design aspects of structures and predicting its fatigue life and designing a structure for its design durability. Early in the design stage, using virtual simulations even before getting into the prototypes and so on. So in the whole vibration spectrum, if you have a system, the system can be anything, an automobile or an airplane or a windmill or a compressor or anything. We need to really understand what is the objective we are going to carry out the study. Whenever we are dealing with vibrations, the engineers are dealing with enormous amount of data. We need to really think about how to make useful insights from that large amount of data, which will enable engineers to make decisions. So in any vibration field, we can look at the vibration response of the system in a time domain or in a frequency domain, especially when we are talking about a system which is subjected to vibration excitation for a large duration. Both time domain and frequency domain is not sufficient to gain complete insight. We need to look at even the statistical models. Many of the systems can be categorized into 3 types of excitation. One is the sinusoidal excitation, like what we see from the unbalance or the misalignment, those are the higher order harmonics, or the short duration loads like shock, impact, drop kind of phenomena, or the short duration random events like earthquake or a seismic excitation. The category that I'm going to talk about is the long duration random event. So typically, the long duration events are non-deterministic. When we say a deterministic signal, we should be able to predict the amplitude and the phase of the signal anytime in the future using a formula. Say, for example, here, though it doesn't look like a sinusoidal signal, this is a summation of 2 signals. We should be able to predict what will be the amplitude and phase at any point of time. But when we talk about the random vibration, if you for example, imagine a truck that is carrying some electronic products like a TV or a satellite, which is traveling from the port to the warehouse every day, we are monitoring the vibration by mounting an accelerometer here. If you look at the thing, the data is shown for 5 days. If you look at the data exactly 10 hours after we start the vehicle, every day it is not going to be the same. They are different. So it is not really predictable. But if we look at what is the intensity of the vibration that this structure has experienced, in every day it remains same. That's why we can analyze these long duration events. Say, for example, if we design the truck, we need to design this structure such that its fatigue life is more than 10 years or something like that. It is really not practical to analyze these data in a time domain. we need to look at it in a frequency domain. Okay. The another important characteristic of this random signal is that these signals, so far we have seen many presentations. Most of the presentations we are talking about the sinusoidal excitation. It means that at a given point of time, it's fundamental or its orders are exciting the structure, right? But in the random vibration, at given point of time, there are multiple frequencies simultaneously exciting the structure. That makes it quite different from the sinusoidal vibration. These random vibrations are quite common in automobile on many products like this. Even for non-mobile products, something like when we transport consumer goods or medical equipments on the road or by air, by ship, they all experience the random vibration. Right? We need to analyze those kind of scenarios. But going back to the basic, even though it is a random signal, this random signal is nothing but a summation of multiple sinusoidal signals. So it means that whatever we studied or whatever we understood for a modal characteristic of the system is still valid for the random vibration system as well, as long as the system is a linear system, right? There are two important characteristics we need to understand when we talk about the random vibration. First one is about the statistical distribution of the signal, or we call it as a probability distribution of the signal. Let's say we have a time domain signal that is measured for, say, 10,000 seconds. First of all, we need to generate a histogram, something like what is the number of instances it is crossing the each beam. Okay? Then we generate this histogram. Fortunately, the Mother Nature makes most of the random events that follow the Gaussian or normal distribution, which kind of have 1 sigma, 2 sigma, 3 sigma distribution, which will cover the probability of close to 99.7 even, which will fall within the 3 sigma limits. But still there are 0.3% which can go beyond our calculation in the entire duration of the time. Right? Then one is the statistical aspect. Then converting the time domain signal into a frequency domain signal, we do that through power spectral density. We pass the raw time domain data. Through various band pass filters, right? Then once we have a data for certain frequency band, then we take a power of the signal and average that. So we will get a average power of the signal within that frequency band. So we do that for every band. Then we normalize this power against the bandwidth. So when we put them all together and we make the bandwidth smaller and smaller, we get a continuous curve. That's what we call it as a PSD curve. But for most of the industry designs, there are a lot of standards which this gives you this PSD standard for which the product need to qualify. Another important thing is that we need to understand when we do this squaring operation, we lose the phase information. Okay, so but however, through the inverse f of t, it is possible to reconstruct the time domain signal back. Okay, so at this point of time, I would like to remember the great mathematician Fourier. Okay, I can't imagine the vibration world without the Fourier transformation. It's going to be very, very difficult to visualize or gain insight of any vibrating machineries. Okay, we must be very, very thankful to Fourier. So all the industries across electronic industry, automobile, avionics, everywhere the random vibration testing is being used to ensure the durability of the product for a given warranty or guarantee period. Right? So the one way is through the testing. The simulation tools like ANSYS will help to virtually simulate this test in a computer environment without waiting for a high capacity shakers or getting the prototypes and so on. In that way, help to reduce the number of prototypes. Probably your first prototype that you are going to make is going to pass your qualification test, okay, and help to save time and cost as well. So let us understand how these numerical tools calculate the response of the structure when it is subjected to a random vibration. We looked at how we calculate the input PSD, and we kind of looked at that the transfer functions are still valid for any linear system. Still they are applicable. So we can calculate the response of the system when it is subjected to an input PSD as input PSD times the response function square. That is going to give us the response system The area under this response is nothing but the RMS. This response can be in terms of displacement, velocity, acceleration, stress, strain, anything. So once we have that, the next thing is we need to calculate the life. So how do we calculate the life? We know the stress, that is a 1 sigma, and we can calculate 2 sigma is 2 times the 1 sigma. So we know 1 sigma means it's a 68% of the total test duration. So we can calculate how many cycles that structure is actually experiencing. Then the capital N is nothing but how many cycles that material can withstand. By doing this summation, we can calculate the life. But the thing is not as simple as this. Okay. Since I have a lot of teaching faculty and students here, I would like to go a little basic. I would request the session chair to give me a few minutes extra, if it is okay. Thank you. Okay, all right. Okay, the trick with random vibration is here. At what frequency the structure is vibrating to calculate the number of cycles that structure is experienced. When it is a sinusoidal vibration, it is very clear. The structure at this point of time is vibrating at this frequency or RPM. How much of a time it vibrates, then those many cycles are happening. But in random vibration, it is not one frequency that excites the structure. There are multiple frequencies excite the structure. Then at what frequency the structure is really vibrating? How many cycles it completes? That's where the challenge comes when we talk about the random vibration against any sinusoidal vibration. For that, what we do is we introduce a new concept called the number of upward crossing and number of zero peaks. The number of zero crossing represents the frequency, the global frequency at which the stress reversals are happening. Okay. The number of peaks actually represents the peak stress value that is important for fatigue life calculation, that is going to give us the stress range, right? Again, there are two types of vibration. One is the narrowband vibration, which the structure's response, dynamic response is limited to a resonant frequency. And another kind of a structure which exhibit the broadband response, where the response is spread across all the frequencies. So if you look at the stress cycles for the narrowband and the wideband, they are quite different. If we can't use the same approach for both the things, if we start using that, the stress amplitude that's supposed to be green, instead of that we will picking a small amplitude that is a red. That's wrong. So we need to use a different approach for a narrowband process and wideband process. So that again depends on the probability distribution. For a pure wideband process, the probability distribution of the stress peaks follow the Gaussian distribution. For a pure narrowband process, the probability distribution follow the Rayleigh distribution. But in reality, many of the practical systems fall somewhere in between. So we need to calculate how much is the deviation that we call it as a irregularity factor that can be calculated from taking the moments of the stress response PSD curve using the formulas that's shown here. The formulas are really straightforward to do that. Okay? To do that, there are 4 popular techniques that's commonly used in industry today. Those 4 are given here. So this will help to determine the number of cycles for different kinds of a scenario. I have given pros and cons of each of these methods. Probably you can go through this later rather than spending a time. This is the holistic view. So when we have a random vibration excitation on any structure, we can visualize that in a time domain. If you want to analyze that in a time domain, it's a years of data. This is very non-practical. But the same information can be visualized in the frequency domain, which is really quick, both for insights and the analytic part. So the whole concept that we discussed is kind of put inside the software, and we get the response function, input PSD, and the distribution of the response test kind, and put it on the SM curve and do that. This is how it's kind of implemented. Just to validate this approach, we have taken a sample of a specimen subjected to a random vibration PSD. We physically measured on 7 samples. As we all know, the measurement of fatigue life has a lot of scatter based on the material properties or so much so on. These are all the various results by adapting the 4 techniques for the cycle counting technique. the Steinberg or the 3-band technique that I explained, which looked very simple, is least conservative. Okay, and the Derlick method is the one that is kind of a conservative among all the 3 approach. Probably, if it is when in doubt, probably go with Derlick. So the typical application, not only for the continuous metals, the same technique can be used for assessing the well life, castings or brackets, machine brackets, process equipments, robots, drones, or the equipments those are mounted on the ship or aeroplane or a car. For all those kind of things, these techniques can be used. With this, I would like to end my presentation. Thank you.
Any questions, anyone?
Thank you.
So we come here at the last paper of our session, or you can say conference. Dr. Lalit Kumar Jugalkar and Dr. Nitin Satpute, Rajaram Bapu Institute of Technology, Islampur, and Dr. Nitin Satpute of Vishwakarma University, Pune. So they are present online. They'll be presenting paper on modeling and development of Mandigo biological damper for changing damping systems. The video is they are pre-recorded video of Mr. Dr. Nitin Satpute, and Dr. Lalit Kumar Jugalkar will be present online for giving any question answer session.
Hello, good afternoon all, respected judges and dignitaries. I am Dr. L.M. Jugulkar, working as a professor in Mechanical Engineering Department at Rajaram Institute of Technology. I am here to present my paper titled Modeling and Development of Magneto-Reversible Damper for Changing Damping System. As far as the abstract is concerned, this is the abstract. As the piston thickness is smaller, a limitation is there on getting a large magnetism. Basically, in this damping, there are some disadvantages of inside piston magnetism, and as it is externally wound, there are some specific advantages. So that is achieved with the help of this research work. Capacity of the suspension. The design parameter in the suspension, such as damping coefficient, damping force, resonating frequency, would not be varied, but it is fixed. This is the passive suspension system. But as far as the semi-active and active suspension system, active suspension is somewhat costlier, or there is a complex mechanism. So most of the researchers turn to the semi-active suspension system, and that too MR damper, where magnetism is developed with the help of electromagnet, and oil viscosity can be varied, which is MR fluid, magnetohydrological fluid, so that oil viscosity can be changed as per the supporting load, speed, acceleration. These are some parameters where the damping can be varied. As per the objective of this research work is concerned, development and modeling of MR damper considering the external magnetic field from the outside of the cylinder, and fabrication and experimentation of the MR damper considering the external magnetic field from the outside of the cylinder. We did also CFD analysis for the same. Basic design is shown here, where input data and selection of the design solution. Design assumptions are maximum damping controllable force, that is 500 kg. We have considered it is considering the weight of the vehicle is 2000 kg divided by 4 per wheel. If you consider for 90.5 kg is the weight, we have considered it as a 500. We have prepared the prototype So that's why we have, and then damping coefficient can be calculated with this, with the help of this formula, and the damping ratio, critical damping ratio, damping ratio has been taken as a 0.4. It is given in the Dixon handbook. 0.4 can be assumed for the automotive application. Then critical damping coefficient can be calculated over here, which has been considered as a factor of safety as a 5. Then buckling load, we have calculated from that buckling load. Then we have calculated the diameter of the outside diameter of the piston rod. Okay. Then, but for safe design, the actual diameter of the manufacturer is taken as a little larger to accommodate the practical conditions. So we have considered it as a 16 mm. Now, considering the piston diameter 3 to 4 times of the piston rod diameter, which is a standard assumption, then 52 mm. Then hence we have calculated piston rod diameter 16 mm. Piston diameter is 52 mm. This is the formula. Number of orifices here. 8 orifices we have consider as per the calculation for that particular piston, having standard size is 1.6 mm. As far as the MR fluid is considered, in order to choose the most appropriate MR fluid, criteria to compare the nominal behavior of the different MR fluid must first be established. The MR fluid dampers are usually designed such that in normal conditions the MR fluid is magnetically saturated. It is under the condition that the fluid will generate its maximum yield stress tau y. Here for this reservoir we have considered as a Falcon MR Tech AMT Dampro is chosen, and it has the values from the Falcon. Circuit involves the following steps: selection of the optimum magnetic field, generating maximum electromagnetic field. We got H is equal to 140 kiloampere per meter, and then choice of the steel of the for the piston and cylinder. For magnetic circuit, low carbon steel is selected because of the high magnetic permeability. Piston, and this gives number of turns, 3,500 turns of copper wire diameter, having a standard gauge 18, but 18 gauge wire is selected from the standard wire gauge. Chart is not feasible for having a 3,500 number of turns in full length of 50 mm, practically 88, 16 mm, piston diameter 52 mm, then thickness of the piston 20 mm, then length of the cylinder 170 mm, length of the rod 560 mm. This is the manufacturing. We can see here. This is the cylinder. Has been the piston openings around that oil ring is required. This is the piston having a number of holes. Total 8 holes, 1, 2, 3, 4, 5 assembly, where there is a spring and there is a cylinder. Inside that there is a piston, and outside the cylinder there is a electromagnetism. You can see that this is the drafting. Now we will go to the experimentation of the MR shock absorber. This is the setup. Basically, we are having a test rig setup developed at RIT in-house, where Scotch-Oak mechanism there, and along the Scotch-Oak mechanism, so that again oscilloscope, data acquisition system, computers, these all are auxiliaries required, and we did the experimentation for 0 ampere current, 0.05 ampere, 0.1 ampere, 0.15. As we change the current are important in input for the CFD. The viscosity of MR fluid cannot be calculated from the viscometer, as it is varied. So that what we have prepared one setup, basic principle of viscometer, where steel ball is put inside the standard ball is put inside that cylinder on oil in the cylinder. Then the ball was left. After this, we have calculated for the particular current, particular velocity for the input of the CFD. Okay, then these are the CFD results we have calculated. You can see that for the current, Reynolds number has been calculated. For the CFD analysis, we should remember that it must be a laminar flow. That's why the equation will be the linear equation, or otherwise it will be non-linear equation. And we have assumed it is a laminar flow. And characterization of damping force 2 ampere. This is the it is current. But after that 5 to 6 hertz, the acceleration curve suddenly increases and drops down again at a frequency greater than 6 hertz. The frequency ranging 5 to 6 hertz is the natural frequency of the vibration of the current prototype. So it has been calculated like this. External magnetic field over the external periphery of the cylinder for the variable damping suspension for 4-wheeler application. The MR damper was tested on the test rig under various tests to get the characteristic curve of the MR damper and its side effect on the ride. The design of MR damper was done on the basis of fixed pole case. Characteristic curve of design damper is found out experimentally. This compared with the standard curves given by various authors and researchers. Design electromagnet amount of current is supplied to the electromagnet, whereas the common viscous damper gives approximately 650 Newton damping at 5 hertz. Design MR damper possibly gives damping coefficient values 4.65 kilonewton second per meter for 0 ampere of the current and damping coefficient of 10.13 kilonewton per second per meter for 0.2 ampere of the current supplied to electromagnet. Common viscous damper gives damping coefficient of 5.98 kilonewton per second per meter. But with the standard force required is much larger. The magnetism generating on the piston is having a limitation due to less diameter and thickness of the piston. It will be increase advantage tall two-wheelers and stroke. So this is the reference. So thank you one and all. If any questions are there, thank you.
Yusuf Khan, please receive the token of appreciation. Request Arin Samuel to receive a token of appreciation from Dr. Gambhir. Request Dr. Pine to give a token of appreciation to Santosh Kumar Murugdas. Santosh sir, he is not present right now. We'll give him later on. So now I request our Associate Chair, Engineer Rajshekhar Uchil, to summarize the session and address the paper presenters. Uchil sir, is left.
Yeah, actually,
I request Dr. Sanjay Mukande to conduct today's quiz for distribution of 2 vouchers.
Thank you, Neha. So quickly, I will take this quiz, and there are surprising 8 for this. These questions are set by the authors, and other than authors, people can answer. So, other than Ram Kumar, people can answer. First question: what are the structural dynamic properties of the system model analysis evaluate? What are the structural dynamic properties of systems model analysis evaluate? Anyone know the answer? Please raise your hand. Yeah, please come forward and tell. Natural frequencies and damping ratio and okay, the answer given are natural frequencies, mode shapes, and damping ratios. So 2 points are correct. One more question, sir. Yeah, mode shapes is right answer. What are the advancement in the model domain? What are the advancement in the model domain? Anyone? Okay, answer is operational deflection, shape analysis, then operational model analysis, and transfer path analysis. Then other than Dr. K. Lakshmi, people can answer how the cocktail party problem is analogous to civil or structural engineering problem. How the cocktail party problem is analogous to civil or structural engineering problem. Okay, answer is it is similar to the sources and mixing matrix, the modal responses and the mode shapes, they are analogous. Second question is what are the major components obtained after singular spectrum analysis? What are the major components obtained after singular spectrum analysis? Yes, sir. No. Any other? Answer is it's train, cyclic and noise components. Okay, fine. Next sheet, other than Chinmaya Kar, people can answer. What is the use of FMEA? What is the use of FMEA? No. No, exact answer is not matching. I already answered. FMEA is used for deciding maintenance strategy of every components of an asset. Next question, how to calculate residual in the machine learning based prediction method? How to calculate residual in machine learning based prediction method? Yes. Residual is calculated as actual measured value minus expected or predicted value. Fine. Now maybe who coined the word acoustic for the science of sound? Who coined the word acoustics for the science of sound? Yes, sir. No. Anyone? It's Joseph Sauvier. Okay, who measured the period of the pendulum movement of the lamp in the church and found that the time period was independent of the amplitude of swing? It's a famous story. The person in the church praying, he found lamp hanging, and then he got some idea and got the relation. Anyone? Galileo is the right answer. Is that person? The voucher can be given to the person already answered. Yeah. Galileo Galilei in 1564 to 1542. Yeah, that's all. Thank you. Thank you. Good name, sir. Ketan. So give big round of applause for Ketan.
Just go to. Thank you, sir. So I would call on our last presentation by Corporate Associate ACOEM India. Which mic?
Taking care of global operations at Texas India. Can you? Yeah. Sorry. Yes. Before I go ahead, I would like to congratulate CVSD and the entire team who made this event wonderful. And I'm privileged to be a part of this event. And I expect that more events should come and that I could part. So the agenda, that I will quickly rush through this. So introduction. Mostly I will speak about the challenges what customers face, and we will see what solutions we are offering. And it is more to do with the current scenario of the customer challenge. So as an account, we believe in finding the right balance. If we say right balance, we say we don't restrict the human development. At the same time, we don't want to disturb the environment. As well as when we are looking for the say restrictions of the development at the same time of the balance between the environment and the growth of the people. So that is the motto of this company, and why how we do that with 5 different verticals we are in. That is industrial liability, emission and processes, ambient monitoring, protection system, and design. So these 3 help us to give the right solution to the customer, which ensures the growth of the say end customer at the same time helping to conserve the environment. Right? So how we do that? We can have different data in terms of acoustic, in terms of vibrations, in terms of emission and gas, alignment, and many more things. And we convert those data into valuable data. Valuable data in terms of the customer interface, who can work on those data, and like normally customers, they are they are not really dependent on really interested in 1x, 2x, 3x, and whatsoever. They will ask what I need to do and when I need to. So we are converting those any data, be it acoustic, be it vibrations. We will convert those data into valuable data, and that will be represented via software and the respective dashboard. Journey, I will not get into this, but we will be completing nearly 55 years of experience we are bringing in. We started in 1967 with many acquisitions, many mergers, and name change as well. Echo was founded in 2011, and so on. We are getting furthermore mergers as well. Global footprints, we are not very. I will quickly rush through this. List of few of the customers. I cannot bring all customers in a single page. So these are the few lists. Important part is we presence is in all sectors. So be it steel, be it mining, be it wind, railways, paper, everywhere we are there. This is very important. Opportunities for the customers, and opportunities also bring challenges. So opportunities, like with the current scenario of Industry 4.0, they have opportunity
to work on the existing setup and to incorporate many more technologies like in the digitizations, and then those can be converted into valuable data, which will help them to go further. So this will definitely help them to improve their overall reliability. How does this take place? So it is a combination of digitization, that is the new technology what we are talking about, and the existing setup what we are already using, that is preventive or predictive maintenance, we are doing that. And the combination of this will lead to the results, what actually we are looking at. But to go there, still there are roadblocks for the customer, and roadblocks are finding the right partners. So customer will always be confused that who is the right person for me, who can help to solve my problem. The second can be the implementation time. Even though if I can find good one, how long it will take? Does it is very much secure? Does they are skilled? Did I take the right decisions? So this will always pull the customers back. So what we are ready with our commitment. Where looking into the upcoming new developments, we are associated with new technologies, and we are working on that. We work with the customer as a partner instead of only conventional supplier. We are ready with the technology, AI and machine learning embedded solutions we are having, and we have a right product which is embedded with this technology. It will readily can be used by the customer. So how we are different? There is a combination of the conventional learning, artificial intelligence, and machine learning over a period of time. So we bring in that experience what we have, and the algorithm what we are bringing in. We have the data scientists sitting at France who are continuously working, and there is a team of data scientists who are working continuously on this. And this results into a software that is called as Nest. The good part of this is it can incorporate every single hardware, be it online, be it offline, be it alignment kit, that all that can be integrated into a single platform. Here. And the Accurex, this is the patent technology we are talking about. And this is the 4th decade we are in. And this is the continuous improving continuously. And how does this help? I will touch a separate slide on this. These are the technological features we are talking about. A simple dashboard, this will be used at the enterprise level. Machine health, immediately as soon as there are the data wizard, it will refer into red, green, or yellow. A harmonic index, so normally those who are analysts, they need to open the spectrum and then they will look into the spectrum 1x, 2x. But by this index, before getting into the spectrum, they will know there will be harmonic inside the spectrum. Machine setup can be done at the fingertips, very easy. I will take some time on shock finders and bearing defect factor and going ahead. So bearing defect factor, this is the most common subject which normally all customers dealing with the rotating machines are interested. So bearing normally have the 3 conventional stages of failure. So stage 1, small damage. Stage 2, expansion, and then it will kill the bearing at a given point of time. So what we are exactly looking in is to get the earliest detection, not early, rather earliest detection, and the evaluation when I need to take the actions. Bearing is failed, but should I do it right away? Should I plan it, or I should wait for more few months? So for that, conventionally and present scenario, these are the indicators which we are using, that is peak view, RMS, and peak factor. Most of the envelope signal are based on this filters, and each 3 filters have their own limitations. Like this is good at indicating earlier, but at the later stage, at the progression level of 3, it do not have any information. For RMS, it do not give any indication at the initial level of wear or damage. Wherein peak factor, no information at early stage, but good at stage 2 and then no information at stage 3. So to overcome this, we have introduced a bearing defect factor, which works on this principle that there will be a raw data of more than there will be high pass filter, and by using filter, and this is the logic behind. There is a know-how of factor A and B, and using existing peak factor and RMS value. And this is very old technology we are since many years we are using. So this will result in, if you see defect factor, be it initial level, be it second level, or be it third level, it will always give the indication. It is independent of the speed. Most of the time it works absolutely fine. It is independent of the bearing type and size. But all other three are some or the other way are dependent on type, size, speed. So as soon as there is a problem pertaining to bearing, this will give some indication. And to make it simplify, we are having a traffic light kind of symbol. So from 0 to scale of 12, everything from 0 to 6 is green, 6 to 9 pre-alarm, and 9 to 12 is alarm. So up to 6, I just need to keep a watch. From 6 to 9, I should start planning it. And say inventory, and I have to look into the availability of the bearing. And from 9 to 12, I have to plan at the soonest. Shop finder, the second challenge what we had observed is the slow turning machine. The information for normal running speed from 1500 or maybe 1000 RPM to above 1000 RPM, everything works fine. Since it is having a centrifugal forces at the back end, which is easier to monitor and easier to understand. But as soon as we say anything which is lesser than 60 RPM, it is still a challenge for, say, most of us. To deal with this, we have shock finding index. It works like there will be time signals which is captured, and we are slicing into equal number of pieces. By slicing, we will have a spectrum FFT of each slice, and then we have, sorry. So if you see here, we cannot make out any impact or anything which is having a problem. But after applying kurtosis, we could see some impact which clearly shows, and this is part of hidden frequencies of the signal. So this is the example where when we see the values, overall vibration values are in 0.2. Very much irrelevant if we go only by velocity. But when we go with the overall envelope value, still less, but defect shock finding, those are dark. If you go with the harmonics, I couldn't see anything, but in time signal, I couldn't see. But when as soon as I apply SFI, I could see impact. And by using this indicators, we could identify bearing at very early stages. The benefits. The second important part is we preferably don't go with the conventional ISO standard alarms and pre-alarm. What we do, we enable AI with machine learning. So with the same set of machine, we have a setup of data, which is black in color. We go with the overall evolution of the data, which is green in color, just to represent this. So anything close to green, that is acceptable. But as soon as it is going beyond green in terms of red or orange, then those are changed in the parameters. And based on that, we can set the alarm limits. So before getting into the alarms, we understand the machine over a progressive period of time, and then we set the alarms. This is the upcoming feature we are talking about. Conventionally, till now, we are using ISO standard globally. And based on that, we define criticality of the machine, say red, green, or yellow, ISO 10816 class 1, 2, or 3. But by in coming from where we are introducing the vulnerability of the machine as well, the criticality of the machine. So there will be two parameters. One is criticality in terms of with respect to ISO standard, and the criticality in terms of from the customer perspective. So there will be a combination of criticality from the customer perspective as well as from the ISO standard, and there will be some number which will assist us to really say the machine is critical, or we can bear with the machine, or we can skip those measurements. So this will be coming up. So as I mentioned earlier, accuracy. That will result in this is for the end customer. What customer need? What is the problem? So problem fault based on AI, it will indicate there is a misalignment or unbalance or resonance or gear or cavitation or structure or bearing. So customer will be or diagnosis will be done. It will pick out the respective problem and the severity in terms of red, green, and yellow, and additionally a confidence rating. So single star is 25% and all 4 star is 100%. So this helps the customer to find what is the problem, how severe is the problem, and what I need to do with this. Should I plan it? Should I wait it? Or should I stop the machine and do the maintenance? So this confidence rating will help them to take their actions. And this is all automated. No human intervention. As soon as I take the measurement, machine itself will do the respective things. Customer just need to follow the instruction given by the machine. So everything, as I mentioned, Nest, it is embedded. So it gives a platform which can be scaled to an unlimited number. So customer initially is having offline monitoring system. Same can go with online monitoring system, and other hardware can be integrated on the same platform. So this is the beauty of this. The product, I will not get into this. We are also dealing with the alignments. We are also into different kind of services. This is just to mention that we are a OEM who are having the end-to-end product. Advisor, this is the last slide for me, so don't worry. I will be summing up. So advisor, it's the services which brings the expertise in place. So what we say by using advisor services, we say customers, don't worry. Leave it up to us to the ECOM, where on customers behalf, we have a team of level 3, level 4 experts who will be doing the analysis. We just need data, and mode of communication can be anything. Once we have the data in the cloud, we do the analysis. So presently we are taking care of US, UK, and Australia, where we are getting continuously data from the customers, and we have a team of analysts who continuously work on those data and give the reports, and that is analyzed and just say approved by the senior analyst. How it works: data collection, analysis, actionable data, and the correction. This is being gathered by advisor team. So what is the advantage here? We are not only restricting the data from the vibration per se. If anything is there beyond vibration, maybe there is something design related issue, then as an expert who are having a rich experience in different fields like oil and gas, cement, pulp and paper. So with those experience in place, they are right person to make the call. So anything beyond vibration, they can do the root cause failure analysis. If there is something wrong with the bearing, then they can pinpoint the bearing, or maybe if in case if there is change in design is needed for the bearing or type of bearing need to be changed, we can help in those aspects. So what we bring in is we ensure the reliability of the machine. We reduce the cost by helping the customers. We implement the sustainable CBM program. So we make customer prepared and we are flexible enough to give solution as per customers' requirement. Some customers are good for offline, some customers are good for online. So based on customers' requirement, we have flexible solutions which can be offered. We work as a partner, and as I mentioned, advisor services, which is 24/7 support. And we use not only vibration but the multiple solutions we are offering. So that's it. Thank you very much for your time and patience. Any question? Was quick. Maybe.
But you question us, so we had energy.
Thank you very much.
So don't think that we are sleeping.
Thank you.
Last moment, I think that we are not doing.
I simply rushed it. I don't know what I spoke.
Just clarify this one. Your
Thank you.
Thank you. We'll just proceed with the valedictory function in a little bit. International Conference on Vibration Engineering, Science and Technology Invest 22, being conducted by the Council of Vibration Specialists, CVS, in association with Agnel Charities, FRC, Rodrigues Institute of Technology, Vashi. I first request our dignitaries to come on to the dais. Mr. Manohar and Rajbhushan, sir, Dr. Gambhir, Dr. Pine, Dr. S.M. Kaur, Dr. Nilaj Deshmukh, Dr. Nitesh Elve, and Dr. Aklim Siddiqui. Thank you. We'll begin our valedictory function by a summary of the conference by Dr. Sanjay Rukhande. Sir.
Very good evening, all of you. Finally, we come to this final session, valedictory session. In these 2 days, there were total 30 presentations, out of which 14 paper presented by the authors, then 6 keynote speakers, 5 by invited speaker, and 5 presentation by corporate associates. Keynote speakers were Dr. Ramakrishna V from NSTL DRDO, Visakhapatnam, Mr. R. Ramakumar, ARAI Pune, Dr. Vishwajit Basu, Trinity College, Dublin, Ireland, Dr. Naveen Garg, National Physical Lab, New Delhi, Dr. Edwin Vijay Kumar, GVP Engineering College, Visakhapatnam, Dr. Diego Geller, Luya University, Sweden. Then invited speaker, Dr. Chinmayakar, Honeywell, Abu Dhabi, UAE, Dr. K. Lakshmi, CSIR Chennai, Dr. Srinivas Ogu, CSIR Chennai, Dr. Madhusudan Nagaraja, Diagnostic Engineering, Bengaluru, Dr. Rao Manepalli, Chief Scientist, USA, and our corporate associates, UE System, Force Marshall, then Bentley Nevada, Bakar Hugs Business, then ACOEM India, and AIMIL. So we have presentations from all international countries, USA, Japan, UAE, Ireland, Sweden. And it was really a very good and successful, fruitful international conference in West 2022. We received really very good cooperation from all of you. So thank you very much. Thank you all for your active involvement. Thank you.
Thank you, sir. Next, we will have the certificate distribution for the paper presenters during the conference. I request Dr. Gambhir to come forward to present the certificates. First, we have Dr. Lakshmi from CSIR Structural Engineering Research Center. Please give them a big round of applause. Next, we have Dr. Lalit Kumar Jugulkar from Rajaram Bapu Institute of Technology. Badal sir will be collecting on behalf of Mr. Jugulkar. Next, we have Mr. Achyut S. Raut from Rajendra Mani College of Engineering and Technology, Amba. Please give them a big round of applause. Next, we have Mr. Atharva Anand Jogdev from PVG College of Engineering and Technology and GK Pate Vani Institute of Management. Please give them a big round of applause. Next, we have for the same paper, Mr. Atharva Malikarjun Atnorkar from PVG College of Engineering and Technology and GK Pate Vani Institute of Management. Please give them a big round of applause. Next, we have Mr. Action and Anil Samuel from FCRIT Vashi. Please give them a big round of applause. Next, we have Mr. Ketan Bajat from IIT Bombay. Please give him a big round of applause. Next, we have Mr. Mahadev Bapur Kumbhar from the Department of Technology, Shivaji University, Kolhapur. Okay, so sir is not there, so we'll skip it. Okay. Next, Mr. Santosh Kumar Murugadas from ANSYS Software Private Limited. He's our industry delegate. Please have a big round of applause. Next, we have Mr. Sarvana Balaji Manian from Kumaraguru College of Technology. There is not there. Okay, so we'll skip to the next one. Mr. Tanmay Konar, Indian Institute of Engineering, Science and Technology, Shivpur. So it's not there. Okay. Yes, sir. Then next we have Mr. Yusuf Mohammad Khan from AIKTC, New Panvel. Please give him a big round of applause. Next we have Ms. Pallavi Khaire from VJTI and from FCRIT. Please give her a big round of applause. Thank you. Next we have Ms. Pradnya Sonar from PVG College of Engineering and Technology and GK Patewani Institute of Management. Last we have Ms. Shamim Pathan from FCRIT Vashi. I don't think she's here with us. Oh, we'll have Prasid sir to collect it on behalf of Ms. Shamim.
Please put the big round of applause.
Thank you, sir. Thank you, Gambhir sir. Thank you. Next, we will have the distribution of token of appreciation for our corporate associates. I request Dr. Pine to come forward. First, we will have UE Systems Incorporated. Please give them a big round of applause. Without their help, this conference would definitely not have been possible. Please give your thanks.
The day we announced Invest 22, next day he came to sponsor.
Please give them a big round of applause. Thank you. Pine sir, next we have from Baker Hughes. Do we have the delegates from Baker Hughes? No. Okay. So next we have from Forbes Marshall. I think they have left. Okay, sir. So next we have from AIMIL. Yeah, we have ma'am. AIMIL, please. Please give them a big round of applause. Hello, sir. Yeah, thank you. Next, we have from ACOEM India. Please give them a big round of applause.
There are full member also.
Sir, souvenir also. Next, we have from NBES.
Everybody from NBES. NBES.
And finally, we have from Tribotech.
Tribotech India.
Tribotech India. I think we can definitely cheer more for all our corporate associates, sponsors, and our himself. This conference would not have been possible. Thank you, sir. Thank you, Pine sir. Next, we have the declaration of winners for the Best Paper Award and Young Researcher Award. I request Rajan sir to come forward to present these awards. These awards will include 5,000 rupees in cash and a certificate The certificate will be shared later. Today we'll be sharing the cash award. So we have for the best paper award, Dr. Minoru Sasaki from Japan, in the title of 3D vibration control of flexible manipulator using inverse system and strain feedback from Intelligent Production Technology Research and Development Center for Aerospace, Gifu University, Japan. Because he was joining us online, so will be able to share the prize with him. And the Young Researcher Award, we have Mr. Axon Samuel for the title Investigation of Effect of Porous Material on Performance of Helmholtz Resonator from the Department of Mechanical Engineering, SCRIT Vashi. Axon will be receiving a cash prize of 5,000 rupees award and a sapling. Congratulations to both of them. Congratulations, Axon. So thank you, sir. Next, we will ask for feedback from our delegates who have been part of the two-day conference. And if you can either just raise your hand or you can come forward to the sir. If you would like to come here, please, we can definitely ask you to talk with us. Sir, it's okay, sir. So you can come here, sir. It will be so you can address the gathering.
Yeah, thank you very much for giving me this feedback opportunity. First of all, I thank CVS for organizing this first and very nicely arranged conference. Some feedbacks, I think, of course, I'm also in the Bangalore chapter, this one, in the Bangalore chapter, but my feedback is, of course, this is a first conference and there are certain shortcomings. We accept it, and this is how we have to learn and go about. What I feel is that the time duration given for each speakers of 10 minutes, I think it will be too short because introduction and other things. At least what I feel, they should be given at least 20-25 minutes of time. And prior recording of the presentation, video recording would have been better so that they can squeeze the presentation, whatever the important information they want to pass within that period, so that we can maintain the tight schedule without going over. And then the segregation of topics, maybe from academic one part and then from industries the second part, so that interested people can participate and discuss on the issues, because some are purely academic in nature and some are purely applied and related to the engineering. We can segregate on that part. And maybe one thing I noticed is on the aspect of noise. Of course, we are all vibration specialists, but noise nevertheless comes along with the vibration if you want it or not. So there are very, except for one presentation, there was not much on the noise aspect, which is also relevant to the vibration, I think. So we need to include that also so that we can expect more people to contribute. This is my feedback. And we will also, it's not that I'm giving a suggestion to this one, because as a member of the organization, I am also into that. So maybe we will take it in a positive way and see to improve all this aspect in the forthcoming conferences. Thank you very much.
Thank you, sir, for your feedback. Is there anybody else?
Anybody from corporate associates?
Anyone? Yeah. So, ma'am, you can take. You can come. Yeah, you can come here also. It's your wish.
First of all, good evening, everyone. I think lot of efforts have been on this particular event, what we have seen in the last 2 days. And I think a lot of efforts have been put by the organizers, especially Dr. Pine. I think all of us will agree, and a huge round of applause to him, please. Because I have seen his dedication, even as we as corporate sponsors, but the kind of communication he was having with us, I think it will be the same for all the participants who are present here. So, any event which we organize, it requires a lot of dedication from the organizing team. I think the students of this institute, last 2 days, and I think before that also, for organizing this kind of event, it requires a lot of, teamwork. And this particular conference has given a lot of exposure to all of us. If you see, most of the dignitaries in this field have participated, and we were able to, get their, we had a lot of knowledge sharing sessions, and many dignitaries in the field of noise and vibration are present here today on the stage and down there also. And I agree with Sir, as Sir said that yes, noise is not included, but yes, it is the topic today where people are working for. Currently, there are no regulations in India related to noise, so maybe it is a left out topic, as I understand. But yes, with the dignitaries present here, we can consider noise also one more topic in this field. And once again, congratulations to all members here, and especially the students. I think they are getting a good exposure, and this is the next generation which will be taking the vibration from the older generation to the new generation. I think that is a topic. The time has evolved. The vibration subject has evolved from so many decades. And all the best to all of you. Let us together collectively pledge here that we will keep this domain alive, and we will take it to the next level. So thank you. Thanks to the organizers again for this wonderful session. Hats off to you all, sir.
Thank you, ma'am. And sir, please.
Good evening, everyone. I'm Dr. Venkat. I'm based in Dubai. I come specifically for this occasion. And I'm quite grateful to Dr. Gambhir and Dr. Pine for pushing me and encouraging me to join this. I'm basically an instrumentation person. Of course, I have my first experience is with a refinery where I have handled these vibration equipment, Bentley Nevada. That was my only experience in life. But I find this topic is very, very interesting. It's a niche topic. And hats off to you guys to have taken up this niche subject, which is probably the first time somebody has brought it to the fore to make it useful to the industry and also to the people who are in the vibration business. And I have a challenge to myself and also to Dr. Carr, who was here in my car, who is also from UAE, that we want to form a chapter for CBS in UAE, and our dream, bless the Almighty, that we want to convert Invest 24 in UAE. This is the challenge we take it, and I expect we will do it. And I'm 100% sure I'll have all the backing from the gentlemen who are sitting on the dais, plus the delegates who would like to come, and we will succeed. And I don't have any criticism. I always would like to leave it with a positive note that excellent, excellent, excellent. Done very well. Thanks to you all.
Thank you, sir. Anybody else? All right, sir. So we will go on to the next. Yes, sir. Gambhir will be making.
Standing by. I just wanted to use this opportunity before I announce something else. I wanted to thank, already vote of thanks will be there. And then thanking all the delegates and speakers and all. There are some people which should not miss actually. Actually, we have to round of applause for it to FCRIT and the team, Dr. Khote, Dr. Deshmukh, Mr. Asari, Neha, Deepak, Vikarni, officers, and of course the student who did a tremendous work. I can understand that they are doing academic studies, and along with this, the organizing committee. So many committees are formed, and we today signed so many certificates. I can see the amount of amount and the effort which has gone into behind all this. Sir, congratulations to all of you. Please look at team. I also want to. In fact, I saw many students when we were on the first day how to go to breakfast. They were physically standing over there and telling us the way of breakfast. Although there were signs, but they were physically putting effort. So that shows the system they have gone. Now here also we have seen how systematically they have done the work. How they got the papers in. They were standing by. They waited till the guest came on the top, and then they came on the stage. So the process and the procedures which are laid down by FCRT and the leaders are doing a great. This has been very. This is awesome. I must also thank the IT team who have done a great job in mixing everything going on in spite of so many challenges. We had a power failure, a small glitch, but they handled so admirably. I must really thank them for that. Coming after that, already Dr. Rao mentioned about 24 program. I want to announce a 23 program. So are we ready for 23? Yes. Oh, great. Thank you. So 23, my Bangalore team is charged up. They want to hold in Bangalore. So November first week after Dasara and before Diwali, maybe you can club it with your vacation in Bangalore and be there. And we will have a program first week of Bangalore. We hope and we request all the delegates who are here and others who are left, all our corporate sponsors, all our speakers and keynote speakers and organizers, please have faith in us. We have made some mistakes this time. Of course, we all make mistakes, but we have noted down our mistakes. We have also taken note of some feedbacks, and we will definitely do a much better job than what we did earlier. Thank you very much again. Bye.
Thank you, sir. We have one award left for the day. We'll now announce the winners of the lucky draw competition for both the days. I request that both the boxes to be brought in. I request Dr. S.M. Khote and Dr. Aklim Siddiqui. Two, sir. Sir, and each of the days we have 3 awards actually.
First day one.
So we'll open up the box from day 1.
But the award is for people who are here.
Here only. Okay.
If you do all that, they will not get.
Okay. Yes, sir. So the awards will be for the people who are here only. So Gambhir sir has spoken and we'll be following him.
And if not their second time, it will be
Yeah.
now.
Yes.
Two boxes are there. This is for the first day. That is for the
Second day.
first day.
So Aklim sir, the prize.
That coupon is there.
So we have a prize coupon for the winners. Aklim sir.
So for day one, it's Mr. Pranav Sharma. Are you there?
Okay, next.
From Adani Petrochemicals. Like Durga Rao from Pillai College of Engineering. Give him a big round of applause.
Thank you.
Mr. Aman Badela from RGIT, Rajiv Gandhi.
Oh, yes.
Mr. Aman from RJIT. Please give a big round of applause. The last one for day 1.
Swapna Singh from IIT Bombay. Swapna Singh.
Swapna Singh from IIT Bombay. Please give a big round of applause. This is it for the day 1. Now we'll go to day 2.
The first one for day 2 is Mr. Tejas Kulkarni, Assistant Business Manager from Avil Limited.
But Prachi, you can.
No.
He should be. Person should be there. So this is the person, not the individual. It is not rule. Okay, sorry. I'm sorry. You
lost, you can say.
Okay, this one is from IIT Bombay, Mr. Ketan Bajaj.
Please give a big round of applause.
3. Oh my God. 90%.
Unlucky person, his name is not written.
Sir, that's mine.
Anybody can write there. No.
Okay, that's SPR Automation, Mr. Sanjay Mishra. Mr. Sanjay Mishra.
He's outside.
Mr. Sanjay Mishra will here.
Oh, just he's our member. Yes,
Mr. Bimal Kumar Mohanty.
Sir. Lucky person.
Mr. Bimal Kumar Mohanty. Please give him a big round of applause. Okay. So one last.
From Tribotech, Mr. Srijit Nair.
Mr. Srijit. He's here. Yes.
You are Mr. Srijit.
Please give him a big round of applause. Thanks to all the winners. Thank you, Coach sir. Thank you, Akim sir. Next, we have one more announcement by Gambhir sir.
Yeah, as you know, our membership has crossed 150 in a year. And now we are getting nearly every day one member at least as an average member. And members' fees was kept purposely low so that people were encouraged to join. We encouraged to join quickly because our governing council has increased the fees from January beginning, a small about 10%. As you know, this money is not taken by any one of us as salary or as any income. You know, it is all going to the institution. It's being used for building the infrastructure of for offices for CBS in future. But mainly our intent is to spend the money on events plus training plus on students. Actually, we are subsidizing the students very heavily, and those fees are not being increased. Only for members they increase the fees. So whoever wants to become a member, we request you to fill the form and send to us before 31st of this month. Thank you very much.
Thank you, sir. Now we'll have our concluding vote of thanks by none other than Dr. Pine.
Last one, Sir.
Sir, the event begins and ends with you, sir.
Oh my God.
Good evening, everybody. And I'm duty now to be extended vote of thanks. Fantastic last 2 days, except on power failure glitch that created us little change of schedule. Otherwise, it was fantastic. However, we have enjoyed the session, all of us, and have taken the benefits of exhibited products and services by our corporate associates. First of all, we like to thank our corporate associate UV Systems, my friend here, Manoharji, Baker Hughes, Home Marshal, Ecoim India, Emil, NB Engineer Consultant, and Tripodic Solution, Daloji also here now, for your all the supports. Without you, this type of congregation won't be possible. We hope that that you will all continue to support us in future and become also corporate member. Those are yet to be. Each of the install has a lot of queries I've seen. We thank you, our eminent guest of honors, keynote speakers, authors, invited speakers, delegates from industry and academia for making this conference truly vibrant and in sharing your knowledge and new learnings. Our sincere thanks to all the students and researchers for letting us know their new research and innovation in vibration. We see a diverse aspect of vibration application in speeches, papers, networking talks, congruent to CVS objectives. We must thank FCRIT team management for all the supports, infrastructure, leadership, administrative help. Without them, we cannot host Invest 22. We are just a year age and last experience, our experience in this regard will help us in the next conference. We must thank all professors, students, Professor, especially I want to mention Dr. Aklim Saab, Dr. Neelaj Desmukh, Dr. Sanjay, and Dr. Sani, then Dr. Aslam, Asrani. They all day night, last 1 week were working. So special thanks to them. Without them, it's very difficult to put the schedule and speakers in order. All our outstanding and outstation founding fellows who have encouraged us and coming here all the way from various parts of the country. Some are accompanying their spouses. I was really thankful to you, sir. We like to specially mention the name of our governing council, like Dr. S.M. Khud, Dr. Gambhir, Dr. Engineer Uchil, who tirelessly last 1 month working to bring this to this level. Thank you, sir. Engineer Niranjan Bise, our live member of CVS, for his untiring efforts for putting the stalls, making our stage all right, in assuring other facilities like hotel and other things, and stage of our delegates as well as invited speakers and others. We thank you all session chairs and authors, our overseas keynote speaker who came online during even their odd hours in their country. So thank you all, sir. My sincere thanks to all online viewers in YouTube with little apology for disconnectivity for some time. Lastly, but not the least, our sincere thanks to all staff of housekeeping, lunch and snacks provider. They tirelessly, faultless, providing the supports. We have seen this in canteen and other areas and snacks and all, and in and out of the conference hall. Dear all, this is our first conference, and first step is always big difficulty. Please support us so that CVS can not only work but start running later. Even in past event, there are few high quality deliberations and speeches that convey various different application of vibration. This is encouraging indeed. That's why we want to see the vibration in this way. And that's very encouraging for us. Again, I thank one and all for making Invest 22 a success. Thank you very much for your time.
Thank you, sir. With this, we will end our valedictory session. I think we can have one more big round of applause. And I request, please wait, we'll end with the national anthem. I request the dignitaries on the dais to please come to this. So you can all come down and they will take a I request everyone to please stand. So he will take us. No, we want to pick first.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे